Okay, we're at the Museum of Developer Art, and I'm standing here with Alex, who actually curated the pieces we're about to take a look at. Alex, can you tell me a little bit about why you chose these pieces for a developer festival?
So the two artists that are here, Ezra Miller and Vincent Jose, are both developers themselves and artists. And so their work is really about using code to create beautiful natural simulations. Vincent creates fluid dynamics that are interactive, which is a very hard thing to do. And Ezra creates data visualizations that are essentially transforming into flocking starlings.
And why these pieces at this festival?
So I wanted to find artists that could understand the sort of developer mentality and communicate to developers and show that by using developer tools you can still create really beautiful work. So that's really the main reason.
Awesome. Well, we were looking at them earlier and that really comes through. Thank you so much.
Thank you.
I'm standing here with Vincent in front of his art. Now, I have a few questions. It's amazing, and I really need to know more. But first, can you tell me just a little bit about this piece? Your process making it, what you used, and what it represents to you?
So, this piece is called Fluid Structure. It's an exploration of how liquid-like form kind of deforms and react under various forces and stimuli. So I've been fascinated for a long time by fluid dynamics because it's like you see it everywhere in nature, like stream, rivers, smoke, volcanoes, and it's all this incredible variety of motion, very intricate. And historically it's been very computationally expensive, but now recent progress makes it possible to do the simulation real time, and that makes it very exciting for me to build interactive piece using this technology. Also to explore all kind of different how it's going to react, playing with different forces and what happens if we slow the time down or make it really fast. And I think it seems familiar and both mysterious because we're kind of used to how things react to physics laws. So I think one of the challenge for this piece was the scale and making it interactive for a large number of people. So it's using 5 different Kinects, which is a depth sensor that can tell me in space where the people are, and it's computing forces based on where people stand to push the liquid around, so that most people who are not always familiar with sensors and interactive installation would get it. There's little hints you're gonna see your silhouette and some modes where the water falls on you is easier to get your interaction and how you influence the result. And I think, and watching the people tonight, so it was a premiere for me as well to I tested with a few friends, but it's what are people gonna do and how they're gonna react, and a lot of people are really getting into it, and that's pretty amazing to see that.
Okay, so one more thing is that the size of this is massive. I don't know what your studio space looks like, but I presume you did some prototyping that wasn't this big before. How did you kind of conceptualize a piece this large?
So I was lucky I could prototype a smaller slice.
Okay.
And then I used VR and Oculus to kind of
Really?
get a feel for the scale of the piece, which I had done in the past for other art installations, which were also pretty big scale. And I'm based in New York, and so large space is kind of a rare thing to get.
Yeah.
So VR for me, it's really useful to get a sense of scale. And the other thing is that since everything is running real time, I have a number of parameters I can adjust quickly once I see the piece for the first time on site at scale, which I did tonight. So I slowed down something and tweak some timings to make it better. So that's the two way I worked on this scale.
Awesome. Well, thank you so much for sharing your art with us.
Yeah, you're welcome. Thanks. It's great to be here and have this opportunity. And thanks to Alex for curating this medium of developer art.
Thank you. Okay, now we're looking at the second piece, and this one is by Ezra. Ezra, could you tell us a little bit about this?
Yeah, so what we have here is my piece Data Memoration, which I built using WebGL. So it's just running in the browser. And it's a flocking simulation as well as a data visualization.
So one of the things that I noticed about the piece is that you definitely have something to say about the really clear data that shows up every once in a while on this graph, but then it breaks out all these data points into this flocking behavior. Like, what brought you to that artistic choice?
Right, so yeah, it oscillates between this sort of like formless cloud of birds swarming and then this really well-defined graph. I think to me it's sort of trying to get at questions about whether humanity can organize itself as we face a lot of problems as a society. And I think the difference between this like formless swirling cloud and that get at that idea. I don't know.
All right, man. Hey, let's talk a little bit more about the tech since we're at the developer conference. You said this is in the browser?
Yeah, so I make websites using WebGL. This was built with 3JS, which is a pretty, like the go-to WebGL library, and I use it out in all of my work pretty much. And it's built using shaders, which are programs that run on a computer's GPU that let you do computations a lot faster than on the CPU. And it's basically creating everything procedurally, which means there's no real image textures being used or any other real assets. I think the main asset is the data, and then everything sort of comes from that. So.
And I also noticed in addition to the flocking, there's this almost waterfall effect. What is that?
Right. I actually added that in like right recently before we set up. I think it just adds a little more dynamism to the background. Kind of cuts through the clouds, and it's a feedback loop process, which is something I use in all of my work pretty much. Yeah, I just thought it looked.
Leave it at that mystery.
Yeah.
I like that. All right, Ezra, thank you so much for sharing your work with us today.
Thanks, man. I really appreciate it.
Wow. All right, so I'm here at the VR Drive-In, and I'm standing with Sarah, who actually helped build the experiences that attendees are going through right now. Can you tell me a little bit about what they're experiencing?
Yeah, so we're Google Spotlight Stories, and we are creating content that directors create their own stories in this medium. So we have Pearl by Patrick Osborne, which was nominated for an Academy Award this year for Best Animated Short Film, and we have the Gorillaz' newest music video, which is a first music video for our group.
Now, you worked with the production teams and the artists in building these experiences, right?
Yes, yes.
What's that like? Do they have all sorts of questions? Like, what's different from a normal production experience?
Yeah, it's definitely a new medium for most people, but both took to it very well. So you have to think about creating a film in 360 space a little bit differently than you would a normal 2D narrative film. So you have to make it interesting in all directions, if you will.
Very cool. Sarah, thanks so much for joining us.
Thank you.
Got to be the largest foosball table I have ever seen. Look at this thing. Coming to you live from the World Championships of Pair Ping Pong here at Google I/O. I'm just kidding, we're having fun. All right, there's probably something I could say, but honestly, this is just mini golf, so I'm gonna go have some fun. What am I doing here?
All right, so it's a 360 video booth that records high frame slow motion. So anything that you do looks cool, it's gonna be, and you get to share it right away. Does that sound good? Yeah. All right, so the main rule is you don't leave the platform until I catch the arm, so you don't get hurt.
Okay.
Other than that, you can do anything that you want. You can jump, move. Moving quick is cool, standing perfectly still is cool. Either way.
But don't move slow.
Yeah, because it'll be kind of melodramatic.
So like a jump or something?
Be very, yeah, that'll be good. Yeah, you good to go?
All right, I'm just testing it out. I don't really know what's going on, but I'm gonna go with this. This is it. Woo! I am tuckered out. Thanks for joining me at the block party here on the first evening of Google I/O. We saw a lot of really cool stuff, and I hope you had as much fun as I did.
Good morning, everyone. Cool, first talk of the day. So, hi, I'll start by introducing ourselves. My name is Akshay Kannan, and I'm a product manager on the Android Auth team.
I'm Felipe Leme. I'm software engineer in Android Frameworks team.
Hi, I'm Simranjeet Singh Kohli. I'm software engineer in Android authentication team.
And our talk is all about Android APIs that you can use to improve sign-in, payment, and other key forms and experiences in your apps. So let's dive right in. Why are we giving this talk? What are the goals we want to accomplish with this? The first is to get more apps to use existing data from Android and to avoid prompting your users. Throwing up any kind of blank form in your app, such as an app login or a credit card, can create friction and result in drop-off when users don't know this information offhand. We've created APIs for you to automatically get this information when it's available, so that you can let your users skip past this step and get right to the stuff that actually matters in your app. Secondly, we'll talk about how you can provide a seamless experience and reduce churn when your users switch devices. Getting a new phone is awesome, but it can also mean that your users get locked out of or stop engaging with your app. Here also, we have a set of APIs to maintain your app state across devices. Let's start by focusing on how you can use existing information that the user has already provided to enhance your flows. The first feature I want to talk about is a new one. You may have heard about this in the keynote. Starting in Android O, we've added native support for password managers. This functionality is integrated tightly into the OS, so you don't have to rely on hacks like accessibility services or custom keyboards in order to securely fill in passwords, credit cards, and other information. We've partnered with Dashlane, LastPass, Keeper, and 1Password to support this feature when Android O goes out this year, and we're really excited about this. Of course, not everyone uses a password manager, but we still want all Android O users to be able to experience the security and convenience of autofill. So for those users, we're introducing autofill with Google. This feature comes bundled with Android O devices and lets you fill in passwords, addresses, credit cards, and other information that you already have saved to your Google account with Chrome Sync, all with a single tap. We've made a preview of this feature available to developers as part of the O beta, which you can play around with today and use to test out functionality for autofilling the logins in your apps. Support for credit cards and addresses is coming later this year, along with the consumer release. Let's take a look at what this looks like. Let's cut to the demo. So let's say that I'm logging into Twitter on a new device. I simply open the app, I tap Login, and you can see here that my username already auto-populates as a suggestion. I simply tap on that, my username and password automatically get filled in, I hit Login, and now, as you can see, I've been able to log into Twitter without pressing a single key on my phone. Next, I'll hand things over to Felipe, who's going to talk a little bit about how this all works and how you can optimize your apps as developers for autofill.
Thanks, Akshay. Guess the clap was for him or for autofill with Google, but pretty sure it was not for me. Anyway, the Android autofill framework was designed to work out of the box with existing apps without changing the apps to support autofill. In fact, for our Twitter demo, we just installed the existing Twitter app from the Google Play Store, and it just worked without any involvement for the Twitter developers. We hope this is going to be the case for most apps, but we still provide some APIs that you can use to make sure that your app integrates well with autofill. We'll see some of these APIs over the next slides, but first, let's take a high-level look on how autofill works, because that will make it easier to understand why using these APIs is important. So the autofill workflow involves 3 processes. In one hand, you have your app, which is the app being autofilled. In the other hand, you have the autofill service, which is the app that has the user data, like a password manager or autofill with Google. Then, in between them, you have the Android runtime system, which is a mediator used for privacy, security, and performance reasons. The whole workflow starts when the user selects an editable field on the app. For example, when the username view on Twitter was focused. So at that point, there is an autofill infra running on the app process, and that infra is going to create a customized version of the view structure that is optimized for autofill. Then it will send this view structure back to the Android system, where the Android system will sanitize the data by stripping out sensitive values. Next, the Android system sends the data to the autofill service. Now, here is the part where things get interesting from an API point of view. The autofill service will parse this view structure and will look for fields that can be autofilled. Then it will look on the user data for that app and see if there is a match. If there is a match, then it creates another data structure called dataset and sends that dataset over to the Android system. At this point, the Android system is able to autofill your app, but it doesn't do that without the user confirmation. So what it does instead, it shows an autofill dialog with the options sent by the service, and only after the user selects an option, we send the dataset back to the app, and then the autofill infrastructure will automatically set the views and change the background colors to show that the view was autofilled. So this workflow works pretty fast. It's pretty fast. Like we saw in the demo, the autofill dialog came out almost at the same time as the keyboard itself. But this workflow has a catch. It only works if the autofill service can figure out what can be autofilled in your app. Generally speaking, the password managers have good heuristics, and they can pretty much figure out how to autofill almost any app. But you don't want to rely only on their heuristics to make it work. It's better if you can tell them for sure what can be autofilled on your app and how. It's also nice to help the Android system to optimize the workflow by telling which fields should be ignored because they don't make sense to be autofilled. You can accomplish both these goals by simply annotating your active XML with autofill tags, as we're going to see in the next slide using a very simple login screen example. Okay. So this login screen has 3 editable fields. There's a username and password and a CAPTCHA challenge. The username and password are the fields that really make sense to be autofilled, while the CAPTCHA is something the user has to type in to make sure, to prove that the user is a human being, or a tree in this case, and not a robot. So without further ado, let's take a look at the XML. The first and most important tag you can use is called autofill hints. This tag tells the autofill service what is the meaning of our view, or what kind of user information the service can use to fill your view. For example, on our password field, there is only one way to fill that info, which it is using the user's password. So we say autofill hints equals password. But on our username, our app allows either a username or email address, but we don't know in advance which of these 2 informations the autofill service has. So it's better to give the autofill service a choice. So we put all values that possible here. So we say username, email address. The autofill hints can take any string. You could have something as bizarre as my dog's favorite color while on vacation in California last year during the drought. But these hints are only useful if the service understands what they mean. So we provide constants in Vue.java for the most common cases like username, email address, telephone number, credit card expiration date. So it's better if you try to use these constants instead. The next tag is called important for autofill. This tag is used by the Android system to optimize the workflow. So basically, it tells the Android system whether the view should trigger the autofill workflow and whether the contents of the view should be included in the view structure that's sent over to the service. So in our example, we can mark the CAPTCHA as the CAPTCHA edit test as important for autofill equals no. That means that when the autofill workflow is triggered by the username or password, we don't send the CAPTCHA over. So this might sound like a minor improvement, but remember, this is running on a mobile environment where every little optimization counts. In fact, there might be cases where the whole activity doesn't make sense to be autofilled. For example, in a spreadsheet editor like the one in Google Drive. In this case, you can mark the root view of your activity with the important for autofill equals no excluded descendants. And that pretty much is telling the Android system that no view inside that activity should automatically trigger autofill. Just keep in mind that the important for autofill is an optimization hint and not a way to effectively disable autofill on your app. The user can always bypass your decision, your hint, by manually requesting autofill. For example, the user can long press the text to edit text and then select the autofill option in the overflow menu. And when that happens, not only we trigger the autofill workflow, but we send over all views, including those marked as not important. So this is pretty much the two easiest way you can optimize your apps for autofill. There are other tags and Java APIs that you can use, but we didn't have time to show in the presentation. But they are available on the official documentation, on the official docs for the autofill. Now back to Akshay for more tips.
Thanks, Felipe. As we mentioned earlier, along with introducing the autofill framework in Android, we're launching our own autofill service that comes bundled with O devices, Autofill with Google. One of the nice things about Autofill with Google is that your data is synced between the Chrome browser and the mobile apps that you use. In order for this to work, you need to claim the association between your mobile app and your website. And you can do this using digital asset linking. If you've used other things like app linking in Android, you might be familiar with this already. Basically, for autofill, this enables any web logins that are saved using Chrome to work with mobile apps and vice versa. And basically, in order to make this association work, there's just two steps involved. So the first step is to host some JSON on your web server at yourdomain/.wellknown/assetlinks.json. And this tells us about the mobile apps that are associated with your domain, along with the permissions that you want to share with those apps. Here you explicitly define the permissions that you want to have shared. So in this case on the slide, there is the common.getLoginCreds permission, which enables your credentials to be shared from your website to your mobile app. And in addition to credential sharing, there's many other permissions that you can also grant to your app using this same JSON. For example, there's also the handle all URLs permission, which lets your app handle incoming web links via app linking, so that your users can seamlessly open links that your app was designed to handle. The next step, once you've hosted this JSON on your server, is to define the corresponding association in your mobile app. And you can do this by modifying your app's manifest. To enable credential sharing, you need to add the following metadata tag to your manifest. Here, Android string asset statements points to a JSON string resource that contains a list of web targets and permissions, similar to what you hosted on your website. And that's it. With these two steps, you can share credentials between your website and your mobile app. This works for autofill, and it also works for smart lock for passwords, which lets you automatically sign in your users. Now, I'm going to hand things over to Simranjit, who's going to talk more about how you can enable automatic sign-in for your users in further detail.
Thanks, Akshay. We want our users to get as much value out of their device as quickly as possible. A lot of that value is associated with their accounts. So we have provided a set of APIs to make user logins easy and seamless. The first one is Smart Lock for Passwords, which was introduced last year. The second one is Account Transfer API, which will be released in an upcoming Google Play Services update. There are benefits to each of them that we will look at as we move on. The first API we discuss here is Smart Lock for Passwords. It allows for automatic sign-in and skipping password forms completely. It syncs with passwords stored in user's Chrome profile. As a result, it persists across app installs. It has some differences from autofill. While autofill is only supported Android O onwards, Smart Lock is backward compatible with ICS and delivered via Google Play services. With Smart Lock, users can be logged into your app programmatically without any user input. Here, as you can see in the Netflix example on this slide, user did not have to do anything. They just open their Netflix app, Netflix makes the API call, gets the credential result, verifies the credential with the server, and signs in user automatically. In this case, login screen can be skipped completely. With autofill, user at least has to tap into the fields in order to populate them. Smart Lock also provides advanced security feature. There are two major flows associated with this API, retrieving credentials and saving credentials. Here's how to retrieve the retrieve credentials using the request API. If the credential was already available, you get success on the callback, and you can sign in user immediately, as was shown in the Netflix example in the previous slide. The other cases require user action, which are triggered by launching relevant intent. If the user has multiple credentials, they can pick the credential they want to use. If there are no credentials available, they get a dialog to select email address or phone number to sign in or sign up with. Here's an example of a save API. If the credentials were already saved previously and you are making a call to updating them, the callback results in a success. But to save a new password, the user must give consent for the credential to be saved. In this scenario, you have to call start resolution for result. Additionally, the responses from SmartLock API also includes a signed JSON Web ID token if Google has verified the user's email address. You can use this token on your server to verify users' email address and sign them in without a password. Or you can use it as a strong positive signal in anti-abuse algorithms. Also, check out the talk later today on PhoneAuth, which will cover a new SmartLock API to verify phone numbers via SMS messages. Now let's talk about a second API, the account transfer API. While setting up your new Android device, you might have seen the following flow, where it gives you an option to copy your data from your existing phone. Initially introduced at Tap and Go in Lollipop release, this flow allows you to copy your Google accounts from your existing device to your new device. We thought about how we can make it more seamless for our users to get started on their new device. And we came up with Account Transfer API to help transfer non-Google accounts also during the setup process. After you select that you are copying your data from another device, our flow kicks in. As you saw in the previous slide, Account Transfer API transfers credentials during the setup of the device. It's a device-to-device transfer. Some organizations don't allow the storage of their users' credentials on our servers due to the nature of their security policy. So in that case, this API is very useful. Also, there is no dependency on Google accounts. If you are an identity provider, this API provides a lot of benefits. It is only available to Android authenticators. Authenticators are apps which implement abstract account authenticator and integrate with Account Manager on the Android platform. Account Transfer API provides an encrypted channel between participating authenticators on a user's existing and new device. This encrypted pipe is established by Google Play services running on both these devices. Apps can do two-way communication over this encrypted channel if they are also present on the new device. But if the app is not present on the new device, transfer credentials are held in temporary storage. If your app is pre-installed on the new device, here is how it looks. You can send messages from source to target and from target to source, establishing a two-way communication. You can perform key exchanges or perform cryptographic challenge response flows. Google Play services running on both these devices notifies you of available data on that device via broadcast. However, if your app is not installed on the target device, the credentials sent from your app on the source to the target are stored in temporary storage. When your app gets installed and is opened for the first time, make a call to our API to retrieve the transferred over credentials. To participate in this API, you need to register these broadcasts in your manifest. This slide shows which broadcasts are active on the source and which ones are active on the target. If your app doesn't come pre-installed on any OEM system image, you only need Start Account Export broadcast. Here is a sample code that will be called on your user's source device. When source side broadcast is triggered, you should start a new service. In the service, you first get a handle to the API object, and then send the user credentials in byte format using the Send Data API. In case there is a failure, notify about it to our API. On the target side, you can retrieve the data that was sent over. Here also, when your broadcast is triggered, you should start a service. In the service, grab the API object, and then make the retrieve data API call and retrieve the byte data that was transferred over. Convert this byte data to your credentials using your custom logic, and then add the account on the device using Account Manager API. Finally, notify our API about success or failure. This is a simplistic example where only one-way communication is happening. Source sends the data, and target retrieves it. This is sufficient for many apps, like apps managing email, IMAP, POP3 accounts. The same code can be used if the app is not installed on the target and when the user opens the app for the first time. However, in this case, you can't send the data back to the source. Also, make sure not to call this API from your main thread. Now I will hand it over to Akshay to discuss Android Pay and backup APIs.
Thanks, Simranjit. So in the last few slides, you learned about how you can automatically sign users in using Smart Lock for passwords, or how you can securely transfer credentials from your old device to your new device using the upcoming Account Transfer API. Similarly, for payments also, we offer a set of APIs to help you get this information automatically on behalf of the user. And similarly, this also extends down to older Android versions, so you don't have to depend on your users running autofill on Android O. Currently, we have the Android Pay API today, which gives you Android Pay cards. But as you heard in the payment session, we'll be introducing the Google Payments API in the coming weeks to extend this API to include all of the cards tied to a user's Google account, not just the ones that they have using Android Pay. And best of all, there's no commission or fees involved at all in using any of these APIs. To make this work, there's basically 3 steps involved. First thing you do is you request a masked wallet. And that shows a dialog similar to the one in the screenshot you can see on the slide. And this lets the user pick a form of payment. Once they've selected one, you can handle the response from this and use that to present a final confirmation to your user, confirming the amount, what they're going to be ordering, and the method of payment they selected. And then once the user confirms this, you can request a full wallet. And what that does is that gives you the credentials that you need to complete the transaction. So that's it for payment APIs. So in the whole first part of this presentation, we've talked a lot about using existing information that the user already has provided to speed up critical forms and flows in your apps, whether it's logins or payments or anything else. In the second part, we're going to focus on using backup and restore to reduce churn when your users switch devices or if they reinstall their app on the same device. Even if someone's using a new device, our goal is to make it feel like they never stopped using your app. So as we mentioned before, throwing up a blank login screen the first time an existing user uses your app on a new device can create unnecessary churn and stop users from re-engaging. If they've already used your app, you can skip your welcome flow, pre-populate login information, and transfer over settings and any other states to give your users a warm welcome and a seamless transition onto their new device. The goal is to preserve as much of your app state as possible so that your users continue to stay engaged. We offer 2 APIs for doing this. There is the Auto Backup API, which, as you'll see in the next slide, is extremely low effort for developers. It's basically a line of code that you add to your manifest, and it backs up everything in your app wholesale. For more fine-grained control over exactly what gets backed up in your app, we recommend using key value backup. This works on Froyo and above, so pretty much all active Android devices today are supported, assuming a user has backup turned on. We'll talk through both of these APIs. We'll explain how you use them and talk through some of the trade-offs between them. Let's start by talking about the Auto Backup API. As we mentioned in the last slide, it's extremely low effort for developers to add to your app. You just add this single line to your manifest that you can see on the slide, and everything gets backed up wholesale, including shared preferences, your files, and your databases. In addition, you can also define custom XML include and exclude rules to control exactly what gets backed up. All of this data gets persisted in a private folder in the user's Google Drive account, which is limited to 25 megabytes per user per app. This doesn't count towards the user's drive storage, and only the most recent backup ever gets stored. So every time there's a new backup, it overrides the previous backup. That being said, auto backup is limited to Marshmallow and above. And if you want broader support or more fine-grained control over exactly what gets backed up, you're going to want to use the key value backup API instead. The Android key value backup lets you preserve your app data by uploading it to Android's backup service. The amount of data is limited to 5 megabytes per user per app, and it's available completely free of charge. There's basically 2 steps to make this work. You update your manifest, and then you write the code to do the backup. In the first step, where you update your manifest, you want to point to the backup agent, which in this case is my backup agent, which we'll define in the next slide. And you want to register for the Android backup service in the API console, which gives you an API key that you can copy-paste into your manifest. Next, once you've updated your manifest, you want to actually define your backup agent. And this is the code that actually does the backup. In most cases, rather than extending backup agent directly, you can extend backup agent helper and use the 2 included helpers that we've already provided, which are the shared preferences backup helper for backing up shared preferences and the file backup helper for backing up files. In the right, you can look at an example of what this looks like. Basically, in the onCreate method of your backup agent helper, you can instantiate one of these helpers with the name of the file that you want to back up, and then you call the add helper method, which adds this helper to your backup agent helper. If you need further control over versioning, file portions, or databases, you can extend the backup agent directly rather than using our included helpers. So that's backup and restore. In this whole talk, we've discussed a lot of APIs to help you streamline your apps, ranging from logins to credit cards to backup and restore. Our vision with these APIs is to lower the barrier for new users, and even existing users on an old device, to start interacting with and engaging with your app. We want to move to a world in which your phone knows more about you, and it can provide this information to other apps when you allow that information to be provided to them. We want to make forms a thing of the past. And as app developers, you should be able to tap into information that's already been provided by the user, rather than forcing them to type it over and over again just so you can get it. Especially with instant apps, upfront forms can significantly hurt the experience and increase the friction that's needed to try something new. So our goal with these APIs is for mundane stuff like credential entry to become a thing of the past. And if the user purchases a new device, we want this information to stay with them and move with them, so they don't feel like they're starting all over again. So just to recap the key takeaways from the whole talk, first and foremost, autofill is coming with Android O, as you saw in the demo. Please optimize your apps for autofill. You can annotate your XML using the hints that Felipe talked about. And also, you can use digital asset linking to associate your website and your mobile app so that credentials can be seamlessly shared between the 2. Second, populate credentials and payment information automatically when it's available. You can use the Smart Lock API to back up your username and password associated with Chrome Sync. You can use the Android Account Transfer API if you need a secure and encrypted pipe during device setup. And you can use the Android Pay APIs today and the Google Payments APIs in the coming weeks to get payment information from the user without any sort of commission. And thirdly, make sure you persist your app's data across devices. We talked about the auto backup APIs, which is extremely low effort and backs up pretty much everything in your app. And for more fine-grained control, we also offer key value backup. So this is a lot of APIs that we talked about today. We have a short link here on the slide that takes you to a doc where we've provided links to the developer documentations for each of these APIs so you can learn more. Thank you so much for coming out to our talk. Hopefully you'll check these APIs out and use them in your apps. We'll now open things up for Q&A. And also, after the session ends, we're going to be in the Android in Play sandbox for the rest of the day, so feel free to come by and ask us any questions. Thank you so much.
IndexedDB 2.0 standard is now fully supported in Chrome and features new schema management, bulk action methods, and more standardized handling of failures. Progressive web apps become more immersive with display full screen. Allow top navigation by user activation gives sandboxed iframes new powers, and there's plenty more. I'm Pete LePage. Let's dive in and see what's new for developers in Chrome 58. The structure of your site's database has large performance impacts and can be difficult to change. IndexedDB 2.0 changes that. Updates, object stores, and indexes can now be renamed in place after refactoring. Binary keys allow for more natural keys without worrying about performance penalties. Data retrieval is easier with getKey, OpenKeyCursor, and continue primary key methods. And bulk recovery of entire datasets no longer needs a cursor with getAll and getAllKey. When progressive web apps are launched from the Android home screen, they launch in a standalone app-like mode that hides the Omnibox. This helps create an engaging user experience and frees up screen space for content. However, for even more immersive experiences like games, video players, and other rich content, mobile UI elements such as the system bar can still be a distraction and take up valuable pixels that you may want. Now, you can make your progressive web app feel more immersive by setting Display Full Screen in your web app manifest. When your app is launched from the home screen, all non-app mobile UI elements will be hidden. Chrome 58 now supports the new iframe sandbox keyword, Allow Top Navigation by User Activation. When triggered by a user interaction, this keyword gives sandboxed iframes the ability to navigate the top-level page while still blocking auto redirects. And of course, there's plenty more. Say goodbye to the clear fix hack. Instead of manually resetting multiple layout properties like float and clear, you can now add a new block formatting context using display flow root. Pointer events.getCoalesced events allows you to access all input events since the last time a pointer event was delivered. Perfect for when you need a precise history of points for things like drawing apps. And workers and shared workers can be created using data URLs, making development with workers more secure by giving them an opaque origin. These are just a few of the changes in Chrome 58 for developers. Check the description for more details, including links to the docs and specs.
Hey everyone, Sam here. In this web series, we'll solve common web problems with standards. These techniques are part of the web platform and work with any framework or library. Okay, let's go. If you're animating some elements, whether you're using CSS, the Web Animations API, or libraries which just use Request Animation Frame, make sure you help your browser stay speedy by letting it use your 3D graphics card. Sam, what are you talking about? When you look at a website, it's made up of layers stacked on top of each other, and your graphics card won't need to redraw for changes to only some certain CSS properties, specifically opacity and transform. These two properties let you move stuff around and change how visible it is. You can animate, width, color, or other CSS properties, but do it sparingly and not in response to user action, where you want to be snappy. To keep things fast, if you have elements that move around a lot, you'll also want to set the will change transform or opacity CSS property. This is a hint to the browser. This element should be a layer all the time. Otherwise, when you upgrade or downgrade to a layer, you incur a cost. The browser has to redraw that specific part of the page. But if you give everything in your page a layer, this might bog down your browser as it struggles to compose them all together. This is a complicated topic, and you should check out more documentation to learn more about it. And most importantly, your site doesn't need to be perfect. It won't crush your user's experience to make a few mistakes here and there, but it's good to keep on top of it. Check Chrome's rendering section inside Developer Tools once in a while just to see what's happening and how your site's going. This was Layers the Standard Way. See you on the next tip.
The only thing that evolves faster than technology is our expectations. We want everything. Better, easier, now. Suddenly, downloading an app feels like it takes forever. And in many parts of the world, data is still at a premium, with 1 megabyte costing up to 5% of a monthly wage. Let's face it though, until now, the alternative to native apps hasn't been great. But that was then. Progressive web apps can now deliver mobile web experiences with a native look and feel, offering features like real-time push notifications, adding a site to your home screen so you can easily jump back to it with a single tap, even when you're offline. Plus the ability to make quick payments on the go. And all from your browser. This is the next generation of the mobile web. So what are we waiting for? Let's go and build something great.
We tend to talk about the web, and today I think is no different.
You think you can beat Wikipedia at a server-side render, do you?
I did.
With HTTP2, the rules all change.
One code base is not what you want, because then you end up with stagnation.
I've got one function that actually produces the other function. It's almost become self-aware. The code is now writing itself. What time does the game start?
LinkedIn is the premier social network for professionals. We are consistently one of the top apps on Google Play. My name is Pradeep Dash. I'm the engineering manager for LinkedIn infrastructure team for the flagship apps. We have 1 million+ reviews. We are consistently 4+ stars. Our users are really appreciative of how stable the app is, how it really helps them bring their professional profile forward.
My name is Drew Haney. I'm on the Android infrastructure team at LinkedIn. My team is responsible for the overall health of our Android application. We take care of releases to Google Play, our testing pipeline for the app, our build pipeline. One of the tools that my team has been excited about is the APK Analyzer tool, because we spend a lot of time paying attention to the size of our app, and it required some expertise to figure out what was causing your app to be a certain size. But now that we have the APK Analyzer tool, we've been able to expand that knowledge throughout the entire team. LinkedIn was an early adopter of Gradle, so adopting Gradle for Android was a pretty natural fit for us because we can share a lot of our custom plugin logic that we've built, and we can also get consistent builds across developer machines and our build servers. One thing that's really benefited us is the lint system, which has a lot of built-in checks for common problems, and we've really appreciated being able to write our own custom lint checks for LinkedIn-specific internal libraries. With so many developers checking into the code base, one thing that helps onboarding someone new is having a consistent code style throughout the code base. Android Studio lets us find a custom code style that each developer can add and automatically have their code formatted in the LinkedIn style.
One of the things that we really appreciate is the open nature of the platform, where not only has the feedback that we have given back to the developer community been accepted, but also being worked upon. In the last couple of years, my team has become way faster, much more agile, and being able to code easier and faster on the Android Studio.
I've been playing games all my life. It's my passion. I also learned how to program computers. And then in 2001, we started the first video games company for mobile phones in Spain called Microjogs. In 2013, my studio was acquired by a big company. Some of the guys and myself, we decided that we should do something fresh, something new, and we founded OmniRun. Titan Roll is a real-time strategy game. It's considered as a MOBA. MOBA is a massive online battle arena, but especially designed for mobile devices. The game is today as it is thanks to the Early Access program. We changed many things from the learnings from the community. Since we launched the game on Early Access, we got more than 2 million installs on Android devices.
We started in the Early Access program back at the very beginning of it. The difference between the Early Access program and a traditional soft launch is that users are actively giving the team feedback. So you don't only check the metrics you have, but they also provide possible solutions. So you end up by doing the game players wants to play. The thing about not having the ratings, but having the constructive feedback was very good. The early access was a great opportunity for an indie developer, someone starting, and very key for us in Omnitron. When we started with the early access program, we approached it in different stages. So the idea was at the beginning to focus on the engagement of the games. Once we sorted that out, we focused on the retention of the game. And finally, we focused on monetization to do a valid product for the market. We managed with the early access to improve our retention in a 41%, the engagement by a 50%, and the monetization by 20%, from the very beginning of the program till worldwide launch the game.
I feel very happy working on the video games industry because it has been my passion since I was a child, and it's really inspiring that through Omnitron we have a real chance to shape the new era of the video games.
In response to popular demand, the Android Framework team has written an opinionated guide to architecting Android apps, and they've developed a companion set of architecture components. Hi, my name's Lila, a developer advocate for Android, and I'm here to introduce you to these shiny new architecture components. Components persist data, manage lifecycle, make your app modular, help you avoid memory leaks, and prevent you from having to write boring boilerplate code. Your basic Android app needs a database connected to a robust UI. The new components, Room, ViewModel, LiveData, and Lifecycle, make that easy. They're also designed to fit together like building blocks, so let's see how. I'll introduce you with a new SQLite object mapping library. To set up the tables using Room, we can define a plain old Java object, or POJO. We then mark this POJO with the @entity annotation, and create an ID marked with the @primaryKey annotation. Now for each POJO, you need to define a DAO, or Database Access Object. The annotated methods represent the SQLite commands you need to interact with your POJO's data. Now take a look at this insert method and this query method. Room has automatically converted your POJO objects into the corresponding database tables and back again. Room also verifies your SQLite at compile time. So if you spell something a little bit wrong, or if you reference a column that's not actually in the database, it will throw a helpful error. Now that you have a Room database, you can use another new architecture component called LiveData to monitor changes in the database. LiveData is an observable data holder. That means it holds data and notifies you when the data changes so that you can update the UI. LiveData is an abstract class that you can extend, or for simple cases, you can use the mutable LiveData class. If you update the value of the mutable LiveData with a call to set value, it can then trigger an update in your UI. What's even more powerful, though, is that Room is built to support LiveData. To use them together, you just modify your DAO to return objects that are wrapped with the LiveData class. Room will create a LiveData object observing the database. Then you can write code like this to update your UI. The end result is that if your Room database updates, it changes the data in your LiveData object, which automatically triggers UI updates. This brings me to another awesome feature of LiveData. LiveData is a lifecycle-aware component. Now you might be thinking, what exactly is a lifecycle-aware component? Well, I'm glad you asked. Through the magic of lifecycle observation, LiveData knows when your activity is on-screen, off-screen, or destroyed so that it doesn't send database updates to a non-active UI. There are two interfaces for this, Lifecycle Owner and Lifecycle Observer. Lifecycle owners are objects with lifecycles, like activities and fragments. Lifecycle observers, on the other hand, observe lifecycle owners and are notified of lifecycle changes. Here's a quick peek at the simplified code for LiveData, which is also a lifecycle observer. The methods annotated with @onLifecycleEvent take care of initialization and teardown when the associated lifecycle owner starts and stops. This allows LiveData objects to take care of their own setup and teardown. So the UI components observe the LiveData, and the LiveData components observe the lifecycle owners. As a side note to all you Android library designers out there, you can use this exact same lifecycle observation code to call setup and teardown functions automatically for your own libraries. Now you still have one more problem to solve. As your app is used, it will go through various configuration changes that destroy and rebuild the activity. We don't want to tie the initialization of LiveData to the activity lifecycle because that causes a lot of needlessly re-executed code. An example of this is your database query, which is executed every time you rotate the phone. So what do? Well, you put your LiveData and any other data associated with the UI in a view model instead. View models are objects that provide data for UI components and survive configuration changes. To create a view model object, you extend the view model class. You then put all of the necessary data for your activity UI into the view model. Since you've cached data for the UI inside of the view model, your app won't require the database if your activity is recreated due to a configuration change. Then, when you're creating your activity or fragment, you can get a reference to the view model and use it. And that's it! The first time you get a view model, it's generated for your activity. When you request a view model again, your activity receives the original view model with the UI data cached, so there's no more useless database calls. To summarize all of this new architecture shininess, we've talked about Room, which is an object mapping library for SQLite, Live Data, which notifies you when its data changes so that you can update the UI, and importantly, it works well with Room so that you can easily update the UI when the database values change. We've also talked about lifecycle observers and owners, which allow non-UI objects to observe lifecycle events. And finally, we've talked about view models, which provide you data objects that survive configuration changes. Altogether, they make up a set of architecture components for writing modular, testable, and robust Android apps. You can sensibly use them together, or you can pick and choose what you need. But this is just the tip of the iceberg. In fact, a more fully fledged Android app might look like this. For an in-depth look at how everything works together and the reasoning behind these components, check out the links in the description below. To jump straight into code and get started working with these objects, you can check out the code labs and samples for lifecycle and persistence. Happy building, and as always, don't forget to subscribe.
I'm Wojtek Kalicinski, this is Android Tooltime, and let's talk a bit about the Espresso Test Recorder and how it can help with adding UI tests to your app. But first, a short explanation for those unfamiliar with Espresso. Espresso is a testing framework designed to provide a fluent API for writing concise and reliable UI tests. However, it is often the case that developers are reluctant to add UI tests to their apps, or simply don't have time to learn the framework. This is where the Espresso Test Recorder comes in. It lets you create and add UI tests to an existing app in an interactive way. You may have previously seen the beta version of this feature, but in Android Studio 2.3, we are promoting it to stable with a few enhancements. To get started with the test recorder, click on Record Espresso Test under the Run menu. The device selection dialog pops up, and after you make your choice, the test recorder runs your app in debug mode. Simply progress through your app's UI as a regular user would, by clicking buttons, swiping, and typing into input fields, and all those actions will appear in the test recorder window. You can also click here to add an assertion to your test at any time during recording, which will trigger the test recorder to dump the current view hierarchy. To select the view you want to assert on, click on the screenshot that appears in the recording window and choose between the assertion type from View Exists, Doesn't Exist, or check that it contains the specified text. When you've finished recording your test, the test recorder generates the equivalent test code to run your actions and assertions and puts it in a new file in your project's instrumentation test folder. It also checks if your build file contains the required Espresso dependencies and adds those if needed. When you look at the source file that Espresso Test Recorder created, you will see that it's perfectly normal, human-readable code, so if you need to further customize your tests or alter them when your app changes, you can simply open the file again and make the alterations you need. As you can see, the Espresso Test Recorder is very simple to use, but it does come with some limitations. As of Android Studio 2.3, only a few most common assertions are available through the Recorder UI, so if you need anything more complicated than that, you will need to edit the generated code by hand. Also, at this stage, the test recorder cannot handle all situations where additional synchronization is needed to deal with delays and async operations in your apps. I highly recommend getting familiar with the Espresso Idling Resource API and using that in your tests to signal when a long-running operation happens. For advanced users who want to tweak some aspects of test code generation, there's a settings page for the test recorder in Android Studio Preferences. Here you can change the maximum view hierarchy depth that will be used for view identification, and if app data should be cleared every time you record a new test. The Espresso Test Recorder is a great way to start adding tests to your app, whether you want to learn Espresso by examining the generated code, or simply to quickly build a test suite which you can customize later. We look forward to your feedback on our social channels, and happy testing!
Hi, Timothy Jordan, your friendly developer advocate here at Google I/O 2017. I'm in the machine learning area, and we're going to check out a lot of really cool stuff. A reminder before I get to it, if you'd like to see any of this footage or any of the other sandbox tours that I've been doing, go to g.co/io/guide. First off, I'd like to check out the Cloud TPU in person. Wow. So much heat sink.
This looks like a skyscrapers. It's like a miniature city down there.
This is seriously one of the best Tron moments I've had in years.
This is among the most amazing things I've ever seen in my life.
Okay, Magnus. Everybody, this is Magnus. You may know him from, well, being Magnus and all sorts of things. Hi, Magnus.
Hi, how are you?
I'm doing super well. So you've been hanging out with all this really cool machine learning stuff all day long.
Yeah, that's right. We've been here all day doing different machine learning stuff.
I'd like to check out some of it and just play with it.
Okay.
Let's try AI duets first. So what is this?
So you can actually play on these things, and then the network generates something back. Yeah.
Okay, so it's kind of like the machine playing music with you.
Yeah, it's kind of constructing music based on what you play. It's trying to create something similar, but still different.
Okay, I want to try it out.
Yeah.
That's a lot of fun. It feels a little like that scene in Close Encounters with the Third Kind.
Yeah, absolutely.
All right, so there's one other thing that I would like to check out while we're here, and that's the candy sorter.
Yes, it's an amazing thing. It consists of so many different machine learning technologies in one single demo.
Shall we check it out?
Yeah, for sure.
As promised, we're going to check out the candy sorter. What is a candy sorter, you may ask? Well, Dave's here to tell us what that is.
Okay, great. So what we're going to show here is how you can infuse machine learning into your apps without actually being a data scientist. And the way we're going to do it is through Candy and through labels. Now, what we've done is we've trained a model up in the cloud that for basically we've taken an existing model and we've trained it for candy. So we've put labels and next to candies. And we've got a little camera here that's taking pictures of the candy, and we put labels that have been associated with the candy. We sent it up to the Google Cloud Machine Learning Engine, and we've trained the model. We used the Inception v3 model, and using transfer learning. And so what we're going to show now is, now that the model's been trained, is actually the serving of the model. So I'm going to take candy here and just throw it out in front of the camera, and this is just any random candy that we have trained this model for. So I like gum. I want to make sure there's plenty of gum out there. And you'll want to make sure there's a little bit of space in between here. Again, when we train this image, it has been a well-trained model that has been modified with these images and these labels. You can even write your own labels, which is awesome. So now it's trained. Now the fun part of this is actually the serving, the prediction. So you're going to speak into this mic, you're going to hit this little mic button here, you're going to speak into this mic and ask for some kind of candy. And it's going to make a call to our API, it's going to understand the text, it's going to do a speech API, so speech to text API, and then it's going to understand the intent of what you're asking for using our natural language processing API, and then it's going to make a prediction based upon the model that's sitting out in the cloud. And the best part is, hopefully, cross your fingers, it's going to make the prediction, pick it, and then give it to you.
Awesome. Okay.
All right, so click on that and speak into the mic.
May I have some gum?
So it understood what you said, may I have some gum? Now it's going through natural language processing, it's identifying the noun there, and gum, so now it's it will then match based upon the model that's been modified. Come on, come on, come on. And it is picking chewy gum. Oh, and there the camera identified extra long-lasting watermelon gum. Now the camera's and over, and there's your gum.
That's great.
Machine learning in an app.
So I get to keep this, right?
Yeah, actually, I've got like 7 boxes back there, so please everybody take one.
Dave, thanks so much.
All right, thank you.
That's pretty great. All right, so that is the machine learning area. I hope that you've enjoyed these experiences as much as I had. It's really cool to see machine learning up close and personal, see how it can be used in real life through these demos. And I hope it inspires you to do some cool stuff with TensorFlow Cloud. See you later.
Hello, everyone. I'm David Sayre. I'm the lead of the Mountain View Android runtime team. We're the folks that build the code that runs on your phone and loads your applications, runs them, and manages their memory. So last year, our team presented the evolution of art, and we described some of the techniques we're using in the runtime and how you can really see the goodness that we bring. Last year, we talked about profile-guided compilation, how you can make your app experience better by understanding how programs run on your phone. We talked about how important it is to keep memory usage down and to make memory allocation blindingly fast. And we talked about just-in-time compilation and how we can get great performance from your applications without the annoying optimizing dialogue. So you heard last year about how great things are, but it was just the beginning. Now that your phone knows more about how your applications execute, we can focus on loading only the parts that are important to you, so apps load faster and use less memory. And speaking of less memory, we've made your applications spend less time reclaiming and even less time allocating memory. And of course, with the just-in-time compiler, we can focus on making your applications run even faster. Nicholas and Art will be talking to you in just a moment about that. You'll notice I mentioned using less memory twice. So let's start by talking about that. I'm going to begin by talking a little bit about how we rearrange your application to use less memory. And then Matthew is going to tell you about how we improved our heap sizes, reduced the jank, reduced the pause times, and have even better allocation times. First, a little review of how Android applications work on your Android phone. An application comes in an APK file, which contains one or more DEX files. These contain the instructions for executing your application. Art uses the DEX files to get information about instructions to run, strings, class relationships, and lots of other things. And the DEX files are loaded into memory by Art. Loading these files has both a RAM and a startup time cost. So when you run, for instance, Maps, one of our favorite applications, your phone reads the DEX files into memory, and you can see amounts to thousands of pages. Multiple megabytes worth of information are loaded into memory. Now, the DEX files were produced by a developer, and the typical developer tools don't really know about the use cases that are going to be important to you on your phone. So the DEX files may have unimportant things on the same pages as important things. Like, for example, the way you use maps, you may only use some of the methods that were in the DEX files. Or some of the strings that are there are not seen in your use case. As I told you before, in Android N, Art introduced profile-based compilation. In Android O, we have clever new uses for this. Several clever new uses, in fact. But one of the ones I'm here to talk about is improving the DEX file locality. The idea is simple. Use the JIT profile information to move the important things, the things that have been used by you and your usage of the applications, closer together. And this is all done seamlessly and transparently to the user as we compile applications on the device. So after we run your application once, at least, to collect the profile information, we use information about what parts of the application were important to you. We gather the important methods together and leave the unimportant methods together. And as you can see on the right there, a lot fewer pages are accessed, especially the methods, when we use profiling information. Now let's take a look at what type of RAM improvements we see after launching a few apps, a few of our favorites again. As you can see, there's a significant reduction, typically around a third in these applications, less memory used by DEX after layout. This RAM reduction also improves launch time on devices that have slower flash because you're pulling in fewer pages and hence spending less time paging applications off of the flash. So that's it for my part. Now over to Matthew, who's going to tell you about our new garbage collector.
Thank you, David. Another thing that saves RAM is the new concurrent and copying garbage collector. Now, Android has had a compacting garbage collector that runs for background apps since Android L. But unfortunately, since this collector was non-concurrent, it meant that there was a GC pause for the entire duration. So basically, the problem with having a GC pause for the entire duration of the GC is that it can last hundreds of milliseconds, and this would very likely cause jank for foreground applications. In Android O, Art now concurrently compacts the heaps of background and foreground applications. This enables compaction of many long-lived applications, such as the Android system process and Google Play services. Since these processes were long-lived, they tended to have a high fragmentation over the time that they were executing. Let's take a look at the GC process. Unlike its predecessor, the new GC is region-based. Starting out, the GC does a brief pause to identify which regions we are going to evacuate. These regions are also known as the source regions. Threads then resume from the pause after having walked their stacks. Next up is the largest phase of the GC, the copying phase. In the copying phase, reachable objects are copied from the source regions to the destination regions. Finally, in the reclaim phase, the GC frees the RAM for the source regions. Starting with the pause phase, the pause is pretty small, and during the pause, one of the key steps is identifying which regions to evacuate. The goal of evacuation is to copy all of the reachable objects out of regions with high fragmentation. After this is accomplished, the GC can release the RAM for these regions. In this example, the GC picks the middle two regions as the source regions because these both have more than 20% fragmentation. Next up is the copying phase. In the copying phase, the GC copies all reachable objects from the source regions to the destination regions with the goal that no objects will reference the source regions after collection is completed. The GC also updates the references to these regions to point to the new addresses of the objects. Now, since application threads are running concurrently during the garbage collector, the GC needs a way to make sure that these threads don't end up reading a field that points to a source region. To accomplish this, the GC uses a technique called a read barrier. A read barrier is a small amount of work done for every field read. The read barrier prevents threads from ever seeing references to the source regions by intercepting the reads and then copying the objects to the destination regions. In this example, there's a thread attempting to read foo.x. This is a reference to a bar object in the source region. The read barrier intercepts this read, copies the object to the destination region, and also returns the new address. The copying process continues copying moving objects as well as doing read barriers if necessary until there are no longer any references to the source regions. At this point, the GC begins the reclaim phase. As you can see here, there are no longer any references to the source regions, so the garbage collector can free all of the RAM for these regions. And what we are left with is a heap that has much less wasted RAM compared to when the collection began. Now, you might be wondering, how much RAM can we save by compacting foreground applications as well as background applications? Well, the average heap size is 32% smaller compared to the Android N concurrent mark sweep garbage collector. And RAM loss to GC overhead is also a little bit smaller. One important factor about concurrent garbage collectors is how long application threads are suspended. Every millisecond that the threads are paused or suspended is one less millisecond to prepare the next frame for the UI. With the new GC, the average pause time is 0.4 milliseconds compared to 2.5 milliseconds in Android N. And the 99% worst case for large heaps is 2.6 milliseconds instead of 11 milliseconds in Android N. Finally, always compacting the heap has enabled ART to switch to a new thread local bump pointer allocator. This allocator is simpler and faster than the free list allocator it replaces. Overall, this means the allocations are around 70% faster compared to Android N, and if you go further back, allocations are 18 times faster than KitKat on a device-adjusted basis. And now, off to Nicholas for other optimizations.
Thank you, Matthew. So besides managing application memory, ART is also responsible for executing application code. And for every Android release, our team spends a significant time optimizing wherever we can. So in this talk, we wanted to share with you two major accomplishments we've made for this release. The first is a performance case study, and the second is about a new optimization framework for loops. Let me start with the performance case study, and then Art will later talk about loop optimizations. So to validate all the optimizations we do, we have our own benchmarks, where we look for regressions and improvements. But we also want to make sure that optimizations do matter for real Android apps. So for the O release, we have invested our optimizations on one of our Android applications, Sheets. Over the years, the R team and the Sheets team have worked on benchmarking the core computational logic in the Sheets app. Our Sheets benchmark suite is composed of three kinds of benchmarks: benchmarking low-level runtime capabilities, core Sheets formula evaluation, and benchmarks that shuffle run themselves. And we're very excited to share with you that in Android O, we've made significant improvements to Art's runtime and compiler, up to the point that we are now running 8 out of the 9 benchmarks in Sheets from 2 times to 3 times faster compared to our previous release, Nougat. You may remember a similar graph than this one that we presented at the keynote 2 days ago. This is actually a snapshot of our benchmark monitoring tool, where we track over time the impact of each individual change we do in Art on our benchmarks. For this graph, what we see is that the Sheets aggregate score keeps on improving month after month between the two Android N and Android O release. So let me pick and explain to you the major improvements we've made for O. So one major change is, of course, the new garbage collector that Matthew just introduced. Overall, it improved the performance of Sheets by 40%, thanks to thread local allocation buffer and faster collections. The next major improvements we made is our inliner, which gave us another 20% boost. And this optimization was probably the easiest optimizations we've made. because we already had an inliner in N. But what happened in N is that now we're doing all the compilation in the background, and we only compile important things. So we can avoid the code bloating when we inline. With those two improvements implemented in N, it was a lot easier for us to do a more aggressive inlining for O. So for example, we now inline across DEX files, we inline methods which could end up throwing, and we give a much larger inlining budget, so more methods get inlined. So now let's move to an optimization that did require some work and helped us increase the sheets code by 15%. That optimization is called code syncing. It's an optimization that essentially moves instructions next to instructions that actually use them. So typically what you want to do is instructions that are rarely being used, you want to move them closer to where they are used. So instructions that are not in the regular flow of your application, you want to move them to the exceptional cases. That's fairly abstract, so let me give you an example to make it more concrete. Here's an accept of sheets code. There's a method called createRange, takes two integers, and returns a new range. The createRange method calls a helper method called checkCondition that will check the required conditions for creating a range. If those conditions are not met, we'll throw an error. Notice how the checkCondition is a var method. And this is important to notice, because it will affect the code that is being sent to our runtime. Here's how. So you start with a simple method. The Java compiler actually desugars the var args call to allocating a new object, allocating a new array, putting in that array boxed versions of start and end, and then passing this array to checkCondition. And this isn't Android specific. This is what the Java compiler does when it compiles to bytecode. And these instructions are not completely free. Yes, we made allocations extremely fast with the new garbage collector, but having to create this array and the boxed versions of start and end all the time the method is executed is not really ideal. So here's how we avoid executing it completely. First, we can easily inline the call to checkCondition. So internally, this is how the code is transformed in art. Notice how args now is only used in the if branch. So what the compiler can do is move the allocation and the boxing closer to where args is being used in the exceptional flow. So at the end of this optimization, what the compiler has made sure of is that only the required instructions will be executed in the normal flow. The last optimization I wanted to mention here is class hierarchy analysis. Class hierarchy analysis is a pretty common technique in object-oriented language. While at runtime, we'll try to infer classes and methods that can be made final, even though they aren't marked as final. Having this information internally gives a lot of room for the compiler for more optimizations. For example, you can do more inlining. And because Java has dynamic class loading, we will build out of these optimizations if suddenly a new class gets loaded, and all the optimizations we did by inferring final classes and methods become invalid. So this sums up the optimizations I wanted to talk to you about. For the record, we also did a bunch of other improvements for this release, such as faster type checks, faster access in compile code for classes and strings, faster JNI transitions, more compiler intrinsics, and a lot more where I did not have the space to list here. So for the interest of time, I'm not going to go into details on these optimizations. Instead, I'm going to hand it over to Art, who is going to tell you about a whole new set of loop optimizations.
Thank you, Nicholas. So if you don't look at virtual method overhead or general runtime overhead, programs tend to spend most of the time in loops. So besides all the good stuff that Nicholas already talked about, it can really pay off by optimizing loops specifically. And I will discuss some of these in this part. Optimizations really always consist of an analysis part where you look at the program and an optimization part where you actually perform the transformations. And you can see here like a list of all the work we did for O. But I'll only touch on a few of those in the interest of time. But before I do that, let's first look at what loop optimizations can do for you. So here you see a graph that plots Android O versus Android N performance, so higher is better. And the color encoding shows you specifically where loop optimizations in general, the blue stuff, has helped, and the red stuff where factorization, which I'll talk about briefly, has helped. And you see that benchmarks on the left, like loop and sum, really get unrealistic high speedups. And it is really as a result of that we broke the benchmark. So we were able to transform loops into closed form expressions that execute really fast. And although that's always nice to have the ability in your compiler, it's not very realistic. But as you go to the right of the graph, you see more realistic speedups. Like LU and Linpack obtained like 10% improvements by factorizations. So central to all loop optimizations is always induction variable recognitions. And that consists of finding expressions that progress in a regular and predictable way in your loop. And the most common example is a linear induction. So here in this example, the basic loop counter I is a linear induction, but also the expression j shown in blue is a linear induction. Every time around the iteration, it increments by a loop invariant constant. There's many more induction variables, and you see some of them depicted here in the graph. And detecting as many of them as possible is always good for the next phase, the actual optimizations. So let's look at what loop optimizations can benefit from induction variables. So here you see a somewhat synthetic example where the compiler can easily see that in the innermost loop, the increment to sum actually is very predictable. Since the loop only iterates 100 times, it can actually replace the sum, hoist it out, with a closed form expression that just adds 100 at a time. After you've done that, you can actually hoist it again out of the next loop if you take a little bit care of the fact that the loop may not be taken when n is negative. So after that, the whole computation has been hoisted out of the loop, and the whole double loop can be eliminated. So in this case, the whole loop is replaced by a closed form. And that's one of the examples that I showed at the beginning where we broke the benchmark. Obviously, your code will probably not benefit this greatly from optimizations, but having this ability can really kick in like after you inline library code, not to the same degree, but it's still nice to be able to optimize your induction variables. Another example where induction variables can help you is with bounds check eliminations. So when you access an array, you always need a test to see whether the subscripts can go out of bounds. And if they do, you throw an exception. But if you know the exact range that induction variables will take, you can often eliminate those tests completely. So here you see an example that both the access to A and B will never go out of bounds. So the compiler can statically remove those tests, and the program, as a result, will execute a lot faster. Induction variables also tell how often loops iterate. So if you know that it is only a few times, you can actually completely unroll the loop. And the advantage of unrolling is that you completely remove the loop control overhead. It reduces the code size because you don't have the control to iterate. And it often enables like constant folding. So you see an example here where the blue part shows that the loop only iterates from 10 to 10, so it actually only iterates once. So you can replace the whole loop with a single statement, and as a result, you can also constant fault the multiplication and already do that at compile time. So the program will run a lot faster. Again, typical code won't optimize right away, but after inlining or other forms of specializations, these situations occur, and they can help improve your performance. So the last loop optimization I want to talk about is the ability of Android O to take advantage of SIMD instructions. So SIMD instructions are instructions that perform a single operation simultaneously to multiple data operands. So you see an example here where one instruction actually does 4 additions at the same time. And all our target platforms, ARM, Intel, MIPS, they have such instructions. And if you take advantage of them, it can greatly improve the performance of certain classes of programs. So converting sequential code, and we typically focus on loops, but it doesn't have to be restricted to that, into code that exploits the SIMD instructions, that process is called vectorization. And it's illustrated here where on the left you see a loop that iterates sequentially, and on the right you see the vector loop that actually goes by 4. And in order to do this transformation, this vectorization, you need some very specific analysis. You have to detect and resolve memory conflicts between the loop iterations to see if you can actually execute them in parallel. You may want to be a little bit more strict about alignment, because SIMD instructions often require stricter alignment on the memory. And you want to detect idiomatic constructs. We'll see an example of that shortly. Stuff that you cannot really express with single operators in your sequential code, but if you detect them, you can map them onto very efficient SIMD instructions. So let's just explore this whole vectorization with a case study. Suppose that you want to display a stream of pictures, like these paintings here on the graph, on your display, and you want to transition smoothly from one picture to the other. You don't want to just show one and then the other. You want to sort of have a transition in between. And you want to do that real time. You don't know the stream in advance. And of course, you want to do it in an efficient way. So one way to get a smooth transition is actually performing a crossfade. So what you do is, it's called a rounding halving add. So basically you take the average of 2 pictures and you show that in between the 2 pictures. So the example here, you see the shipwreck on the top and the quiet fire on the bottom. And the picture that you show in between will sort of be an average of the 2 pictures, showing them at the same time. It forms a nice, smooth transition. So how do you code it? And you don't want to go to a native solution. You don't want to use the NDK. You don't want to use GPU code. You just want to stay at source level. So here you see a method that could do such a crossfade. So you have 2 incoming byte arrays, which represent the pictures, x1 and x2. And you go through like a 0 extension and an averaging operation, and then you compute the x out. So keeping this at source level is, of course, a much easier way of expressing such an algorithm. It's easier to write, test, debug, maintain, etc. You don't have to use the NDK, you don't have to use GPU code. So Android N will actually translate the loop that I just showed to the sequential code on the left, and Android O will now generate the SIMD code shown on the right. And I don't expect you to grasp this whole assembly right away, but just focus on the parts that have been highlighted. So first of all, in orange, you see that the sequential loop goes by 1. It does 1 byte at a time before it goes to the other one. In contrast, the SIMD code goes by 16. It does 16 bytes at the same time. The other thing that you notice is that the loop body is a lot shorter for the SIMD code. And that's a result of the yellow highlighted instructions. On the left, there's a lot of instructions required to do the 0 extension and the rounding halving add. On the right, there's a single idiomatic instruction that can take care of that. So all this combined makes sure that the loop runs about 10 times faster if you just look at the loop. However, If you look at a real application, where this loop is actually part of a larger thing, where there's like a handler requesting new pictures, etc., you can see that factorization made a difference between rendering at a slow 20 frames per second, and after factorization, we render at 60 frames per second. And that's actually as fast as you can go. Like, you cannot render much faster. So that really shows that factorization has given you the power to render at a very acceptable speed, and you actually have CPU cycles to spare, because it doesn't need the full power to go to the 60 frames per second. And all this was made possible by the factorization. You don't need to write like tedious NDK code anymore. You can just express the loop at source level. So it concludes my part. And then I want to invite the other speakers back on stage. And we're ready to take questions if you have any.
Do we have any questions?
I am Ashok Kumar. Hello world, I am Ashok Kumar. I used to play a lot of computer games. I was completely fascinated about it. I started to feel like I should prepare such games. I just wanted to learn how these applications react to humans. Somewhere, the dots were not getting connected. So I started reading blogs on all the possible online resources. Luckily, from GDG Bangalore, I got an invitation for Google Mobile India 2015. If I attend this competition, I could get a sponsorship for nanodegree. I was completely excited. I figured out that's what I required to connect the dots. It's like being really in front of a teacher. It enabled me to develop a production-ready application and converting my idea into reality, something that helps education and make the world a better place. Now I'm feeling relaxed.
Hi, I'm Nandini from Google's Conversation Design team, here to give you some tips on how to design your own voice and chat UIs using Actions on Google. Before we dive in, let's have a conversation about conversation. Consider this. All human inventions start as ideas. By definition, conversation is the exchange of ideas by spoken words. And by definition, civilization is the most advanced stage of human social development. It's the tangible expression of our common understanding and values, which is expressed through language. And language is molded and refined by conversations. A conversation is a contract between two participants with a mutual investment in the outcome. But all of that is really hard to codify. Building natural human-to-computer conversations is hard. But that's because human-to-human conversations are only deceptively easy. People are not going to change how they converse anytime soon. So the key to closing that gap between modern interfaces and thousands of years of evolution is to use what we know to be true about human-to-human conversation to teach our computers to talk to humans, and not the other way around. So the key to building a good voice interface is not to fall into the trap of simply converting a GUI into a VUI. Obviously, I can't teach you an entire design discipline in a few minutes, but I can give you 5 pro tips to set you up for success. Let's design a simple number guessing game along the way. Here we go. Number 1, leverage your brand and give yourself a persona. I don't mean a caricature or mascot necessarily, but you can do that too to make it even more accessible. A persona is more than that. It's the consistent character captured by the voice and interactive experience. It's the face of that experience for the user. First, list the core attributes of your brand and what you stand for. Come up with the corresponding attributes that can be conveyed through design elements, and of course the voice dialogue itself. For example, if your brand is known for speed, something we at Google are known for, some attributes of the design might be to be intuitive and data-driven, since both of those elements cut out steps for the user. Some voice attributes for the actual dialogue wording might be engaging or apt or approachable, since those also tighten up the dialogue by removing ambiguity or making it easier for the user to have confidence in the interaction. Write a short style guide covering things like pace, tone, energy level, vocal attributes, and the overall impression that you're shooting for. Try to create a simple bio sketch of a character that might embody all of these attributes. Give it a name if you want. Also, there's a practical reason for creating a persona as well. It's a good grounding mechanism for you long term. Designers and developers will come and go, or multiple people could work on it at once. It'll give everyone something to fall back on for consistency. Finally, don't forget to identify yourself as a separate entity from the Google Assistant. That means greet the user. Number 2, think outside the box, literally. It's tempting to draw out a conversation path visually and plug in the dialogue and then dive right into the code or start stringing together blocks of context to write a working agent, and then back into the experience iteratively. We don't recommend this. You can, but I promise you it'll save time and give you a much richer experience to map out the core conversation paths ahead of time. This doesn't mean just the so-called happy path. It doesn't mean error paths either. Instead, write out your core experiences like you would a screenplay. This can be as scrappy as acting it out and documenting it on paper, or create an interactive prototype you tweak and play with until you're ready to start coding. And then, when you draw out your initial vision, keep it at a high level, where the boxes present entire dialogues or user intents, but leave out the individual wording you'll use in the interaction. Number 3, context. Here are just some types of context you can consider and infuse into a conversation to make it more meaningful. Where is the user? What are they doing? What type of device are they interacting on? How is the experience influenced over time? Where is the user's frame of mind in relation to what they're trying to do? Try to cater to their intent, not to a specific feature. Number 4, speech recognition technology isn't perfect, but it's getting better all the time. So for the most part, you might want to treat that as a black box that'll continue to improve. You have to, of course, be aware of its limitations, but try to step back and look at the interaction from the user's perspective when something goes wrong. You don't have to try to steer the user back to the original question if they don't get recognized immediately. There are so many reasons they might not have been. People hardly ever say nonsense. Try to take those so-called errors and make them into another meaningful turn in the dialogue. Finally, I leave you with a challenge. This new world of conversation design for machines opens up a great deal of opportunity that hasn't existed before for us to use technology to advance our lives. Sure, as you get started, create some games, but I urge you to think bigger eventually. Help give someone access to information or technology that they couldn't use before because of a physical, mental, or an economic disadvantage. We're excited to help you do that with Actions on Google. Check out the description for some resources, and we can't wait to see what you create.
When we want to learn something, it's not very comfortable for girls. Generally, they don't go out and learn with other colleagues. They don't prefer learning with someone. The reason I go to Udacity is because a friend of mine told me about how wonderful the course is, and even if you know nothing about Android, the courses are designed so that you don't have to have a very much detailed experience in Java or Android. So when I started the course, I was like very scared that like maybe it will be too technical for me to understand because I don't know very much about Android or Java in very deep, like how to have some logic into a program and how to code in general. But the instructors, like my favorite way, Catherine, she makes it so interesting and so normal. You don't feel like that you are learning something, and it's a good way to learn online. Whatever I feel like learning today, I could just go and then search for it, and there will be a course available for that.
We're bringing together a really talented group of designers and developers to collaborate and innovate and generate exciting ideas for what can be done on the Android platform.
Within this context of a sprint, I really think that the distinction between designer and developer is blurred. It's all about problem solving and getting it done.
You're not working with designers as an engineer making a mistake to begin with. I feel like every designer or engineer brings a perspective to a project, and that's what's nice about working with a designer. You think like an engineer and designer comes and brings a perspective. In this group, I'm like happy to work with super talented designers. It helps me understand Android better because I see how they're thinking about it. It kind of kills my prejudgments about the product, and I start thinking about it from a fresh perspective.
We focus in on generating a broad range of ideas that are really innovative and far-reaching, and then prototype and pull together concepts and prototypes to demonstrate and create a vision for what those concepts could be.
I never was really familiar with the idea of using this type of process for ideation, and it's impressive to see the degree of precision that Kai specifically has introduced in the way that she's run this process. It's been really enjoyable to see specifically how one exercise leads into the next and the next and the next, and how that can actually effectively yield good ideas.
We're a very small company, so effectively we're doing similar things all the time, but we often rush straight to the solution. It was nice to see some structure around, I guess, the process. So, it starts here and, you don't get to fix it straight away. It's like define the problem, then go to this step, then go to this step. And that kind of structure, though it seems kind of burdensome, like it actually improved like the overall thing we came up with.
When you're in a company, you tend to think about like how the company kind of does something and how the things that you've learned in the past, and then like here is just kind of like a blank canvas again, and you get to like start new and then rediscover the things that kind of work in a workflow or in a much more creative space. I mean, like here we like tried to build something in like 3 days, which is like insane. This is the first time we actually like been in a sprint with just doing Android 2, and I would like love to bring some more of the Android sprinting back to our company.
I think design sprints facilitate interdisciplinarity, interoperability, and all of the kind of amazing things that can happen from a good collaboration.
One of the really exciting features of Android is that it's a very open platform. Anyone can come and write their own apps and create their own concepts. We want to bring that opportunity of openness to the design community and inspire designers to generate concepts and ideas and design really cool apps that leverage the openness of the platform.
I was impressed with the openness of Android. It's definitely a unique thing that you might not find on iOS or other systems.
In our app in particular, there's things that we definitely couldn't have done on iOS that are actually really useful. And it is nice because the app can organically come with you into the rest of your life.
I think for me, one of the big awesome parts of it was that I was able to begin to learn Android, which is something that I've always wanted to do as a prototyper. I just would like to get to know Android better, and this is like a really big jump start.
One of the few constraints that they put on us here at the Design Sprint was like to sort of like come up with something that's like unique to the Android ecosystem. And as we were going through all of our, crazy 8s and all of the myriad ideas that we had come up with, we actually abandoned some of them that were cool because they were kind of like something that could feasibly be built on any platform. And I think that giving us that constraint infused our other ideas with more creative solutions. And I think what we came up with is like so simple and so delightful and only available on Android.
I was an HR, I was working as a recruiter, and I was completely unaware as to what I'm supposed to do. I used to feel that I just don't want to be a recruiter, I want to be on that other side, talking technology and talking about gadgets and how technology is changing our day-to-day lives. One of our relatives, he challenged me that you are a girl and engineering requires a lot of designs and drawings. I wanted to prove him wrong, and that was the time when I heard about Udacity. I started taking some online courses in Java and Android, very basic things. It is little difficult, but it's just that I don't want to feel that, that sense of regret. I just don't want that. So Udacity has actually been a savior in my life. The quality of the projects is very good. It's like, after completing those, you feel like you have conquered something. Actually, I finished my nano degree yesterday, and so today it's just going to be the celebration.
I couldn't be happier to be here to see the launch of the Android skilling program. There's going to be so many new, great Android developers here in India.
Good morning, everyone. Thank you so much for coming. Some of you know I'm from Delhi. Always fun coming back and meeting all of you.
We can scale up developers and scale up mobile developer training to help make India a global leader in mobile app development.
Having the universities teamed up with us in the skilling program is going to be a huge opportunity and make a huge difference.
Finally, we've launched it. It's been a year since we first introduced this program. 2 million developers.
I think that it's a really achievable goal, and I think that it would do a lot for improving the environment in the country in terms of hands-on programming. So I think it's great.
It's a massive number. The possibilities are immense. India will be the largest developer base globally, and just to get everyone to start thinking about Android and developing for Android, we're at the cusp of a revolution.
Let's do something big. More games, more users, more success.
Yes.
Everything more.
Developing a successful app isn't easy. To reach a broad audience, you'll need to consider your iOS, Android, and mobile web users. And to build for these platforms, you'll need a backend server to store data and support the apps. Of course, you want to get your users logged in, hopefully lots of users, which means your backend will have to scale. Then after you've solved your scaling problems, you have to find more ways to spread the word to get new users. But have you found a way to measure all this activity? And oh no, your app is crashing and causing servers to melt down, and you haven't even made a dime yet. Don't you wish this could be easier? This is why we built Firebase. It has all the tools you need to build a successful app. It helps you reach new users, keep them engaged, scale up to meet that demand, in addition to getting paid. From the beginning, with Firebase, you'll have test lab and crash reporting to prevent and diagnose errors in your app. Your backend infrastructure problems are solved with our real-time database, file storage, and hosting solutions. Acquiring new users is easy with invites, AdWords, and dynamic links. And using the authentication component, you can get those users logged in with minimal friction. Once installed, you can keep your users engaged with notifications, cloud messaging, and app indexing. Then, with Remote Config, you'll have the freedom to experiment with new features and optimize the user experience in real time. And of course, you can earn money with the same AdMob component that's been monetizing great apps for years. Last, but certainly not least, our all-new Analytics component, designed uniquely for Firebase, brings insight into how well these components are working for you and your users. With Firebase Analytics, you can measure and optimize your advertising campaigns, discover who are your most valuable users, and understand exactly how they are using your app. Now, all these components work great on their own and provide a solid infrastructure to build out your app, but they work even better when combined in creative ways. So let Firebase handle the details of your app's backend infrastructure, user engagement, and monetization, while you spend more time building the apps your users will love. To get started right now with Firebase on Android, iOS, or the web, follow these links for more information. Then, to manage and monitor your apps connected to Firebase, there's a web console to view crashes, set up experiments, track analytics, and a whole lot more. And to learn more about Firebase and all of its components, you can read the documentation right here. We can't wait to see what you build.
Thank you for joining us here today. India is coming a long way, as I just mentioned. Today, India is the second largest country in the world in terms of number of developers. Soon, it's going to be number one.
What we want to invest in is actually training the faculty from your colleges.
The potential is so great, and what Google is doing to help catalyze that innovation it's really an exciting time for these campuses.
We are really trying to provide the best possible experience to teachers in these faculty hubs, because the first step to training 2 million developers is to train the teachers that are going to teach those 2 million.
Industry as of now demands a lot of updated curriculum. Developing 2 million Android developers. Working in a technical university, we can contribute hugely on developing those million app developers.
So we're excited that all the raw materials are there to create an innovation revolution in India.
I really think the students are going to make some great things, and I can't wait to see what comes out.
There's a lot of potential in India, and we need to take it forward.
With Google, we can provide rich opportunities to all. That is the essence of Google program, which I have seen.
This is a good move, and this program will definitely be useful to the students, because app development is going to rule the world for next few years, believe.
Let's now take a quick look at Google Cloud. There's two things that I want to check out, and Jen is here to tell us all about them. Hi, Jen.
Hi, Timothy.
So what's this? Because I really want to play with it.
So this is Kubernetes Whack-A-Pod, and it is a demo in which you battle Kubernetes, where you are trying to take down a service by being the cast monkey. While you're doing that, Kubernetes, which is a container orchestration framework, an open source project, will try and keep your web service up.
That sounds like fun. I'm going to totally try and take it down.
Yeah, give it a spin. You're going to hit the button and you're going to battle for 30 seconds. Ready? Here you go. So you're doing great. Kubernetes bringing those containers right back up. And the YOLO mode is special. It'll take out the entire web app in one go. Oh, and it's down, but Kubernetes is already bringing those containers right back up. You're doing great. 4, 3, 2, 1, and you are done. So during your 30-second battle, you took out 58 pods and caused 9 seconds of downtime. But it seems Kubernetes was victorious in getting about 70% uptime. But that's still a very good attempt.
Awesome, that was a lot of fun.
I love that demo.
All right, so I'd also like to check out Spanner, because I think Spanner is like one of the coolest things ever created.
Spanner is pretty amazing.
So I want to check out what this visualization is. Maybe you can give us a quick rundown of what Spanner is and then tell us what's happening here?
Sure. So Spanner is a managed SQL database what makes it special is it is massively horizontally scalable and can handle huge amounts of traffic. And you still have the wonderful features you would expect from a SQL database, like queries and transactions and other neat, shiny things like live migrations. Yeah, and it's fully managed, which is pretty cool. Who likes managing your database? This is a view of the schema that is an example schema on Spanner, which is the same thing being used to power the demo on the screen next to us.
You know, if I can, I think one of the things that I've always really liked about Spanner is the fact that it stays in sync, even though things are happening in different data centers. Can you tell me about that?
Yeah, it's a great point. It's one of the special features of Spanner. Spanner, in this particular demo, we have Spanner running on 3 different data centers on 3 different continents all over the world, and yet, due to some magic involving atomic clocks and very precise timekeeping, we can still serialize all those transactions and maintain that consistency.
That's cool. So what is actually happening on the screen here?
So on this screen right here, we are simulating a pretty amazing ticket sales event, where apparently, whatever this ticket sales event is, we are selling 137,000 tickets every minute. And so far, this demo, which I believe we started this morning, has sold 238 million tickets during its run through. You can see that they're distributed across the world, and even despite all that really high throughput, we're still maintaining about a second of latency on those transactions.
That's amazing. Okay. Is there anything else you want to tell us about what's happening here at I/O?
It's a great show, but other than that, I think we found the fun spots.
All right. Thanks, Jen.
Yeah, thanks so much, Timothy. See you later.
Okay, see ya. I'll be honest, it's not a party if there's not a photo booth. So I found the photo booth, and the guy who built the photo booth, Alex, was going to tell us all about it.
Hey guys, so this is a talking photo booth. For an operating system, it uses Android Things, and you talk to it using the Google Assistant, and it uploads photos to the cloud using Firebase.
Awesome. Shall we try it out?
Yeah, let's do this.
Where does it talk out of there? What about the speaker? Okay. Okay, Google, let me talk to the I/O photo booth.
Sure, here's I/O photo booth. Hi, I'm the I/O photo booth. Okay, taking a picture. 3, 2. Don't look so serious. You're in a talking photo booth. 1. Do you like it?
Yes.
Do you like some style for your photo?
Yes.
Just a minute. Downloading styles.
That's 56K, I can tell.
Here you go. I'm uploading your photo now. Can I share this on my Twitter too?
Yeah.
Yeah.
Got it. Uploading your photo. Printing a link in the photo now. Don't forget to share your photo with hashtag O'17 and have a great time at I/O.
That was awesome.
Thanks. That was a lot of fun.
All right, thanks, Alex. Hey, look at us. All right, so I'm here with Doug from Firebase, and there's a lot going on in the Firebase area, a lot that developers have already been able to play with and know pretty well, but there's also some new stuff, and I've asked Doug to show us some of that new stuff.
Yeah, so announced today, actually yesterday at Keynote, we found out that Firebase now has Firebase Performance Monitoring, which is a set of tools you can use to measure and monitor the performance of your app. So let's take a look at that. All right, so this is the dashboard. What we have here is an overview of the performance of your app. So we have traces by frequency. You can think of a trace like a window of time that's of interest in your app. Also, we can look at the latency of your network connections all over the world. We can also see the success rate of your app over time. So it looks like things are getting a little bit worse for this app as time goes on. So that might be something to pay attention to. Now, if we drill into traces a little bit, we can see that there are a collection of automatic traces, so we capture these for free automatically, and here's some custom traces that have been defined by the app. So you have the flexibility to write code to get some performance, or you can just let it do things automatically. Now if we go to network requests, we can get a breakdown of all the HTTP transactions that are going in here. And you'll notice that there's some wildcards, so we're actually bundling up different kinds of requests that look the same but actually have like different parameters. And you can see for this set of APIs, what's the average response time, what's the success rate, and the number of requests that have gone through the system. You can click through to this and see how it's going. So, you're probably using a lot of different SDKs. You probably want to know how they perform. You probably want to know how the app is performing from your user's point of view, and this is a great tool to get that done.
Awesome, Doug. That's really cool. And it's really neat to see all the data in this way.
Yep. No, it's definitely very helpful. It's definitely also very interactive. It's not just a dashboard that you look at, it's a dashboard that you interact with. So.
It's actually one of the really cool parts about being at I.O. is that if I were just to set this up on my app right away, I might not have all this data right away. But we're showing a demo here where we've collected a bunch of that data so you can see what it's like once you've invested for a while.
Yeah, definitely. There's nothing worse than opening up a dashboard and having nothing staring you in the face, right? It's nice to be able to see what you're getting into before you actually get into it.
Absolutely.
Good morning. Thanks for being here. I'm Chris, and I'm a PM at Fabric and now Firebase, and I'm also a co-founder. I was a co-founder of a mobile startup. So I know firsthand from experience and from talking to customers like you just how hard it is to get more users. Building a really good growth funnel is insanely hard, and it's always changing. It's super complex. And so as a PM over the last couple of years, I've been focused on this problem of growth for mobile apps, and especially focused on the identity portion of growth. And a lot of people don't think that identity is like a really important part of growth and growth hacking and whatever. But it actually really is, because you can have an amazing onboarding funnel, but if people can't or won't log into your app, then you don't get a user, you don't have growth. And so it's super important. And we've especially seen a lot of great success with using phone numbers as an effective identity for growth. So why phone numbers? One, they have a lot of great benefits. One, they're global. Every single person in the world who has a smartphone has a phone number that they have memorized. And actually, in a lot of emerging markets, we've learned that people prefer to use their phone numbers as their identity instead of an email address or another form of identification. And second, phone numbers are higher quality. They give you higher quality users. Because they're more expensive to mass produce, they're naturally resistant to the kinds of abuse and fraud you might see more often in other types of identification. And also, I think most importantly for this discussion is they enable really low friction sign-in for apps and websites. And again, like I said, sign-in is such an important part of your growth funnel. Over 90% of people who have issues logging into an app are going to leave. And so I think it's a scary number, but I think it's a great opportunity that if you really focus on identity as part of growth, you can have really awesome benefits. And so if identity is so important to growth, then why is login so hard to use? And I think as app developers, as web developers, we created the login screens. And so why are we making these screens so hard to use? And over the years, I've noticed there's really two big areas of why login friction is so, or login is so high friction. One big one is a problem of optimization. We're trying to do so much in a little screen that should be simple. Instead, in addition to just trying to log somebody in or sign them up, we're also trying to get a way to contact them by getting their email address. We're also trying to enforce some level of security, usually with some sort of password credential criteria. And we know as developers that passwords don't increase security as much as they increase frustration and friction. One big reason. Another big reason why login is so high friction is on the opposite side of the spectrum. And I'm definitely guilty of this myself, is we're so focused on the core value of the app that we're creating that we don't really spend a lot of time on login. It's just like something that we throw together before we ship. But the big disconnect there is that the first screen our customers see is a login screen often. And so the last screen you thought about is the first screen your customers are going to be experiencing. So a huge disconnect. And those are two big reasons why there's a lot of friction in login. And as developers, we know that login is harder than it needs to be. Most developers are not happy with their sign-in experience. But I know it's rational that we'd rather focus on the core value of our apps, our core ideas that we want to get out to the world. And dealing with login is hard. There's UX implications, there's security implications, and it's just not something people using our app is more important to us than people logging into it, at least when we're building apps. And so with all that in mind, a couple years ago, our team wanted to experiment taking phone numbers and wrapping them into a really simple login experience. And it looked like this. Instead of entering your email address and phone number, or email address and password, you'd enter your phone number. And in return, you get a 6-digit code. You punch that code in, and you're logged in. Really simple, secure login with no password. We took that experience and dropped it into a really simple-to-use SDK called Digits. Digits was something that people from any technical background could dump into their apps or websites in a few more moments than it takes to actually log into Digits. And we let it go. And how it went was, I think, pretty well. Since launching, almost 150 million people have logged in with Digits all around the world. That's been a really fun ride. We've learned a lot. But I think what I've really enjoyed the most is talking to developers like you and hearing your stories about the things that you care about when it comes to growth and identity and authentication. And obviously, performance is a huge factor of that. Our good friends at Doblet replaced email login with phone as one of the options for their app. And they saw a 45% increase in sign-in rates. Imagine your own growth funnel and making one small change that can give you 45% more users every day into your app. I think that's cool for a couple of reasons. One, it shows that phone is a legitimate way to log people in. And second, it shows that, like I said, any changes you can make to the identity portion of your growth funnel might have huge impacts for your entire growth all the way through. Or Musical.ly, who is improving the quality of their accounts by enforcing Digits phone verification. So what they're doing is they're reducing fraud on their in-app economy, which I think is a really smart use of Digits. And again, I trust. Periscope, they're early partners of Digits, and they're still using us. And by letting us handle their onboarding flow for them, they're able to focus on their core value, which is delivering live video to people anywhere in the world. Or Dubsmash, who, again, they relied on us to handle almost 2 million people per month through Dubsmash so that they can focus on the core value of what they offer to customers. And so these kind of topics have come up over and over again: trust, performance, and reliability. And performance has always been the biggest thing because, frankly, you hired us to do a job. The job is to give you more users, and we wanted to give you more users. And so earlier this year, when we joined Google, we saw this really amazing opportunity to take all the iteration and UX research that we put into Digits Kit and combine it with the really unique capabilities that Google has to offer. And so we put our heads down, and a couple of days ago, we saw some really cool announcements. And I think that what we came up with are some really awesome next evolutions in phone auth performance together in Firebase. And so to share how you can take advantage of that today, we're going to be talking about two topics. One, for those of you who are already managing your own SMS backend, You know how hard it can be to actually get a well-formatted phone number from a customer. And so there's some really cool new APIs that we're going to be discussing first. And second, I'm really excited to be sharing Firebase, more details on Firebase phone authentication, which has been a really tight collaboration between the Digits engineering team and Firebase to create a brand new service that I think is philosophically and effectively the next logical evolution of what we want to do at Digits in terms of phone auth performance. It's a really amazing system, and it also has a really easy-to-use migration path for Digits customers. And so I would encourage every Digits customer to take a look at it, because I think it's really badass. And so to get us kicked off, please welcome Vikas on stage, who's going to be talking about phone selector and SMS retriever. Thank you.
Thanks, Chris. And hello, everyone. My name is Vikas, and I work in the Android Auth team at Google. I'm going to talk about how we enable you to support phone numbers for authentication if you have an existing backend infrastructure that you are already using for verifying the phone numbers, such as for sending SMSs to your users. You may have your own SMS infrastructure, or you might be using a third-party service such as Twilio. So, as Chris mentioned, using phone numbers for authentication is great, as it offers several benefits over traditional authentication methods. But still, signing in a user with phone numbers is still problematic for some users and for app developers. Let's see what a sign-in experience with phone numbers looks like today. It involves two steps. First, getting the phone number of the device, and second, verifying the phone number. Most apps perform verification by sending an SMS to the user's device with a one-time verification code that the application then verifies. So the app has to get the phone number of the device and then read the verification code from the SMS. So how do the apps get these two things? Most of the apps basically ask the users to enter these values. But that's not a great solution for many reasons. First, manually inputting the phone number is painful. It adds a lot of friction for the users to provide phone numbers to your app. It's also error-prone. It's important to note that every failed verification because of a typo in the phone number adds cost to the app developers because they end up sending an SMS to the wrong phone number. Let's say the user provides you the phone number, and you send the SMS to the phone. The next step for you is to get the verification code from the SMS. Again, asking the user to provide you the verification code is painful for the users. It requires the users to leave your app, go to the SMS app, copy or remember the verification code from there, come back to your app, and then provide it there. It's a lot of work for the users. Many users find it confusing, and it's not a great experience. So many app developers have recognized these problems with the manual inputs. And what they've started to do is they are now reading the verification code and the phone number automatically. But this approach has its own problems. Let's see. Getting the phone number from the device and the verification code from the SMS automatically requires your apps to get permissions from the users. And this looks something like this. These permissions allow the apps to get the access to all the phone calls and all the SMS messages of the user. Users are left confused as to why your app needs access to all these phone calls and SMS messages. So this leads to a low adoption rate and a poor user experience. And from privacy perspective, it's not a great solution for your apps. With Google Play Services SDK, we are offering you best of both the worlds. We enable you to read the phone number and the verification code from the SMS automatically without requiring these extra permissions. For reading the phone number, we have the phone selector API, and for verifying the phone number, we have the SMS retriever API. Since these APIs are part of the Google Play Services SDK, they are also compatible with the older versions of Android platform. Let's take a look at the phone selector API first. The phone selector API provides the phone number to your app with a much better user experience and no extra permissions. Using this API, you can launch a dialog which shows the phone numbers on the device to the user. when the user selects the phone number that they want to use to sign in into your app, that phone number is provided to your app immediately without requiring any extra permissions. You can check out the usage of this API in the apps like Myntra, Lyft, and Flipkart. Let's see how you can use this API in your app. First, you create a hint request object and set the phone number identifier supported field to true. And then you get a pending intent from that hint request for the phone number selector dialog. Once the user selects the phone number, that phone number is returned to your app in the on activity result. It's that simple. Once you have the phone number, the next step for you is to get the verification code to verify the phone number. In order to help you with that, we have the SMS Retriever API. So let's take a look at that. SMS Retriever API provides you the message content to your app without requiring any extra permissions. And the key part is that it provides you only the message targeted to your app. All you have to do is, in your SMS message, in addition to the verification code, you have to include an app-specific hash. This app-specific hash is a static hash that you can just include in the SMS template without requiring many code changes. Let's see how you can use SMS Retriever API in your app. When you want to verify the user's phone number on the device, you start the SMS Retriever. This makes it wait for one matching SMS, which includes the app-specific hash. After starting the SMS Retriever, you can just send the SMS with the verification code and the app-specific hash to the phone using any backend infrastructure of yours. Once the SMS with the app-specific hash is received on the device, it is provided to your app via a broadcast. In your broadcast receiver, you can get the message content from the extras. Once you have the message content, you can extract the verification code and verify the code just like you would normally do. The SMS Retriever API, you can use it for not just signing in the users, but also for reauth use cases such as for payments. The SMS Retriever API will be available in Google Play services. It will be available in the Google Play services in the coming weeks. But our early partners who have tried this API have loved it. Here are some testimonials from some of our partners. Many of our partners, like O'17, they love the fact that these APIs work with their existing infrastructure. We have carefully designed our APIs so that they are very easy to integrate with your existing flows. Myntra, for example, was able to successfully integrate the SMS Retriever API in their existing sign-in flows in just 3 days with one engineer. Here are other testimonials. Many of our apps have been able to get rid of the scary permissions and streamline the phone number verification flows because of our APIs. Cascas Chat actually found out that their conversion rates increased after they integrated their flows with our APIs. So I just talked about how with Phone Selector API and SMS Retriever API, we enable you to simplify the phone auth process if you already have a backend infrastructure in place. Next, we are going to talk about the Firebase phone auth, which helps you get started with the phone auth. And if you're looking for an end-to-end solution, this is how it will help you. So with that, please welcome Dev, who is going to talk more about the Firebase phone auth. Thank you.
Thank you, Vikas, and hello, everybody. My name is Dev Rishi, and I'm the product manager for Firebase Authentication. You've heard about some really cool things that phone number authentication can do for your application. And today, I'm really excited to talk to you about how Firebase Phone Auth can make it possible to build all of these really great flows end-to-end and very easily. So before we start, I feel like I have to acknowledge that since we've launched, phone number authentication has been one of our top feature requests constantly. To all the developers that tweeted post it on Stack Overflow or filed a feature request, I just want to say that we've heard you, and I'm really excited to be able to bring this functionality to Firebase now. And it's no surprise that so many people have been asking for this. Today's apps need to be able to support high-quality, low-friction users from all over the world and engage with them in new ways. And that makes phone number auth really valuable. But the truth is, for a lot of the apps that actually don't have phone number authentication today, building it in the first place can be a real struggle. Chris talked about a lot of the pains that users go through, but it's also really painful for a lot of developers. The first thing you'll need to do is integrate with an SMS provider and get coverage with carriers to send SMS. And then you're going to want to expand your offering globally to support all the different areas that your users might come from, making sure you've perfectly localized along the way. After all of that, you need to build secure authentication. That means generating a one-time code, verifying it from a user, minting cryptographically signed tokens, persisting sessions, writing your anti-abuse logic. I don't know about you, but that's not exactly what I was looking forward to when I started to write an app. That's why I'm really excited to tell you that this week, Firebase launched its phone authentication APIs. The first thing that we allow is we enable basic sign-in and sign-up flows, similar to what Chris talked about earlier with digits, on all of the platforms that we support, iOS, Android, and web. And on Android, we actually allow for a few built-in enhancements. Vikas told you a little bit about the SMS Retriever API, which actually increases overall conversions from users so they don't have to end up going to the SMS app and parsing it. And I'm excited to announce that this is going to come built into our Android APIs. Finally, we have a really new cool piece of functionality called instant verification on Android. And I can't wait to tell you a bit more about that. The iOS and web APIs are actually available for you to start trying today. And the Android APIs will be coming in a few weeks. But in the meantime, let's go ahead and see what these APIs are capable of. First thing that we want to make sure we enable your app to do is allow you to sign in and sign up your users. So, for example, if you're in an iPhone, the flow might look a lot like this. Perhaps you're one of the many modern apps that integrates email authentication as well as different identity providers. And in this case, you decide to go ahead and sign in with phone number. All a user would need to do is enter their phone number, and you can go ahead and pass it over to us. We'll validate the phone number, handle any normalization logic that needs to happen, see if this is a new user or a returning one, and we'll go ahead and generate a one-time code associated with this request. From there, we'll handle sending this one-time code through an SMS to your end user, so you don't have to worry about any of those pieces. And your user will simply pass back the code into your application, and which you would just pass right back on to us, and we will verify it. We'll handle any of the complex logic and deduplication if you sent multiple SMS by mistake, or any of the other edge cases that might arise. And the user will go ahead and enter their code, we'll validate it, and we'll go ahead and mint cryptographically signed tokens, persist sessions, the whole authentication 9 yards. And you won't have to worry about any of it, because all you'll have to worry about is how to best and warmly welcome your users into your application. So that's kind of what the actual APIs look like for signing in and signing up users on all the platforms that we support, iOS, Android, and web. But I'm really excited to talk about some of the enhancements that we're able to make on Android. The first one is auto-retrieval, which works very similarly to what Vikas discussed earlier, and comes built in if you use our phone auth APIs. For auto-retrieval, if a user goes ahead and clicks sign in with a phone number, this time they can actually select their phone number if you integrate with Hint Selector. It'll be auto-populated into the application. We'll validate it once more. We'll generate the code. But this time, when we actually send the code in the SMS, we'll be able to pick it up from the background. We'll auto-retrieve it directly, parse it out, and populate it into the application. And the best part of all of this is your user never actually had to leave your application, go to an SMS tab, wait for it, and then copy and paste the code into your UI. They stayed in your application the entire time, and it was a really seamless experience for them overall. That's all that you ever had to do. The last piece of infrastructure that I'm really excited to talk to you about today is a new feature on Android that we're calling instant verification. Instant verification works exactly like it sounds like. It allows us to verify the phone number without sending an SMS. And to the user, it appears instantly. Let's take a quick look at how it works. In this case, the user might see the screen again, where they get to select a phone number directly that we read off their device. This time, when they enter their phone number and you call our APIs, we're going to do a first check. That check will go ahead and see if we have verified this phone number on the device recently. If we have, we can actually instantly verify the phone number the next time around without needing to send any additional SMS. We think that this means there's no wait time, no SMS, or anything else, just pure simplicity. And I'm really excited about the potential this has to significantly improve user experience and greatly simplify the lives of our developers. I think one of my favorite things about Firebase Phone Auth is that all of this powerful functionality is also really easy to use. There's essentially just 2 steps to go ahead and get started. The first thing you need to do is just enable Phone Auth within your project in the Firebase console. This is quite literally clicking on the phone selector and enabling Phone Auth with a single flag flip. It doesn't actually get much easier than that. The second thing you need to do is just integrate with our SDKs and our APIs in order to be able to use this functionality. Now, our headless APIs don't enforce any UI. So they give you programmatic access to our underlying infrastructure that you can use in any way that you choose. And it's really easy to use. On Android, in order to get all the awesome functionality that I talked about, the actual ability to generate and send codes, the auto retrieval, even instant verification, comes down to just one single API call and the implementation of the callbacks that you care about. So in this case, all you would do is call verify phone number with a phone number that you pass in and implement a few callbacks, for example, on verification completed, where you can decide whatever it is you'd like to do once we've either auto-retrieved the SMS, instantly verified the phone number, or whenever the user has just decided to be signed in. I think all of this functionality is really powerful. These APIs are very simple to use and give you programmatic access to some of our most incredible infrastructure here at Google. But I think it's really worth asking, what about UI? Building authentication UI can be pretty complex. You need to handle all sorts of edge cases across all the different platforms your application might support. And even after you do all of that, you want to make sure that your login UI is actually high performance, and it will give you good conversion rates. As Chris talked about earlier, this isn't really what a lot of you want to spend your time doing. The first screen that your users see is often the last screen that you think about. And building out all of this UI can honestly be painful. Trust us, we know, because we've actually done it. We wrote out all the code for the different phone authentication flows that we've talked about just for the UI components on Android, iOS, and web. And just to write the phone authentication flows across the 3 platforms, it can be several thousands of lines of code. Now, if you decide to go the way of a lot of modern applications and integrate different identity providers such as Google, Facebook, email, etc., then this is just going to get more complex. And if you actually end up wanting to integrate all these different sign-in providers into your application, well, doing identity and user sign-up is probably going to become your full-time job. That's why I'm really excited to announce that Firebase Phone Auth is now also part of Firebase UI. And Firebase UI is an open source repository on GitHub that we maintain that gives you the best practices in sign-in and sign-up that Google has studied over a long history of doing identity work directly and out of the box for your applications. This is really bringing years and years of knowledge from Google's understanding of how to maximize conversion rates directly into your application. It's really simple to integrate into your app, and it gives you the best practice flows for all the different platforms. Best of all, Firebase UI is completely open source and fully customizable. So as soon as you integrate it into your application, you can go ahead and tweak and tailor it directly into the needs of your app, however you decide you would like to. But you don't just have to take my word for it on how easy Firebase UI is to use and how easy these APIs are to integrate. I can actually show you. So I call this part of my talk, What Could Possibly Go Wrong? Because it is not only a live demo that I'd like to do in order to show you the cool functionality and how easy it is to build into our applications, but before this week, I'd actually never touched a line of Android code before in my life. Luckily, building phone authentication is actually really easy, and I'm going to be able to do it, I hope, in just a couple of minutes into my application. So before this demo, the only thing I've done is actually create a project, and as you can tell, there's not a lot going on here. I'm not sure I could actually do that much more. All I've done so far is just get the dependencies. As you know, the public versions of the Android APIs will be coming out in a few weeks. From here, I can actually build phone authentication into my application in just 3 simple steps. The first step is I'm going to link Firebase to my application through the super easy to use Android Studio plugin. I'll go ahead and go to authentication, click email password, and as you can see, I've set up my dependencies, and I'll just hit connect to Firebase. This is going to open up a dialog that'll allow me to either create a new Firebase project. Connect to Firebase fail. Internet connection can be one of those things that makes live demos treacherous. But there we go. This is going to open up a dialog that'll allow me to either create a new Firebase project or link to an existing one. In this case, I'm just going to link to EasyAuth, which is the Firebase project that I had set up. Now that I've connected it to it, that was step 1. Connecting this through the Android Studio plugin was all I needed to do for step 1, and step 2 is even easier. I'm just going to go over to the Firebase console, go to the Authentication tab, go to Sign-in Methods, and here we can see all the different sign-in methods that Firebase Authentication currently supports. I've already configured a few in the past, like email, Google, and Facebook, and I'm just going to enable phone. This part is quite literally just that flag flip I showed you earlier, and we're done with step 2. Now, if you'll believe me, step 3 is just as easy as the last 2, even though it's the step where we write code. All I'm going to do is go to the open source Firebase UI GitHub repository, scroll through the README, ignore most of it, and go to this one section that I care about, where I'll be able to copy and paste the code directly into my application to get my phone UI built. Now, this allows me to support a lot of different sign-in providers, like the ones you saw before. And in this demo, instead of Twitter, I'm going to decide to support phone verification. That was it. That's all I had to do. Luckily, because again, I'm not actually an Android developer. And once I go ahead and compile this application, if I could switch to my phone, please. Thank you. I will be able to show you exactly all the different flows that we integrate with end-to-end. So now I have multiple different login methods enabled on my demo app very easily. And I can show you exactly how the phone auth flows work in real life. Fingers crossed to have carrier coverage here. First thing you'll notice is Firebase UI integrates with hint selector directly. So I didn't write any additional code for this, but it's able to pick up my phone number from the device, and I can just simply enter it directly into the app. Now, when I hit verify phone number, it'll go ahead and send me a code, which will directly get read off the SMS. And I don't know if you actually caught it because it was so fast, but the number was, thank you very much. The code was sent to my device, immediately written from the SIM. But from an end user perspective, it was the easiest thing I've done all day. All I did was really tap my phone number, and everything else was taken for me. The SMS was delivered, it was parsed, it was taken. I never left the app. Now let's imagine that I'm coming back to the application, maybe after a week or 2, and I'd signed out. This time, I'm going to try and demo a really cool piece of functionality that I'd mentioned earlier, instant verification. This time around, when I go to the application, I'll hit sign in with phone number again. It'll pull up the phone number from my device just like last time, and I hope what's going to happen is I'm just going to do single tap login, where I go ahead and select my phone number. It sees that I'd already been verified in the past, and that was it. No SMS was sent, nothing else. Can we see an instant replay, maybe? Because that was so quick. There was no SMS sent. There was no need for a user to wait for anything. But instead, we were able to just validate that we'd verified it and log them in directly into the application. So I'm really excited about this functionality, the potential it has for where we can go in the future, and I can't wait to see how you integrate into your applications. Can we go back to the slides? Thank you. Thank you. So I think one of the things you just saw is how easy it was to build Firebase phone authentication from scratch. And I think one other thing that we've thought about a lot as we've actually developed this is how do we make sure we have the best possible experience for Digits developers? As Chris mentioned earlier, building Firebase phone authentication was a really close collaboration between the Firebase Auth and the Digits teams. And we want to make sure that we're able to warmly welcome Digits into the Firebase family. That's why I'm happy to announce that we've started to roll out migration pathways for Digits developers, where they'll be able to link their Fabric accounts with Firebase projects, and we'll handle the user importation and all other tasks required in order for them to get set up for their first time. From there, they can go ahead and use some migration guides that will be published soon in order to integrate the new Firebase SDKs into their application, and that's all they should have to do. There won't be any additional friction for your users who won't have to necessarily re-authenticate back into your application, and I hope all of you stay tuned on the Fabric site for the coming details. I'm really excited that we've launched phone authentication, because I think now Firebase is an even more comprehensive authentication solution. Now we support all the different major sign methods your application might want to support, like email authentication, phone numbers, and some of the top identity providers like Facebook, Google, Twitter, and GitHub. We also give you easy user management UI from the console, as well as SDKs in order to do all the different tasks that you might want to on behalf. You can bring your own custom authentication solution to Firebase if you've already had one. And I think best of all, we give you drop-in and fully customizable open source UI that reflects Google's best practices, so you never have to worry about how to best write the conversion flows for your application. You never have to worry about all the thousands of lines of code that it might take. I think one of the things that's great about Firebase authentication is that most of the services are completely free to use. And I'm really excited to say that with PhoneAuth, we've spent a lot of time thinking about how do we come up with the most friendly pricing structure for our developers as possible. We have a really generous free tier, where I think for up to 10,000 verifications per month, we're actually going to be able to give all the verifications under this threshold for free. This will cover the vast majority of applications, and I think it's more than 90% of Digits developers will be able to use this service completely for free. If you do grow wildly successful, we want to make sure that our service continues to grow sustainably and scalably with you. But we also want to make sure that we give you really simple and easy to understand pricing. So we're only going to charge you based on what you care about, which is the actual verification of the user. And we're going to make the pricing structure really simple. Just 1 cent for a verification in US, Canada, and India, and 6 cents in the rest of the world for any of the verifications that go above and beyond the 10,000 verifications a month. I can't wait to see what you all build when this is in your hands. So to recap kind of on what we've talked today, we've really talked about 2 sets of optimizations I think Google is enabling for all the different applications out there that care about phone numbers. If you have your own phone auth infrastructure already, there's phone hint selector and SMS auto retrieval in order to really optimize those flows and make your end user experiences much better. If you want to build a phone authentication solution from scratch, Firebase Phone Authentication will give you the entire process end-to-end with some of our built-in enhancements very easily. And I think is a really compelling way to start getting into this space and being able to integrate this powerful technology into your applications. Like I said before, the iOS and web APIs for Firebase Phone Auth are out now, and the Android APIs for everything will be coming out in the coming weeks. But in the meantime, I do hope that you'll go ahead and check out our documentation, try us out today, and if you have any questions whatsoever, all of our contact information is listed out on the screen, and we'll be hanging out outside these tents and in the Firebase sandbox for a little bit afterwards as well. I really cannot wait to see what you build with this new technology, and I'm really excited to help and continue to support our developers. Thank you very much.
Did you know that the average user has 36 apps on their device and doesn't use 3/4 of them most of the time? And of those, about 1/3 of them have only ever been used once. Well, what if that's your app? You've done the research, you've written the code, you've performed the testing, you've perfected the design, you've gotten the installs, and then nothing. So, how do you prevent this? App indexing helps you re-engage with your users through tight integration with Google Search. As well as appearing in search results, it surfaces your app through autocomplete and now on tap. All you have to do is get your app in the index. And when users search for the content that's already in your app, they'll be able to see your app directly in the search results and be able to launch it right from there. It's as easy as that. But how does it work? If your app and site have similar content, you associate them with each other. Then your app can receive incoming links from search. On Android, these are achieved using standard Android apps, and on iOS, using standard iOS universal links. When a user searches for your content, they can then find your app. If you have the app installed, it will allow you to it sees the address of the index content and decides which screen to load to show it. It's really as easy as that. You can also use the App Indexing SDK to submit content to the search engine based on how people use your app content. When people use your app, your search position can be improved. With app indexing, you get into the index, putting your app into Google Search, and allowing you to re-engage your users.
So you've built an amazing mobile app that your users are gonna love, but you want to get it into people's hands and let them see just how awesome it is. Well, AdWords helps you do this, putting ads for your app in front of billions of people that use Search, YouTube, Google Play, and more. You can quickly set up an ad campaign to reach the type of users that might be interested in your app. You only pay if the user clicks on that ad, and you can set the budget and acquisition costs that you're comfortable with. But how do you know you're reaching the right users? Maybe some will install your app and forget about it, while others will make it part of their daily lives. Firebase Analytics helps you do this. You can define events that happen in your app that you consider to be important, such as reaching the first level of your game, purchasing a fancy new pair of sunglasses, or returning every morning to check out new products. You can tell AdWords which of these events are most important to you. Then, AdWords will display ads to people who are more likely to complete these important actions in the future. You can also build audiences, which are specific segments of users, and have AdWords display your app to them. For example, imagine that you have a group of users who are very active, have added a product to their cart, but haven't purchased yet. Well, you can use Firebase to create an audience of just these people, and then use AdWords to give them specific ads and encourage them to come back to your app and take action. Understanding your users and engaging with them at just the right time and in the right way will help you build loyal users for your app. Firebase and AdWords, working together to help you grow your user base. Get started today. Your new users are waiting.
Android Instant Apps make it possible for users to access your app without having to install it first.
Imagine users opening your app just by clicking on a link in an email or a text message. We've recently made Android Instant Apps available to all Android developers. To take full advantage of this, we have some best practices to help you make your Instant Apps user experience as great as that in your installed app, or maybe even better. You can find all this and more at the URL in the description below. It's important to keep in mind that by enabling your app to run instantly without installation, you're not creating another additional app. We're thinking of Instant Apps as another way to use the app your users already know and love. It's the same app, just without installation. By adding the ability to access your app directly from a link, a search result, or another app, it's much easier for users to engage with your app and get excited about it. If they decide to keep your app on their device permanently, they can then install it right from within the Instant App. The ability to launch an app without having to install it provides an enormous opportunity. For a long time, app developers have focused on the number of app installations as a proxy for the metrics their business really cares about. Without installation, users simply weren't able to engage with the developer's offerings at all. Removing this barrier to entry enables you to think about the metrics your business really cares about. Your audience is now just one tap away from engaging with your service. Your Instant App is just another mode your app can run in. So don't branch your UI and make any unnecessary changes regarding the layout, interface, design, or experience of your Instant App. The transition from instant to installed mode after installation should be as smooth and seamless as possible. Your users should have a rich and full app experience, even if they haven't installed your app. Rather than thinking of Instant Apps as a limiting factor to what your audience can do, think of it as an opportunity to get them to your functionality quicker and a way to foster your relationship with them. Avoid prompting your users to install the app when they're in the middle of a task. They'll be much more inclined to place your app onto their device permanently after it has had the opportunity to prove its usefulness. Refrain from bouncing them back and forth between your Instant App and your mobile web offerings. You can probably tell by now, Instant Apps are all about removing friction for your users and getting them closer to your functionality. Think about ways you can remove further barriers for your users. For example, wait until users can see the benefit of making an account and signing in until the value of doing so becomes apparent. Asking users to create an account after installation seems like a small additional ask when they've already gone through the app installation flow and are only just getting started. However, when they're coming from a link looking for specific content or functionality, being asked to register can feel very disruptive. Additionally, make sure to use available APIs to make your and your users' life easier. Using Google Smart Lock, for example, makes signing up and signing in a much simpler and straightforward experience. In summary, we really think that Instant Apps will unlock a lot of opportunity to engage your audience more directly. Users will be able to focus on what it is they want to accomplish rather than having to spend time maintaining and updating apps on their phone. We're super excited to see what you come up with. Everything I talked about here and much more you can find on g.co/instantapps. Thanks for watching.
Firebase makes sending messages to your users easy with Firebase Cloud Messaging. It's a free service that allows you to send messages to your users' apps across a variety of platforms. Messages can be addressed to single devices, groups of devices, or even topics. Building a notifications or messaging system with Firebase Cloud Messaging is easy. First, you register your user's app instance with the Firebase Cloud Messaging servers. Then, on your server, you write code that allows you to address these devices by ID, group, or topic, and which tells the Firebase Cloud Messaging server to send the messages for you. It's powerful, it's scalable, delivering hundreds of billions of messages per day, with 95% of messages being delivered within 250 milliseconds to connected devices across many different platforms. It's that easy, it's that powerful. Firebase Cloud Messaging.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer. So you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
When I was 10 years old, my dad got me a book on Pascal. And just a few chapters in, I immediately realized I can create some amazing things all by myself. My name is Shruti Saraf, and I'm a founder and game developer at Blacklight. I always remember my mom playing solitaire on a computer, but when moving to mobile, she struggled to find a good solitaire for her phone. So she insisted that being a game developer, plus her daughter, I should develop solitaire for her. So I took the idea to Sumit.
I'm Sumit Soni and I'm co-founder at Blacklight. I'm 32 years old and I have 25 years of game experience, playing them and now designing them.
We played solitaire for hours. We even bought a deck of cards, real cards, to understand the game better.
60% of our users are mommies and grannies, so we designed solitaire keeping them in mind. Big bold cards, soothing colors and minimal design, taking a lot of cues from Google Material Design Guidelines.
It took us 6 months of research and design to make solitaire look great and be really fun to play. And then we noticed a lot of visitors are visiting our page, but very few of them downloaded the game.
So we thought maybe the logo is the problem. We experimented on Google Play with a modern design and a very old-fashioned one. And wow, the old-fashioned logo had 54% more downloads, and after we adopted it, our total downloads went up by 90%.
Plus, we moved to Android Studio, which allowed us to integrate Google Play game services, and emulators helped us design user interface for different screen sizes and varied pixel density. The feeling that something you have created is adding fun and value to so many people around the world, most of them from places I've never been to, can be quite profound.
Shruti's love for coding and her mom's love for solitaire led to this. Today, we have 5 more games in the pipeline, and we hired 5 more Android developers to work on them.
It definitely wasn't a smooth journey, but through hard work and great user feedback, we are where we are today, and we can't wait to see what we do next.
Android Wear 2.0 is the most significant update to Android Wear since its launch in 2014. I'm Hoi Lam, and I'm here to take you through 3 highlights of Android Wear 2.0. First, material design has arrived on Android Wear. The new Android Wear interface uses a darker color palette, which makes the watch blend in more in social environments. It also helps save battery by OLED displays. We also suggest that developer adopts vertical layouts and reserve horizontal swipe for activity dismissal. In our research, this makes user interface easier to understand. To help developer implement these new design patterns, we have introduced new user interface components such as the wearable drawer layout and wearable recycler view. Check out the material design for Android Wear site for more details. The second highlight for Android Wear 2.0 is watch face complications. Before Android Wear 2.0, if a watch face wanted to display data from another app, they need a one-to-one agreement in both business and technical terms. To alleviate this complexity, with Android Wear 2.0, we have introduced the Complications API. Complications are a traditional watchmaking term for areas of the watch face that displays information other than the time, such as the date or phases of the moon. We have extended this concept to smartwatches, so any app can publish data for watch faces to consume. And watch faces can display these data in a style that fits into their unique designs. For app developers, this helps increase user engagement and mindshare. For watch face makers, this adds utility to the watch face. Users can now choose whichever watch face they want, as well as getting the data that they need. Check out the watch face and complications sections of the developer documentation for more details. Last but not least, standalone functionality. Previously, Android Wear 1.0 apps require a phone app to communicate with the cloud. With Android Wear 2.0, Wear apps can access the internet directly without the need for a corresponding Android phone app installed. This means the Android Wear app can access the internet even if the user has an iPhone. To help with app distribution, we have also put the Google Play Store on the watch. Users can now download apps directly on their wrist. Apart from these 3 areas of improvement, material design, complications, and standalone apps, there are numerous other enhancements with Android Wear 2.0. Check out the Android Wear developer site for more details. I'm Hoi Lam. Happy coding!
Have you played AppShip 3000?
No, but I'm ready to. And I'm standing here with Abe, who helped build this fantastic experience. Abe, tell me all about it.
Yes, this is AppShip 3000. This is a collaborative Firebase trivia game where 3 people work together to launch their AppShip and hit their moonshot. It's pretty crazy, played with arcade controllers out here in this very loud situation where it makes you yell to each other and get all hyped up, and it's a lot of fun.
Awesome. So we're going to play it, and maybe I'll give you the microphone, and you can sort of narrate what's happening and maybe talk a little bit about the tech.
Absolutely.
Great. So for my fellow team players, we've got Doug over here. Doug, take a bow. And Todd over here, who you may know from such things as Everything Todd Does. All right, Abe, I'm going to give you the mic.
Yep, everyone's already logged in and they're sitting with their rocket primed for ignition. In order to take off, everyone has a specific color they need to hit. So let's give it a countdown. In 3, 2, 1, take off. There we go, there we go. Now in the game of AppShip 3000, the very first thing that happens is you will get prompted to ask, have you played before? Everyone here has, which is good. And we'll dive right into the game. The very first question, who has it? There you go, there you go. Those blinking things up at the top are asteroids, which will absolutely destroy you. Good, good. Good, good. I'm amazed you knew that. Good job. How many Google engineers does it take? Lovely. Good call, good call. Yeah, you cannot be a true Firebaser if you think pineapples are ugly. All right, while this game's running, I'll talk a little bit about what's happening. But it's a little hard since they're all shouting all the time. Somebody pick something, you're running out of time. Oh. All right. So while they're playing this game, every movement they make is being thrown off into the Firebase real-time database. And the real-time database is taking that, doing some analysis, updating high scores and things like that. So absolutely every move they make is getting thrown off into Google Cloud and Firebase for analysis. All right. Oh, you got to watch out for those asteroids, guys. No, it is not. Definitely not 8. Up. We're low on fuel. If you miss this next question, you are done. Oh, you're so close. Right. Oh. Oh, there you go. That is the end of 754 feet. That is an okay score. That is supremely okay. Good job, everyone. Thanks for playing.
All right, Abe, thanks so much for that.
Absolutely, anytime.
So we're actually going to play another round, so bye.
Good morning, everyone, and welcome to this talk about color. So how many of you think they understand color? Raise your hand. Nobody? OK, I guess that's why you're here. So I gave a similar talk last year at NDev 360, and there was a lot of math and a lot of equations, and a lot of worried developers asked me if there's going to be math in this presentation. There's going to be no math, no equations. Instead, there's going to be physics. So let's talk about color. The first question we have to ask ourselves is, what is color? It sounds like, a deep question. The answer is not so deep. So here's a definition that applies to most of us as human beings. We're not developers, we're just regular people. So it's a visual perception that can be described by hue, brightness, and colorfulness. Sometimes colorfulness is also called saturation. And if you've ever used the HLS, HSL, or HSB colors in the Android APIs, you might be familiar with that kind of definition. What's really important to understand is that color is just a perception of our brain. It's not a real thing. And we're going to see why that is. So obviously, we see colors with our eyes. And if any of you see colors through another mean, I would love to talk to you. And to understand how we perceive color, we first have to go back probably to high school or college and try to understand what light is made of. So I'm sure most of you know that light is made of photons. But there's a duality to light. It can be a wave or a particle. And we're going to look at the wave nature of light first. So light is an electromagnetic wave. And our eyes are just receptors for those electromagnetic waves. So here's the electromagnetic spectrum. It's not to scale. And from the shortest wavelengths to the left to the longest wavelengths to the right, we have in order the gamma rays, the X-rays, the ultraviolet, the visible spectrum, that tiny little bit in the middle full of colors, Then we have the microwaves and the infrared, the microwaves, and then the radio waves. The part that interests us is that it's that tiny bit in the middle. So that's what we call the visible spectrum. It goes from about 400 nanometers to 700 nanometers. And all of us, these are the only wavelengths that we can see. Why does this matter? Our eyes, like I said, are receptors. They're actually made of millions of small receptors called cones. Most of us, almost everybody, has 3 types of cones that can detect different parts of that spectrum. So you see the spectrum here at the bottom. Those are all the wavelengths of colors that we can see. And this diagram shows in 3 different colors the sensitivity of each type of cone that we have in our eyes. They're called short, medium, and long. Sometimes they're called blue, green, and red. It's not technically accurate to call them red, green, and blue. So instead, we're going to call them short, medium, and long. And they're called that way because the short ones help us see in the blue wavelengths, so ultraviolets, violets, and blues. Then we have the medium ones that help us see the greenish colors, and the long ones that help us see green, orange, yellow, and a little bit of red. And you can see there's a lot of overlap between the medium and the long wave, the longer receptors. So now, what is light? So light is a distribution of several wavelengths. So this is what we call the spectral power distribution of a light bulb. So the kind of light bulbs that you can find in any house. It's an orangish light bulb, and you can see the amount of energy it outputs in different parts of the visible spectrum. And you can see here that this type of light bulb outputs most of its energy in the red and orange part of the spectrum, and that's why we perceive it that way. But what happens when the light from that light bulb hits our eyes? So we saw that we have those receptors. They have different sensitivities to different parts of the spectrum. So we just multiply the distribution of the incoming light with the sensitivity of our different cones. And the result is what we perceive. So when we multiply both, we get this. So when you look at one of those light bulbs, you see almost nothing in the blues. You see a little bit of green and more orange and red. And then our brain will interpret that as an orange color. The way we actually interpret the result of those cones is a little complicated, and we don't have time to go into the details here. You can go look on Wikipedia how it works if you're interested. So here's what happens exactly when we look at a light source. The light is emitted by the light. There's wavelengths emitted by the light source. It hits our eyes. We multiply by the cones, and that's what we perceive. But most of the time, you're not looking directly at the light. You're looking at different objects that surround us. And how do those objects get their color from? So every object also has what's called a spectral power distribution. It's a description of the wavelengths that the object can reflect. We call that the reflectance. So some of the wavelengths will be absorbed. So for instance, a black object absorbs almost everything that's incoming, and a white object will reflect pretty much all the wavelengths. So we also multiply, to perceive the color of an object, what happens is that we have light coming, it bounces off an object, some of it is reflected, so we just multiply the 2 distributions, then it hits our eyes, and we get the final perceived color. What's very interesting here is that any combination, because it's a multiplication, any combination of light and reflectance can yield to the same perceived color in our brain. So a very simple example is that if you have an orange object lit by a white light, you're going to see it orange. But if you have a white object lit by an orange light, you're also going to see it orange. And our brain does a lot of post-processing, really, to help us understand what is the color of the light, what is the color of the object. And a few years ago, there was this famous example of the dress. Some people were seeing it in black and blue, some people were seeing it in gold and something else. And that's exactly what's happening, is that some of us were interpreting the result differently. And nobody was wrong. It's just without the context, you can't really know for sure. So yeah, we can swap the colors, the distribution of the light source and the object, and we're going to see the same result. So that leads us to something called the chromaticity diagram. It was standardized in 1931 by the Commission Internationale de l'Éclairage, CIE. It's French commission, apparently. And it represents all the colors that we can perceive as human beings. So on that horseshoe shape, the outside edge is called the spectral locus. It represents all the pure colors, the pure spectral colors, so that spectrum of colors that we saw in the previous diagrams is actually bands around that edge all along. And everything in between, all the colors that we can actually see, are a mix of all those different wavelengths. then, so it has that weird shape. It's not a rectangle or anything. And there's a lot of colors that live outside of that spectrum. We call them the imaginary colors because we cannot see them. No matter how hard you try, you won't be able to see those colors. There are some optical illusions that you can find online that will kind of help you find those colors. It's actually really weird. Not everybody can see them or perceive them. There's one, for instance, where it shows you a blue rectangle for one of your eyes and a yellow rectangle for your other eye. And the way I see it is this really weird color that you can't really describe that keeps changing from blue to yellow, but never stops on one of those two colors. The visible spectrum is actually a little bit more complicated than that. What you're seeing is a slice. It's a 2D slice. There's a z-axis that's coming towards you, and that is the brightness. So the footprint at the bottom, like this large footprint you see, is the dark colors. It's because our eyes are better at seeing dark colors than they are at seeing light colors. So we've seen what colors are for us as human beings, but everybody's a developer, I think, in the audience. So the real question is, what is color for us as developers? What does it mean for your application? So color really is an encoding scheme for brain sensations. And the formal definition is that it's a tuple of numbers or list of numbers defined within a color model, and it's associated with what we call a color space. And we're going to look at some examples to make you understand that. So here are some of the color models that you might be familiar with. RGB is one of the obvious ones. I'm sure everybody's used that. CMYK, if you have ever printed a picture or a book or something, you might have also dealt with it. And there's another one, for instance, called LIB. There are others. There's XYZ. There's many others. What's interesting is that the color model defines how many numbers we need to define a color. So you're used to RGB. It has 3 colors. It has 3 values. But CMYK requires 4 values, for instance. So the one that we're interested in today is the RGB color model. It uses a triplet of values, hence the name. And you are mostly, I'm sure most of you or all of you are familiar with the hexadecimal notation. So there are many ways of representing that tuple of numbers. This is one of them. It's pretty popular, especially on the web. You've probably used it a lot on Android when you want to pass a color directly to one of our APIs. So this is a pinkish color. So this is the same color represented as a triplet of 8-bit unsigned integers. You're also most likely familiar with it. This is something we use a lot on Android when you set the color on the paint or when you use the color.red to extract the red component of a color. This is another notation. This is actually the one I prefer. This uses floats. So the values are between 0 and 1. And it's interesting because it's more versatile. You can use it to represent HDR colors. And we'll see that Android actually makes use now in O of the float notation to have negative colors and colors that go beyond 1. So to reproduce colors, so the big question is, once we have those numbers, what colors do they actually represent? So I told you this is a pink, but you've seen that spectrum of colors. There are many, many, many pinks. There's actually an infinity of pink. So which one of those pinks does this represent? So to reproduce colors, all of our displays use additive light. So we use red, green, and blue. And our TVs, our phones, our computers, our old CRT monitors, and they just mix those different lights. So the numbers that you just saw, the RGB triplets, it might sound obvious, but they're an intensity for each one of those lights. So let's say we pick 3 lights. We pick a green light, a red light, and a blue light. And they're not perfect spectral lights. They're just random lights that you found. They are found somewhere in the visible spectrum, and together they form a triangle. So when you have an RGB color in your application, you are just, you can only represent one of the colors within that triangle. You cannot represent colors that live in the entire visible spectrum. So, and that triangle is what we call a color space, and there's an infinity of them. Depending on the 3 lights you choose, you can represent any of an infinity of color spaces. So here's, for instance, the widest, or one of the widest color spaces we could create. The problem we have is that with a triangle, with just 3 lights, we cannot encompass all the visible spectrum. We have to choose a smaller slice. So this one in particular is called the Adobe Wide Gamut RGB color space. There's no device that I know of that can capture or recreate this color spectrum, this color space. And the problem is that if we wanted to create a color space with RGB that contains all the visible colors, we would have to create lights that are in the imaginary space, so lights that we cannot perceive because we've seen that our eyes cannot perceive outside of that horseshoe shape. But color spaces are a little more complicated than that. So color spaces are actually defined by 3 components. The first ones are called the primaries. There are 3 of them. Then we need a white point, and then we need something called transfer functions. So this might look like a complicated diagram, but what I did is I've put the visible spectrum on the left, and I've overlaid 3 triangles that represent 3 common color spaces that are used for still images. So the smallest one you see in the middle, the blue triangle, is the one we call sRGB. I'm sure you've heard that term before. So sRGB stands for standard RGB, and it was designed in the 90s, and it kind of matches the reproduction capabilities of the CRT monitors of back then. And to this day, it's still used everywhere, and it's pretty much the universal color space, the only color space that you can count on. There are other color spaces. There's Adobe RGB, for instance. It's the orange triangle. Because it's bigger than the sRGB color space, we say that it's a wide color space, or it's a wide gamut. So the 3 vertices of the triangle is something we call the gamut. And then there's something called Prophoto RGB that you can see extends beyond the visible spectrum. And this is not a color space that we use to actually represent colors on the screen. This is what we call a working color space. For instance, when I take a picture with my camera is set to Adobe RGB, so it captures everything in the color space that you see on screen. Then when I import my photo in Lightroom internally, Adobe Lightroom works in Prophoto RGB. And it won't be able to recreate all the colors that it's working with on screen, but the idea is to have as much precision as possible. So you can ignore this kind of color space for your needs on Android applications. So I said a color space has 3 primaries, and the primaries really are the coordinates of each one of the 3 vertices of a triangle in that chromaticity diagram, in the visible spectrum. So they identify, when you say, for instance, that you want a color that's red equals 1, green equals 0, blue equals 0, it tells you what red we're talking about. And if you look here on the screen, sRGB and Adobe RGB, when you say red equals 1, they have the same exact red, but Prophoto RGB has a different red. So it's 2 different reds for us, not necessarily for our computers. We'll take a look at that. And then we also need a white point, and the white point is the same idea. It gives us the coordinates of white in that color space, and we'll get back to that. So I also mentioned transfer functions. Transfer functions are a little bit complicated. That's where a lot of math comes into play. You've probably heard about them under the name gamma. So if you heard about gamma correction, that's actually transfer functions. So I gave a talk last year about transfer functions. I don't have time to talk about them today. I'm going to show you a link at the end of the talk. If you're interested, you should definitely go look at that talk. There's a lot of things that you should learn about transfer functions that can impact your applications. So I've been talking about color spaces, but why do we care so much about color spaces? So the problem is that every device out there has a different color space. So for instance, you can have a phone that has an LCD screen and it's going to be close to sRGB. You have a phone that has an OLED screen and it's going to be closer to P3, to a color space called P3, or to the Adobe RGB color space that we just saw. And same thing for your laptop, for your computer, for your TV. And things get even worse, because even if you have 2 phones, they're the same model, there's the same manufacturer, they're both supposed to be, let's say, P3, there are variations in the manufacturing process, so they won't be the exact same P3, so the colors won't be exactly the same on those 2 devices. And I'll show you an example of what happens. So let's imagine that we have content that we created for sRGB, so it's in the sRGB color space. We designed it at home on our computer that shows sRGB colors. That's the white triangle you see. And then if we take that content as is, we don't do anything to it, and we just show it on a display that's Adobe RGB, what we're going to do is we're going to just take those RGB triplets, those values we had, and reinterpret them in a different color space. So suddenly, your green that you had in sRGB, like that green equals 1, is going to be a different green. It's going to look completely different to your user who's using an Adobe RGB screen. So here are concrete examples. This is a photo I took. I took it in Adobe RGB. I processed it in ProPhoto RGB. I converted it nicely on my calibrated monitor to sRGB. This is what it should look like. Actually, this is not what it should look like. On my laptop, it's what it should look like, because those screens have a color space. I have no idea what it is, but it's definitely not sRGB. And what you see is really wrong. But what matters is the difference between the next photos. So let's say that this is proper sRGB. This is how I wanted you to see the picture. Now, if I display the picture as is on a different screen, let's say DCI-P3, it's going to look like this. So if I go back and forth, you can see there's a difference in contrast. Some of the colors are a little bit more saturated. So already, my photo does not look like the way I intended. Then if I display it on a ProPhoto RGB display, if such thing existed, it would look like this. So super saturated, really garish. I don't know about you, I really don't like this picture. And those are only when that happens when we only affect the primaries. But you can have similar issues when you affect the white points. So the next slide here, that is the same sRGB photo, so we kept the primaries, but I changed the white point to something that's bluish. And suddenly my photo, well, you know, it's underwater, so it kind of makes sense to be blue, but it is not the way I wanted it to look like. So again, if you take multiple Android devices, for instance, and you put them side by side, chances are that some screens will appear yellow to you, some screens will appear blue to you or green, and that's because of the white point. We have different white points across multiple displays. And once again, the same model of device from the same manufacturer, there are going to be white point variations. So when this happens, we say that colors are unmanaged. This is what Android has been doing since Android 1.0. And I hate it, absolutely hate it. It's horrible. You know, your designers will spend hours and hours like slaving away on their computer, like creating a beautiful UI. Then you test it on a phone, and it looks completely different. And you test it on another phone, and it looks completely different again. So you might be thinking, how can we have our design look exactly the way we want? So the solution is something called color management, and it's new to Android O. So the idea is that every color that we want to display needs to be associated with a color space. We need to know what was the original intent of the design. So we need that information. Then through the magic of a lot of math and matrices, it's actually a little more complicated than just a matrix, but that's most of it, we're going to do a controlled conversion to the destination color space. So what we're going to do is that when we manufacture a device, we're going to use special devices that will measure the capabilities of the display. We're going to measure the primaries and the white point of the device. We're going to create the destination color space. And then we can convert your original content to the destination color space and preserve the same colors that you wanted to have. So this is something we're introducing in Android O. And there are two parts of it. There's first color management proper, and then there's something called the white color gamut rendering. We're going to take a look at both. But first, before you need to worry about Android, you need to make sure that you or your designers are using color spaces properly in your design application. And there are two things you can do with pictures. You can assign a color space, or you can convert a color space. So I'm going to switch to a demo. But first, I just wanted to show you, earlier I said that color spaces, this chromaticity diagram we had, the horseshoe shape, it's a slice of a color space. And so are the gamuts, those triangles. So this is sRGB in 3D. And it's interesting because I mentioned that our eyes see more in the darks, and you can see that in the diagram. The brighter the colors, the fewer hues we can perceive. All right, so for the demo, so I'm using a tool called Affinity Photo. And this is a picture I took, same process. You know, I took it in Adobe RGB. I was using raw files from my camera, from my DSLR. I used ProPhoto RGB to do my work in Lightroom, and I created an sRGB version of the picture. And if we zoom in, pretty much any good design tool somewhere will show you the color space of your image. So here we know it's an sRGB image. I'm on a calibrated display, it looks fine. And like I said, you can assign a color space, often called an ICC profile, or you can convert. So if you assign, what you're saying is you're just saying, keep the colors the way they are, keep the same values. I just want to move them to a different color space. So let's say we move to the ProPhoto color space, and now it looks like this. This is exactly what Android does. This is not the right way of doing it. Sometimes that's what you want because you know what you're doing, but very often it's not going to be what you want. So instead, what you want to do is to convert ICC profile. It's sometimes called match. So we pick pro photo, and when I click, you'll see no difference. And this is what we wanted. But what happens is that every single RGB value has changed. It just looks the same. We just have different values stored inside the image. And to give you an idea of what happens to your Android design, so this is a screenshot I took of my Pixel 2016 running Android N. And on Android, we pretty much assume that all the content is sRGB. So when I opened this file in the tool, I was warned that there was no color space and that the tool would assume sRGB. Now, when you display this screenshot on an OLED display, because we don't manage color, what happens on my Pixel 2016 is this. So I hope you can see the difference. If you look at the red icons at the bottom, you can see that everything becomes more saturated. So that's what you designed, and that's what you see on an actual phone. All right, so when you don't know what the color space is, just assume it's sRGB. It's the only assumption you can make. And this is why, like, for instance, all my photos are sRGB, because when I put them online on the web, I have no idea what display you're going to use. I have no idea what device you're going to use. I don't know if your app is going to be color managed or not. And sRGB is your safest bet. It won't be always correct, but it's your safest bet. So when you use a design tool and you have a color picker, if there's no information about the color space anywhere in the tool, you are most likely using either sRGB or what we call a native gamut, which is whatever the screen can do. For instance, this is what Apple Keynote does. When you pick a color, you pick the color directly for your display and not another display. If your application is color managed and your document has a color space, you're picking a color in that color space. Some color pickers are more advanced. So this is, for instance, on macOS Sierra. If you click that little gear in the second tab, you can choose the color space you want to use for the color picker. And actually, when I was working on the slides, I picked colors for the slides, and then I was creating diagrams into a different tool, and I tried to match the colors, and I forgot that I had to change to sRGB in this speaker, so it took me 5 minutes to understand why my colors were different. So even when you know about color spaces in color management, it can sometimes be confusing. Another tool you can use on Mac, on macOS, for instance, and other platforms have similar tools, is the digital color meter. It's in the application/utilities folder. It lets you pick any color on the screen, and using the drop-down, you can choose the color space you want for that color. So you can look at the color in the native gamut of the display, or you can use sRGB or P3 or whatever. On Android, if you have a recent version of Android, and if you have a Pixel device, for instance, if you go to the developer options, you can turn on the sRGB mode. So here what we're going to do is apply color correction. We're going to apply color management to the display to make sure that all the colors are interpreted and reproduced as sRGB. You might be surprised at first. A lot of people complain that the colors looked washed out, but they're actually more accurate. It's just a matter of habits. All right, so now some code. So on Android, what you've been using so far is what we call the color int, just an int. It contains alpha, red, green, and blue. And the only assumption we can make, because we don't know what color space you're using, is that it's sRGB. So it's pretty simple. Now in O, we're introducing a crazy new API. We've had that color class for 10 years, but it only has static methods. Now you can create instances of the color class. You can actually use color as the way it was meant to be. So you just call value of, you give your RGB values, and that's going to give you an instance of the color class in sRGB. Because note, I didn't specify the color space, so my assumption is it's sRGB. You can also specify the color space. So here we also call value of. We pass the alpha, so the order is RGBA when it floats. And then we say that we want that color to be in the Adobe RGB space. What this allows us to do is work with colors so we can convert them from one color space to the other. So I have this Adobe RGB color, and if I call convert, I can convert it to display P3, for instance. Someone's happy? Something else we're introducing, so color ints are really useful because they're easy to manipulate, they're small, they're easy to store. And color objects, the color class is very generic. It can represent colors. It uses a float array internally. It has a reference to color space, so they can be pretty heavy object. So now we have something we call the color long. It's the same idea as the color int. We use a primitive type to store a color, but we also store the color space for that color. So it's similar to value of. You just call pack instead, and you get a long. And here's the format of the long. So we have 16 bits for the red channel, 16 bits for the green channel, 16 bits for the blue channel. We have 10 bits for the alpha channel, and then we have 6 bits that identify one of the built-in color spaces. And those 16-bit values, they use something called half floats. So they're floats that use only 16 bits instead of 32 bits. So there's a new API in O called android.util.half that lets you manipulate half floats. Anybody who does HDR or advanced rendering in OpenGL or Vulkan might find that API useful. If you use the color class, you don't have to worry too much about it. There's a ton of utility methods on color that will use the half API on your behalf. So we also have the color space class. It's well documented. It's pretty easy to do. You just call get, and you can create one of the common color spaces that we provide. You can create your own color spaces if you want. Two methods that are interesting on color space. There's isWhiteGamut. It will tell you if it's a wider gamut than sRGB. And getModel, it will tell you how many components are in that color space. So RGB, CMYK, LAB, stuff like that. If the model is RGB, you can cast it to colorspace.rgb. That gives you access to more APIs. You can query the primaries. You can query the white point. You have access to the transfer functions. This is also very well documented. If you want to do conversions between color spaces, it's pretty simple. You call connect. You give us the source color space and the destination color space. And the reason why you need to call connect is that we need to make sure that both color spaces use the same white points. So when the color spaces have different white points, we do a little bit of math internally to turn them into the same, to make them use the same white point effectively. So then if you call the transform method, you can give us RGB values, and we're going to give you back the corrected RGB values. You can also change the white point of a color space. So if you call adapt, colorspace.adapt. So here, for instance, we do what I did for one of my examples, my photo of the fish that was very blue. We took the sRGB color space, and I changed the white point from something called D65 to something called D50 that's bluer. White points are usually defined as a color temperature. It's the perceived color of a black body when you heat it to that temperature. So here, D50, it's 5,000 degrees Kelvin, and it's blue. And D65, which is a very common white point in color spaces for our monitors, it's 6,504 degrees Kelvin, and it's more yellow. Bitmaps, we now support color spaces embedded in bitmaps, so they're called ICC profiles. Until now, we would just ignore it completely on Android. So if you use Bitmap Factory to decode a bitmap, now you can call get color space on the bitmap, and we're going to tell you what it is. Most likely, for most images you're going to load, and presumably for all your resources that come inside your APK, the answer is going to be sRGB. So you can call color space.is sRGB to check what kind of color space it is. And that's very important. All the bitmaps on Android are always in the RGB color model. We might expand on that in the future, but we don't let you use LAB or CMYK or XYZ or any of that. They're always RGB. So you can, right now, when you call get color space on the bitmap, you can always cast it to color space at RGB. It might not be future-proof, so just make sure by checking the color model. You can do more interesting things with Bitmap Factory. So on bitmapfactory.options, we have this horribly named field called in just decode bounds. It was originally created to let you query the dimensions of an image without having to decode all the pixels in the image. So it's really quick. It gives you an idea of how big the image is going to be. Over the years, we've kind of abused this field. So now it's going to tell you the configuration of the bitmap. Is it ARGB 888? Is it RGB 565? And now it also tells you what the color space is. So if you want to know the color space of a bitmap ahead of time, you have to ask us to give you just the bounds, just the dimensions. So you call your decode method on Bitmap Factory. You pass your options. And then we have this field called out color space that tells you what is the color space of the bitmap. So if you want to make sure that the bitmap is in the right color space before loading it, you can do this. And if it's not in the right color space, you can use this other API on options called in preferred color space, where you can tell us what you want the color space of the decoded bitmap to be. So in this example, for instance, let's say we queried the color space of the bitmap. We saw that it was Adobe RGB. I don't want Adobe RGB. I want sRGB. So I can use in preferred color space to force the system to convert it at load time. Then you can just call decode. We're also introducing in Android O 16-bit bitmaps. So they're bitmaps that use 16 bits per channel. And those bitmaps are always, always in a color space called linear extended sRGB. And we're going to take a look at what it is. So when you have a 16-bit bitmap, don't try to convert the color space. We're not going to let you, at least for now. This is how you create a wide gamut bitmap. You just create bitmap. You specify the width, the height, the configuration. The Boolean tells us whether there's alpha in the bitmap, and then you just give us a color space. So pretty simple. Bitmap has APIs that let you read and write pixels inside the bitmap. So because getPixel and setPixel use color hints, they have to use sRGB. So when you call getPixel on a bitmap that is not sRGB, we're going to do a conversion for you. Same thing when you call setPixel, we expect sRGB, so you have to do conversion yourself. Now, if you use this other API called copy pixels to buffer, it gives you access to the raw data of the bitmap. So that data is going to be in the native color space of the bitmap, left completely untouched. You have to be a little bit careful because of that new configuration for 16-bit bitmaps. So if you load the 16-bit PNG, the data in that byte buffer is going to be half floats. It's not going to be those color hints. And that's why you might want to take a look at android.util.half. All right, so now what happens when you draw bitmaps on the screen? So until now, what we are doing is we take a bitmap, we assume it's sRGB, we send it to the screen, and if the screen is not sRGB, too bad, the colors are going to be completely wrong. This is still what we do by default on Android O. Now, if we have a bitmap that we know is not sRGB, it has a color space associated with it, we're going to do an sRGB conversion on your behalf in the rendering pipeline. It can be a little bit expensive, so you should avoid it as much as you can if you don't need non-sRGB bitmaps, but at least the colors are going to be correct on the display. Now, if you render a bitmap into another bitmap, so if you create a bitmap, you create a canvas, and then you call draw bitmap on that canvas, we're going to convert from whatever the source color space is to whatever the destination color space is. So if you want to convert a bitmap from one color space to another, not at load time, this is the way you do it. You just create the destination bitmap, you create a canvas, and you just draw. So pretty simple. So we make all those assumptions about sRGB, but like I said earlier, if you remember, I said that OLED displays on our phones have wide gamuts. They can show more colors than sRGB. Now the problem is that if we take your sRGB content and we don't stretch it to the entire gamut of the display anymore, and we keep it in that little triangle, we have all those unused colors that we're not taking advantage of. So in Android O, we're adding this new API, and it's super complicated. It's just one attribute that you add to your manifest per activity. You have to tell us that you want to render using those extra colors. You want the wide color gamut mode. The way it works is as follows. So if you have sRGB content, if you're on a device that does not support that mode, not all devices will support that mode. So if you're on a device that does not support that mode, your window is going to use the ARGB 888 format. That's what we've been using for 10 years, so there's nothing new there. You have your sRGB content, we just draw it directly on screen. If you have non-sRGB content, we convert it to sRGB and we send everything to the screen. Colors might be wrong, but that's just because the device does not support the new wide color gamut rendering. On a device that does support wide color gamut rendering, we're going to make a much larger window. We're going to use 16-bit per channel, so it's going to double the size in memory of your window. It's going to double the needs in bandwidth. So it is an expensive thing. So if you don't really need wide color gamut rendering, think twice before enabling it. If we have sRGB content, we're going to send it directly to the display as well. And if we have non-sRGB content, we're going to convert it to a color space called extended sRGB. And what is extended sRGB? It's a kind of a weird color space. It's a really big color space. It's way bigger than the visible spectrum, much, much bigger. And some of the values are negative, and some of the values are greater than 1. They go all the way to 7.5. And what's interesting about that color space is that all the values between 0 and 1 match exactly the sRGB color space. So what it enables us to do is we can take your existing content, all your sRGB content, basically everything you have in your app today, and we can draw it directly. We don't need to do any conversion because it's going to match sRGB. So what we do is we only pay the cost of a conversion when we're drawing non-sRGB content. So we have, the expense is that we need 16-bit per channel because we need a lot of precision and range to be able to encode this sRGB space. but it's much better for you. It's much simpler. You just have one attribute in your application. Interestingly, because we use 16-bit per channel, because of extended sRGB, we can, or we will be able to, maybe in the future, to render in HDR directly. So we could have HDR user interfaces. We also have a new resource qualifier called white-CG for white color gamut. So you can create layouts or strings or drawables that are specific to a display that supports the white color gamut rendering mode. We also have a few APIs that you can use to query whether the device supports white gamut. So if you have a resources instance, you can grab the configuration, and the configuration will tell you if you have a white color gamut display. If you have a view, you can call getDisplay. We give you a display object, and you can ask the display whether or not it's white color gamut. So the main conclusion of all this is don't panic. I put a bunch of hearts on the slides to make you feel better about all this. I know it's complicated, and no matter how hard you try, and I don't want to sound disheartening, but your colors are going to be wrong somewhere for someone. Like, they're wrong for me on that screen. And I know a little thing or two about color spaces and color management, but you're not in control of everything. You're not in control of the final display, and you're not in control of all the software that intervenes in the pipeline of an application of rendering colors. So don't worry too much about it. Do your best. Make sure that your designers work on calibrated displays. Make sure they work in sRGB. Make sure the images contain color spaces, and you should be OK, or at least mostly OK. So if you want to learn more about transfer functions, so there's this talk I gave last year with Chet. So if you go to that URL and you go to minute 29, that's when the color part of the talk starts. The first half is about animations. It's also super interesting. You can also look at the documentation for colorspace.rgb. There's a lot of details and information about transfer functions and what they mean for you. If you want to learn even more about colors, I gave a talk at Devox US a couple months ago. I talked about bending and dithering. What is bending? How can you fight it? What do we do in the platform to fight it on your behalf? So if you're interested, go at that URL, and it starts at minute 36. And I think that's it. I only have 1 minute left, so I don't have time for questions, but I'll be at the Android sandbox if you want to talk more about color and color management and all that. Thank you.
What's up, everybody? David here, and today I have a quick and easy Firecast for you. We're going to get up and running with Firebase and the web. And this is actually going to be the first of many screencasts in a series. So make sure you subscribe to get notified of tutorials on authentication, storage, hosting, and web push notifications with Firebase Cloud Messaging. Also, if you're a fan of JavaScript frameworks, I'm going to be dropping videos for Angular 1 and 2, Polymer, React, and Ember. So you better subscribe because you don't want to miss those. But today we're going to start with the very basics. I'm going to show you some mad copy and pasting skills by getting the project initialization code from the Firebase console. And then we're going to set up a small web app. So let's go and dive in. So I'm in the Firebase console at console.firebase.google.com. You can see I'm logged in as myself up here, just smiling at you. But to get started, I'm going to create a new project. So I'm going to click Create New Project. I'm going to call it Web Quick Start. And then we'll create it. My project is now created. So I'm going to click Add Firebase to your web app. And this brings up a little modal with all the initialization code I need to get started. It has things like my API key, auth domain, database URL, and storage bucket. So then I can go to the bottom right, and then I can click Copy. And that's all the code I need to get started. But just as a little FYI, you can access all of this information by clicking Auth, and then going up to the top right where there's Web Setup. But now, to the editor. So here in my editor, I'm going to get crazy. I'm going to create this web page from scratch. So I'll start with my basic HTML boilerplate, give it a title, and now I can just paste in all the code from the console. And this is all you need to get started. And just to prove that it works, I'm going to use the database as a little tiny demo. So I'm going to create an H1 and give it an ID. And every single time the value changes in the real-time database, I'm going to sync it to this H1. So the first thing I need to do is get that H1 by its ID. And then now I'm going to create a database reference using firebase.database.ref and then create a child location to the text location. And now I can synchronize any changes using the on function. And then using ES2015 arrow functions, I can just do it all in one line. So to the left right here, I have my project in the Firebase console, and to the right is just my blank page. To use the database, I'm going to remove all security. So I'm going to click Rules, and then I'm going to say Read is true and Write is true, and click Publish. And you should totally know that you only do this while you're developing, because that means anyone can read or write to your database. So now I'm going to give my browser a refresh. And then I'm going to add a text location. And it synchronizes to the browser. And so I can change it, and then it changes as well. So keep in mind that the real-time database is just one of the many features Firebase offers for the web. You can also use authentication, storage, hosting, and even Firebase cloud messaging. So that's all it takes to get started with Firebase in the web. And if you want to go and learn more, then check out the link in the description for our official documentation. And if you're super excited to learn more about Firebase on the web, then please subscribe to our channel because we're going to have tons of more content. So that's all for this time, and I will see you all later.
We started Is on a living room couch, and we really started because of the problem that we had, which was asking the same question to our closest friends. Where are you? What are you doing? We were baffled by the fact that there wasn't a solution that solved this problem, and we felt like we could build one that was better.
The value that Is drives for all users is knowing which of your friends are nearby. So if you look around where we are right now, an arena, how many times have people gone to a basketball game, hockey game, or a concert and found out the next day that they had friends who were at the same event? And think about all those moments that are missed because they didn't know they had friends there. So what we're solving is letting people know who's nearby and making those moments matter.
My name is Diesel Peltz, and I'm the founder and CEO of Is.
I'm Mark French, co-founder of Is.
We felt there was no reason users should manually go fetch data. When I get a text message, there's no reason for me to tap refresh. And we felt, why should it be different from anything else? And Firebase let us solve that. Firebase really allowed us to enhance the user experience by making it real time, simplify the UI by not having a refresh button, and cut down on development time.
Like any startup, the most valuable asset that you have is your team and your time. And what Firebase has allowed us to do is save 50% in terms of time by moving that much quicker with a product. It's a game changer.
We're using 8 features from Firebase right now. They're analytics, remote config, dynamic links, the real-time database, and more. Traditionally, that would have been in 8 different places. And now we go to one place, which is the Firebase console.
We're eager to launch this product in a big way. We're seeing how people are using the product and how they're inviting more and more friends that we're concerned. We're growing very, very quickly. So we sleep a lot easier at night knowing that we got Firebase that's really there to build that infrastructure.
If you're a developer, use it. We love it, and it's enabled us to focus on developing the user experience and not have to worry about the things in the background that should be there.
Yeah, with NPR One, we are reimagining what a listening experience could be outside of the radio.
It's the radio, but better. It has all of the great stuff that we've spent 40 years perfecting.
With NPR One, we see the opportunity of reaching a more diverse audience that have a device in their pocket at all times.
My name is Mike Saiflahi. I'm the lead mobile developer for NPR Digital Media.
My name is Nick Dupre, and I'm the innovation accountant at NPR.
My name is Tejas Mistry, and I'm the senior product manager of NPR One.
Just some of the biggest challenges in any mobile app are that first impression. When the user first installs the app, you've got a very limited amount of time to convince them to keep the app and to get engaged in the experience. trying to figure out how we can get users into the content as quickly as possible was the real focus of integrating Firebase and dynamic links. Using dynamic links, we were able to shorten the number of interactions it takes for a user installing the app to get from the promoted content to the content from 20 to 3. So that user is able to get right into the content.
We're driving more and more listening per user every week. It's really astounding. Creating playlists of content that are configured by the podcaster or by a member station or by us internally. And with Firebase, we have that at our hands.
Having the analytics product interact with things like dynamic links, remote configuration, cloud messaging, it adds a real multiplier effect.
And the integration with the broader Firebase suite, I don't have to go outside the platform to figure out what's working. So it's not just about shipping the product faster, it's about analyzing the results faster. And with the integration with all the other Firebase products, we're really excited about all the things we can learn from it.
Raise Labs is a company that is focused on building excellence in software, technology, and design. We do that through our work on mobile applications and websites and technologies in general. My name is Gregory Raise. I'm the CEO and founder of Raise Labs. We really want to understand the human problem, and oftentimes the hard problems in software aren't just the technology problems, the API, the how do you connect these things, but really getting at the heart of what people are trying to accomplish and do in their day-to-day.
My name is Ben Johnson. I'm the managing director at Raise Labs in Boston. We decided to put our hat in the ring for the Google Certified Agency Program. The first leg is just having access to a lot of what Google is doing today. So there's access to design reviews, invitations to events, and that's sort of the base level. And I think that's hugely rewarding even in and of itself. Having Google review your app from a design perspective is amazingly helpful. So that's sort of the first tier. The second tier comes with certified status. There's a long application process for that. And once you have it, it's something that you can really say to your clients that gives them comfort that we're a reputable firm, that we're building great software in a way that Google believes in.
The certification is a higher bar for us to really differentiate ourselves from many of the other companies out there. It required us to really dig into what that means to be truly world-class, and we wanted to set that bar for ourselves as well.
My name is John Green. I'm a VP Creative at Raise Labs. The Google Developer Agency Program allowed us to have access to engineers for the map team, the design team, to figure out, how can we actually do some of these things? And we could reach out to them when we needed. And also it allowed us to set up and say, we can make this a success. They might look closer at this app because we're part of this program, which has actually been super helpful.
Some of the challenges in building the Six Flags app, and we touched on some of these, are certainly mapping technology and payment technology, material design, or the APIs. Having access to the Google team to really ascertain how we're approaching certain software and ensuring that we're building technologies the right way makes for a smooth development process.
We set off to build the Six Flags app with a pretty lofty ambition, and it was to bring in-park navigation and commerce to the app. The comfort of knowing that Google is there to help us understand where they are heading as an organization and that we are along for that ride is a really helpful thing to know. And as a business, we know that going forward, we're going to be at the cutting edge of whatever Google is doing through access to programs, through the collaboration with their teams. It's really helpful for us to know that 6 months, 9 months down the road, we'll still be a part of that process, and we'll still be working with them to figure out what's next.
Oh.
Hey, Timothy. How's it going?
It's going great. This is Brad Abrams. Brad is a product manager on Assistant.
That's right. Yep. How's it going, Timothy?
It's going great. now that you're here and I'm here, I think we should talk about the assistant. What do you think?
I think that sounds like a great idea because it's the only thing I know to talk about, so perfect.
All right, let's start with square one.
Okay.
What is Assistant and why is it cool for developers?
Well, the Assistant is really a conversational interface to Google. It's the kind of smart brain in your Google Home or on your Android phone, and actually at this event we just launched it on iOS as well. And you can have really a conversation with Google to help you get things done.
That's awesome.
I think so.
What are the different surfaces for developers to integrate with?
Oh, great. So there's a couple of different ways. One, you can extend the Assistant by adding your own custom apps to the Assistant. And then you can also host the Assistant in different devices. So if you're building your own hardware or whatever, you can host your Assistant there.
And that's the difference between Actions on Google and the Assistant SDK, right?
Exactly. So the Assistant SDK is where you host it with your hardware, and Actions on Google is extending the Assistant.
Okay. Well, we're at I.O., and I know some new stuff has been announced. Why don't you tell us about some of your favorites?
Oh, man, it's hard to pick. There's so many. I'm really excited about Actions on Google coming to phones, to Android and iOS. So up until this event, you could only build Actions on Google for home, for eyes-only experience or eyes-free experience. And now we have Actions on Google for the phone as well. So we have suggestion chips, lists, image carousels. And it can really give you a deep multimodal experience.
Oh, you mean like seeing and hearing?
That's right. You can see and hear, yeah. We also launched transactions, so you can buy things via the Assistant. I think that'll help users a lot. I know I want to buy a pizza from my phone. I can just say, okay, Google, I want a pizza, and it can connect me with somebody to go do that. And for developers, it also gives a financial incentive, which I hear some developers like to get paid.
Yes.
So
indeed, they do.
And then, of course, deep. For me is developer experience. And we've done a lot of work. We launched the platform first in December, and we've done a lot of work on developer experience. So we launched a new version of the developer console. We call it the Actions console. Developers can use that to work better in teams together, to get deep analytics about their application, as well as it integrates really well with the Firebase and Google Cloud consoles.
Awesome.
And then can I do one more?
Absolutely.
See, I can just add them. So one more would be discoverability. I think that's been, in the whole kind of chatbot space generally, having people be able to discover them has been a problem. And so we've done a lot of work in that regard. The first is that we have a new directory for our apps, and it's right there on the Assistant surface, just one tap away, and you can see a category view of all the Assistant apps that are there. We also gave you a way to get a web URL into that. So if you wanted to promote your app via your enormous Twitter followers, you could totally go do that, which is awesome. And of course, people who love your Assistant app can share it with their friends via the deep link. And finally, we did some work to help discover when to invoke your Assistant app from information in the directory, other information provided by the developer. We can just respond to queries like play a game, and we can actually find the right Assistant apps to go trigger in that case.
That's totally awesome.
Yeah, it's really fun. It's kind of a big release for us here at I.O.
Yeah, I mean, there's a lot of different stuff.
Yes, it certainly is. But I think it comes together in a really cohesive package, though, because if you're going to do transactions, you're going to buy things. A lot of times, having a visual surface to see the different options, see the cart and whatnot, really helps with that. And then, of course, if you're going to have a financial interest there, being able to have people discover your Assistant apps really helps.
Awesome. Okay, so let's take a step back, and I would love to hear your thoughts just on conversational interfaces in general.
Yeah, I mean, if you think about this evolution that's been happening, like when I started using computers, it was like mouse and keyboard. It was very indirect, right? You move.
Wait, you had a mouse?
I did have a mouse. You don't think I had a mouse?
Well, I mean, you start with like the Commodore 128.
Right, yeah. Okay, before you had a keyboard, and then we added a mouse. But these are indirect, like you do something with your hands and something happens on the screen. And then, we got capacitive touch, right? So you could actually touch the screen. And like my kid, when he was 2, knew how to touch the screen, right? Like that was very intuitive. And I think we're at the verge of making the next step. And that is, rather than just being able to like touch the button, what if I could just express what I want? Why do I have to dig through a bunch of menus, find the right button to press, not really sure what's going to happen when I press that button, but what if I could just express my idea? This is what I want to happen. I want to play this game, I want to order this pizza, I want to do whatever. And that's what I think this conversational interface is enabling.
Awesome. I do want to say that I think one of the things that's been holding us as developers back from that is the right tooling to do so.
You know, as I describe that, I think the developers are going like, wow, sure, but how do I do that when the user, if you think about the huge number of ways people could say they want a pizza and order toppings on the pizza, how can they turn the huge vagaries of human language into something a developer can understand? And that's where tools like API.AI can really come into play. API.AI is our own conversation building tool. And what it does is lets you as developers define intents just by giving us some example phrases of what a user would say. And then we can do the, pull out the entities from that and do the natural language understanding so that we can do slot filling and actually figure out what users are saying. So you might give an example like, I want a large pepperoni pizza with tomato sauce is your example. We know it's large is an entity, pepperoni is an entity, and tomato sauce is an entity. We can actually pull those out and then recognize other queries like, I want a small pizza with tomatoes and green olives with no sauce. And that, because we can do that, it makes it much more tractable for developers to actually understand human language.
But seriously, how many times have you ordered a pizza with no sauce?
Well, that's pretty rare, but I'm for extra sauce. Just because it dribbles down your face.
Okay, that's good. All right, is there anything else you want to say about Assistant or any of the developer tools before we go?
No, I think we pretty much covered it.
All right, Brad, thanks so much.
All right, thank you.
Hello, I.O. Last year, I was up on this stage talking about the potential for building progressive web apps with frameworks, the promise of being able to use some of the world's best DX to ship some of the best UX on mobile. In the last year, we've seen massive promise here. We've seen many large global brands start to ship progressive web apps as part of their default mobile experience, and many others starting to experiment with this stuff too. So today we're going to talk about some of the technical insights and the journeys that many of these large companies took to ship these experiences using frameworks. Now, before we get started, I've got a little bit of a confession. Right before I.O., my wife Ellie had to tell me to stop playing video games and start working on my I.O. slides. So I did stop playing video games, and I did work on my slides. I built my I.O. deck as a video game. And my main character is my wife, Ellie. I'm going to get in so much trouble for this. Let's get started. Today, we're going to play progressive web gaps. So let's get started. We go in our first level. We start our quest to building a fast progressive web app using a framework. And we run into Alex Russell, who says, use a JavaScript framework that gives you headroom on mobile. Ignore the fact that he's shooting us in the face with an arrow. What Alex means here is that you need to understand the cost of your abstractions, especially on low-end devices. You see, on desktop, the time it takes to parse and compile JavaScript is often several times faster than it is on mobile, where it can sometimes take 4 or 5 times as much time in order to process. This is one of the reasons why we see a lot of the web apps being built today using frameworks on mobile taking about 15 or 16 seconds to get interactive, unless you're keeping an eye on how to optimize that. Now, in order to help you get fast and stay fast, your framework needs to give you the best possible headroom to succeed. Think of it like a budget. If you're trying to get interactive in 5 seconds, you want to make sure that you have enough budget for your application code and that your framework isn't taking up that entire budget, right? Because if you're going to start slow, you're very likely to stay there. Now, thankfully, over the last year, we've seen a huge increase in the number of good options for starting to build progressive web apps on mobile that have low parse and compile times. In addition to Polymer 2.0, joins us with Preact, Vue.js, and Svelte.js. These are all excellent options, and I'm starting to see an increasing number of companies consider them. Now, over the last year, one of the main pieces of feedback that I've got from large teams that are building, building with frameworks and trying to ship progressive web apps is that they wish they had more reference material. They wish they had better demo apps that showed them how to properly hold a framework so that it would perform well on mobile. And so I got together with a number of different framework authors, and today we're happy to announce a new project that's the successor to To-Do MVC. We call it HNPWA, Hacker News Readers as Progressive Web Apps. This is a new project that has an entire suite of progressive web app references implemented using some of the best practices of today's frameworks. And in case you're wondering, hnpwa.com is a PWA itself. Now, our suite of HNPWA apps includes apps built using Preact, Polymer, Vue, Angular, React, lots of other frameworks. The Preact, Polymer, Vue ones are interactive in less than 3 seconds, even on emerging market connections. And the Polymer one is using the purple pattern, which we'll talk about later, and they happen to be hosted on Firebase functions using H2 Server Push. As is the Preact one. It's using H2 Server Push too. The way that we validate these implementations is using Lighthouse. In fact, we'll link out to a Lighthouse report for every single implementation. And we use web page test to test these apps out on real devices, showing you how long they take to get interactive. So check out hnpwa.com. I hope you'll find it useful. Now, the first framework that we're going to talk about today is React. React has made it painless to create interactive UIs and build components that manage their own state. And just last week, React crossed 1 million NPM downloads a week, a huge milestone for them. And it's being used in many PWAs. The first one we're going to talk about is Twitter Lite. Now, some folks in our team, Alex Russell and myself, we had the honor of getting to work with Twitter on some of their pieces of Twitter Lite. And I thought I'd talk about some of their journey. Twitter Lite took their old mobile website and turned it into rewrote it to be a PWA. And they saw massive improvements in both time to interactivity, the number of tweets sent. They saw a 76% increase in tweets, and a 2.7% increase in page views. Now, one of the other awesome things about Twitter Lite is that it's interactive in under 5 seconds on 3G. Now, using a framework like React to accomplish this on mobile requires a little bit of additional work. So let's dive in to what they used to look like. So the old version of this site, when they were first rewriting it, had a few issues. It was interactive in about 15 or 16 seconds. It was heavily dominated by script. They were using suboptimal loading patterns. And so they had to put in a ton of work in order to get to a good place. And so we return to our quest. And the next place that we get to is performance guru Sam Saccone, who has purple bats that are trying to eat our faces off. Now, Sam has got a pattern that he suggests. He says use purple. only load what you need for the current view. So what's purple? Well, purple is a pattern for structuring and serving progressive web apps with an emphasis on the performance of application delivery and launch. It tries to encourage you to prioritize loading code that a user is immediately going to use, deferring loading other code until idle time. This is a pattern the Polymer team discovered last year, and which has great promise. Now, we're initially going to focus on the push and preload part of this. An idealized version of the purple pattern would try to avoid you having multiple round trips to the server, where you're first of all fetching your HTML, parsing it, and then having to go and fetch all of the other resources necessary for the page by taking advantage of H2 server push. Because everybody in this room, as authors, knows what's important to their pages more than we, the browser vendors, do. And so you can take advantage of things like H2 server push to push, in one RTT, information, the resources that are the most important to your page. And you can avoid having to over-push stuff locally by taking advantage of service workers, so that on repeat visits, you're just reading from the local cache instead. Now, Twitter weren't able to use H2 server push, at least early on in their journey. So they decided to focus on using resource hints and link rel preload. Now, in this case, the first thing they looked at was using link rel DNS prefetch. Now, DNS prefetching with link rel prefetch is an attempt to resolve domain names before a user tries to follow a link. Twitter were connecting up to multiple servers, and they found that by dropping in link rel DNS prefetch for some of these endpoints, they're able to see an 18% improvement in their initial load time. They then explored using link rel preload. Now, link rel preload is amazing. It's a declarative fetch that forces the browser to make a request for a resource without blocking the documents on load event. Now, preload can decouple the load event from script parse time. And in many cases, you're able to get this set up with low friction, even if you're in an app that happens to be using React, Preact, Vue. There are Webpack plugins that you can use to wire up your preload for asynchronous chunks and important scripts in your pages. And in Twitter's case, they saw a 36% improvement just by switching to using this. Now, before preload, the network request usually starts far further down in your network waterfall. And after preload, it shifts to the left, right up to parse time, which is great. Next, we move on to render, so getting meaningful pixels on the screen. Now, Twitter is a heavily multimedia-based application. As you scroll through your timeline, you're going to end up seeing lots of pictures, lots of videos, lots of animated GIFs. And those have a cost. Now, one of the things that Twitter ended up doing was more intelligently taking control of scheduling inside their application. They used request idle callback to accomplish this. Now, request idle callback is a web platform feature that allows you to schedule work when there's free time at the end of a frame, or when the user is inactive. And what Twitter Lite found was that by using request idle callback to defer the loading of images using JavaScript, they're able to see a 4x improvement in render performance. Now, something that we're all still very much guilty of doing is shipping images that just have way too much bloat on the web. And Twitter Lite wasn't an exception. What they found was that in many cases originally, they were shipping images that just had way too much of a dimension. They weren't using all of the pixels that were being shipped down. And those images weren't properly compressed. What they found was that by properly optimizing those images and only shipping down images with the correct dimensions, they were able to both reduce bandwidth as well as image decode costs, in some cases taking it down from 400 milliseconds all the way down to 19. Another thing they did was introduce a data saver mode. As we're on the go, some of us end up on very data-limited plans. And so having a data saver mode that can blur images and videos until they're tapped can actually end up saving us on our data plans. This actually introduced a 70% improvement for many users. Twitter are also investing in trying to explore using the Save Data Client hint, which is a nice other web platform feature here. Now, I've been talking about a bunch of web platform features, but there are also React-specific things that Twitter ran into. On slow devices, they discovered that it could take a long time for their main navigation bar to respond to taps, in some cases anywhere up to 2 seconds. And one of the reasons for that is that mounting and mounting large trees of complex components, like timelines of tweets, can be very expensive in React. Ideally, you want to defer mounting and unmounting those complex trees. And so what they ended up doing was using a double request animation frame trick that was discovered by Owen Campbell Moore recently. And they created a small, higher order component on top of that to improve perceived performance if a component wasn't reacting. This effectively allowed frames to complete, to allow other components to update and re-render before mounting an expensive wrapper component. This led to almost instant changes as soon as you were tapping through their navigation. Another thing that they ran into was a number of cases where unnecessary updates were hurting their performance. Now, in React, whenever a component's state changes, it's going to re-render the component and its children. Occasionally, the component and its children may not have really changed all that much, and yet you end up rendering everything. In this case, in this video, clicking the heart would result in any conversation component also needing to re-render. Using React's should component update allows you to bypass rendering using the virtual DOM completely, and in this case ended up with fewer updates being necessary, as well as CPU cycles being saved. Next, we move on to pre-cache, and we go back to our quest. So who's going to be the next person we run into? Well, the next person we run into seems to have what looks like a JavaScript poop monster, but it's Jake Archibald. And Jake says to leverage the service worker. He promises it won't bite too much. Now, Twitter had a very incremental journey with adding support for Service Worker. They initially, Service Worker cached their static assets, their JavaScript bundles, their CSS, the emoji that you use when you're DMing someone. They then switched up to having a custom offline page, and eventually switched to also using things like the application shell model, so that you're able to load the UI for the experience locally instead of having to keep going back to the network. The result of this is that instead of it taking over 6 seconds on a good 3G network to load the experience, on return visits, pre-cached, it took less than 1.5. This was a 75% improvement for most users. It was definitely worth investing in. In 2017, if you aren't considering using Service Worker, you're leaving potential performance wins on the table. So consider using it. And then we move on to lazy load. And in React, Preact, and Vue, we often end up using Webpack to accomplish this. So we go back to our quest. Now, many people's first experience with Webpack can feel like walking through fire. I love Webpack still. And here we've got that guy there maintains Webpack. And here on this screen, we've got Sean Larkin and Preethi, who work on Webpack, telling us to always bet on it. It is worth using in the long run. The number of bundle savings that you can accomplish using Webpack are phenomenal. And one of the things they've been trying to do recently is investing in a Webpack CLI to help people migrate from Webpack 1 to 2, as well as helping people navigate the Webpack complexity waters a little bit better. But back to Twitter. They tried to get things like code splitting initially set up, but it was tricky. They ended up with 3 JavaScript assets totaling over 1 megabyte in size. That's about 420 gigabytes gzipped. The parse and compile time of that was still really high on mobile devices. We're talking somewhere between 5.5 seconds for most people. So what they ended up doing was investing in code splitting using require.ensure with Webpack 1, and the Commons chunk plugin for extracting common modules across all their chunks, effectively moving them towards route-based code splitting. This meant that they could get faster timeline renders, and they broke up the entire experience into 40 on-demand JavaScript chunks that were amortized over the lifetime of the entire Twitter Lite experience. This meant that it only took 3 seconds on a 3G network, a 3G condition, under a real phone, for this JavaScript to actually process and load. To learn more about Twitter Lite's journey, we just published a case study this week that you can check out. And Paul Armstrong on the Twitter Lite team, who's one of their web performance experts, recently wrote an awesome drill down into their experiences here. So check it out. But they're not the only ones that have been experimenting with some of these ideas. Tinder are also experimenting with a progressive web app. They're using React, they're using React Router, and Webpack. Now, they've seen near instant repeat loads using Service Worker. They've seen a 50% reduction in time to load code just by adopting code splitting and link rel preload. And similar to Twitter Lite, they've also been deferring non-critical work using request idle callback. Now, the important thing to note here is as you hear about all of these stories, the Twitter Lites, the Tinders, the Housing.coms, the Flipkarts, you'll start to notice these patterns form of what different teams are independently running into as things that help their overall performance on mobile. I'm excited to see Tinder's PWA continue to evolve. And they're not the only ones that are working on PWAs right now. The NBA are also working on PWAs using React, and I'm excited to see their work hopefully get released at some point in the near future. And so we return to our quest. And one person that we very regularly bother when it comes to React best practices is Dan Abramov. Dan he worked on Create React App, a zero configuration tool for making a lot of things easy. And so we've been working with Facebook for the last while on something that I think is a little bit special. I'm very excited about it. This change literally landed at 6 a.m. in Europe, like yesterday. Create React App, one of the de facto ways for building React apps, will now give you a PWA by default. Thank you. I'd like to thank Dan Abramov, Tom Alcacino, and Jeff Posnick on our team for all of their work in making this possible. This is a huge shift for the ecosystem. As we start to see more and more frameworks in their tooling adopting progressive web apps by default, we're able to shift that baseline closer and closer to tools like Polymer App Toolbox. And so what does Create React give you out of the box now? It gives you progressive web app support with Service Worker for offline caching. It gives you code splitting with dynamic import. It gives you support for Webpack 2, where you can import in ES modules, as well as support for performance budget tracking, so you can stay on top of your performance. It gives you helpful overlays for uncut errors, and has Jest 20 built in there as well for snapshot testing. I'm really excited about this release. This is one of the biggest Create React App releases that have been out in a while. So I hope you go and check it out. A normal global install of Create React App, we'll give it to you today. Comes with a decent Lighthouse score out of the box. And in terms of the amount of headroom that this gives you on mobile, Create React App's output will give you about 1.5 seconds on that overall 5-second budget for time to interactive for your own application code. Now, the thing to keep in mind there is that you probably want to make sure you're using code splitting, so you're shipping like a thin core for your application's initial view, your initial routes, and then using lazy loading to defer the rest of that loading across the rest of the experience. So I'm really excited about that. Next up, we have Preact. Now, most UI frameworks are large enough to be the majority of an application's JavaScript size. Preact's a little bit different. It's small enough that your code is usually the largest part of your application. That means less JavaScript to download, parse, and execute, and more budget for your own application code. And what we've been seeing is that many companies that are starting to build progressive web apps are taking advantage of Preact in production. The first one we're going to talk about is Treebo. Treebo is India's top-rated budget hotel chain, and they operate in a segment of the industry worth $20 billion. They recently shipped a new progressive web app that's using Preact, and what they saw was a 70% improvement in time to first paint compared to their old experience, and a 31% improvement in time to interactive. You can check out Treebo.com for their experience, but I'd like to dive into some of the things that they had to do in order to get this experience out. So they started off with Webpack. And using Webpack's default setup, they ended up with a monolithic JavaScript and CSS bundle. This had a first paint of about 4.4 seconds, and first interactive came roughly after that point. Now, like some companies, they thought, we're going to try optimizing our first paint a little bit and see how far we can get. And so they invested in trying out server-side rendering. Now, it's important to note server-side rendering is not free. It optimizes one thing at the cost of another. However, in Treebo's case, using server-side rendering dropped their first paint times and their perceived performance. The user still got a full page with JavaScript disabled. It was still good for SEO. But the con was that it had a negative impact on time to interactive, because the browser had to, first of all, wait for the server-side rendered HTML to get down the pipeline, had to receive that payload, and then it had to go and fetch and execute all of the JavaScript. This meant that first interactive happened about 7.7 seconds in, which is also not ideal. So the next thing that Treebo looked at was code splitting. This is how they're basically doing server-side rendering, by the way. They're just using React's render to string, nothing particularly fancy. And they're injecting state for the application initial boot up. So route-based code splitting. What they did here was they split out their vendor, their Webpack runtime manifests, and their routes into separate chunks. This reduced the time to first interactive down to 4.8 seconds. The con was that it started the current route's JavaScript download only after their initial bundles were executing, which was also not ideal, but it did at least have some positive impact on the experience. So what can they do next? Well, we can go back to the purple pattern. We can say, well, ideally, use H2 server push. If you can't, at least experiment with link rel preload. And that's exactly what they did. Now, again, for route-based code splitting in this experience, they're doing something a little bit more implicit. They're using React routers, declarative support for get component, with a call to asynchronously load in chunks. So with preloading, they use preload to preload the current route's JavaScript ahead of time. This had the impact of dropping their first interactive times, since the Route's JavaScript was already in the cache when their main bundles executed. It shifted the time down a little bit. So first interactive currently happens at 4.6 seconds. The only con they had with link rel preload is that it's not implemented cross-browser. However, there's an implementation of link rel preload in Safari Tech Preview. I'm hopeful that it's going to land and stick this year. There's also work underway to try landing it in Firefox. Another thing that they looked at was HTML streaming, so trying to get some sense of progressive rendering into their application. They would stream the head tag with link rel preload tags set up to early preload in their CSS and their JavaScript. They then perform some server-side rendering and send the rest of the payload down. The pro of this was that resource downloads started earlier on, dropping their first interactive and first paint times. The con was that it kept the connection open for a little bit longer between the client and server, which could have issues if you run into longer latency times. Now, the way that they're doing HTML streaming is effectively defining an early chunk, again, with the head content, then have the main content and the late chunks, all of these being injected into the page. And what this looks like is a little bit like this. Effectively, the early chunk has got their preload statements for all of their different script tags. The late chunk has got anything that's going to include state or actually use the JavaScript that's being loaded in. And finally, like this is an app that originally was using React. They switched from React to Preact in production. This had the impact of dropping their vendor bundle sizes from 140 kilobytes all the way down to 100 kilobytes. This is all gzipped, by the way. The pro was that it dropped first interactive times. They were interactive in 3.9 seconds on average mobile hardware, which is awesome. The con was that they did have to end up putting together a few workarounds in order to get Preact working exactly with all the different pieces of the React ecosystem that they had to use. And that's been one of my experiences as well. Preact is great for like the 99% use case, but there are still a few edge case bugs. Thankfully, Jason Miller, who works on Preact and is somewhere in the audience, there's Jason. If you run into any bugs, bug Jason. Now, switching from React to Preact in production is relatively straightforward. You can do this in your Webpack config by aliasing React to Preact compat and React DOM to Preact compat as well. Treebo have been good open source citizens. They've been using a lot of open source software. In return, they've actually open sourced most of their Webpack configuration, as well as a boilerplate that contains a lot of the setup they're using in production. They've also committed to trying to keep that up to date, so as they evolve, you can take advantage of them as another reference. Housing.com, another site that are taking advantage of Preact. Housing.com shipped Housing Go, a progressive web app, last year. They had somewhere in the region of 50 million visits, and they saw a 38% increase in total conversions across browsers. Now, they've been experimenting with Preact for the last 2 months, and it's now sticking in production, but they saw a 15% average improvement to their time to interactive, a medium TTI of about 5.5 seconds, and huge savings on their overall startup time. And it's not just Indian companies that are considering using Preact. Forbes.com have also recently been investing in progressive web apps. In March, they shipped a new PWA as part of their default mobile web experience. And this is an experience that was initially using React. They switched over to using React Lite, which is a little bit like Preact. And they're currently in the process of evaluating Preact for production. Overall, this is an experience that gets interactive in 4 seconds on emerging market 3G. And for most of us in this room, is probably interactive in 3 seconds. So again, doing really, really well. And so we get on to the next part of our quest. And Jason tells us to, make our code, not our framework, the largest part of our application. If this particular level represented making a framework that's smaller than Preact, which is about 3 or 4 kilobytes, in as much as it does, I don't think I could pass it. I tried passing this level about 15 times, and whatever Jason's doing, whatever magic Preact voodoo, I just couldn't pass it. Now, I love Preact. I think that its small size helps us stay incredibly efficient. But I also really respect the work that's come out of the Polymer team with the purple pattern. And I thought, what if we tried combining these two things together? And so we started working with a number of people in the Preact community on a new project that I'm really excited to share with you today. Today we're announcing Preact CLI, a brand new toolbox for creating purple-first applications using Preact. We think that this is going to make a lot of the React community incredibly efficient at shipping better loading strategies. And I believe that Jason's probably tweeting out about it right now. So Preact CLI is available today. And in addition to giving you a 100 on Lighthouse right out of the box, it also includes support for things like automatic code splitting across routes. It's got built-in tracking for bundle sizes, 0 configuration for pre-rendering, and server-side hydration. It's got support for CSS modules. It's got support for helpers to help you transparently code split any component. And it goes out of its way to make it easier for you to deploy Purple Pattern's H2 server push support on Firebase functions. So I hope you'll check it out. Preact CLI is available today. It's just an npm install away. So npm install global Preact CLI. If you notice any issues, please file them. But I'm really, really excited about this. I think this is like a really great opportunity for us to start taking some of the great learnings from Polymer's App Toolbox and bringing them to the rest of the ecosystem. So what headroom does this give you? Well, Preact CLI will give you 3 seconds in that 5-second interactivity budget for your application code. This is huge. The framework itself only takes up 2 seconds of it. And so you as an author have got more application budget to write code that's going to be useful to your users. If you're not using H2 Server Push, that budget is about 2.5 seconds. But we've tried to make it as easy as possible for you to deploy H2 Server Push using Firebase. We've got a built-in server for it. We've got manifest generation. And we're also excited to take a look at the Polymer team's Purple node server implementation to see what ideas we can share there. So that's Preact CLI. The base that it gives you sits on top of 4 kilobytes. So there's Preact and Webpack. There's 2 kilobytes if you're using the router and asynchronous support, and about another 2 kilobytes for fetch and promise polyfills, which we can conditionally load in for you. Check out the Preact HN Preact implementation. It also takes advantage of a lot of the patterns that we've baked into here. Next up, we've got another framework that I'm a little bit excited about, Vue.js. Vue is designed from the ground up to be incrementally adoptable. And Evan Yu, the author, has tried to take some of the best ideas, the best inspiration from multiple frameworks. It's heavily inspired by Polymer, by Angular, by React, by other things in the ecosystem. It's got a 19 kilobyte core. It's had over 3 million downloads over the last year. And they have a lot of active users. So some of the things coming to Vue.js this year that I'm excited about are over here. Things like support for progressive booting, hydration using request idle callback, support for custom elements, CSS variable theming, seamless support for Webpack code splitting. I would in fact say that Vue.js has got some of the best server-side rendering in the industry. They've got support for streaming support, for component caching. And in fact, they take that even further. Vue.js, if you're using their server-side rendering support, will attempt to infer what JavaScript chunks in your application are important enough to link rel preload, what isn't important enough to use link rel prefetch on, and whether or not there's critical CSS that can be inlined or web fonts that can also be intelligently loaded in. I think that this illustrates a step forward we can take with our tooling, where we're trying to make the best decisions for you. And I love that Vue.js is experimenting with a lot of these ideas. Now, one of the companies that recently shipped a brand new progressive web app using Vue.js is O'17, the biggest food ordering and delivery company in China. They recently switched from an Angular 1 mobile site, this is their old site, over to China's first large domestic progressive web app, with a time to interactive of about 1.2 seconds on their target devices. They're using Vue.js because it boosted their productivity. Vue's support for single-file components, which actually look a lot like Polymer imports, enable them to easily share components across pages and adopt things like Vue.js's ecosystem support for Vuex or Vue router very easily. Now, O'17 is interesting because it's not a traditional single-page application. This is a multi-page app. They actually have a number of pages that are their own dedicated microservices, a number of pages that are technically single-page apps in their own right, and yet they wanted to ship a progressive web app that takes advantage of some of the other ideas that I've talked about today. And so they looked at the Purple pattern. One of the first things they tried doing was HTTP2 server push for their API responses. They found that this cut time to first byte by about 500 milliseconds over regular 3G. And they want to bring this back into the mobile experience. Now, we've been talking about link rel preload as well, and they tried that out. Now, this is one of the first examples of where link rel preload actually didn't make a massive difference to them. See, routes in multi-page applications tend to naturally fetch only the code that particular page or that particular route needs. And so they have a relatively flat dependency graph. And so Elema found that by using link rel preload, they didn't actually see that many gains for time to interactive. If, however, you are building an SPA, I would consider using it. The next thing they tried to do was just improve their overall rendering times. Now, for every single page, they effectively have something that's a lot like the application shell model. They pre-render the application shell for the page. They try to make sure that they're only loading in script that's necessary for the current page and keeping their overall times for any content that can be painted as low as possible. This is something that's a little bit more straightforward for them because they're not worried about the performance of subsequent views quite as much as individual pages. Then they got on to pre-cache, and their performance pre-cached with Service Worker was significantly better than their old experience without it. Now this got interesting. Because the site wasn't exactly a single-page application, so every URL was effectively its own HTML page, they needed to cache the entire HTML page as well as make their current and future routes available. It's a little bit like the application shell pattern, but not. They had to also end up pre-caching their scripts, their style sheets, anything else that was necessary in order for an entire service or entire individual app to be useful offline. They still saw some performance wins with this. Now, in this application, again, because it's a multi-page app and they're relatively diligent about only shipping down the JavaScript needed for each page, what they found was that their time to interactive scores were relatively decent with Vue.js. It's got a low startup time. And so Vue itself was actually their main bottleneck. They found that the Vue runtime, components, other libraries you might drop into the page were their major bottleneck. However, they put in a lot of extra work into making this multi-page application setup still have a good user experience. They invested in skeleton screens for transitioning from one view to another, from one page to another. They also looked at how they could defer the execution of Vue's framework itself by using set timeout on next tick. Now, Elema have tried documenting a lot of the challenges and workarounds that they ran into in a new technical case study that I hope you'll check out. But after adopting the purple pattern, they effectively saw their time to interactive scores drop all the way down to 1.2 seconds. Now, I do have to caveat this with Elema work in a part of China where their users have very powerful phones. About 85% of their users, in fact, are using Wi-Fi or 4G and have at least something that's equivalent to a Nexus 5 or better. And so it would be unfair to say that they've got a really good time to interactive without comparing this on a Moto G4. On a Moto G4, which we consider to be roughly average mobile hardware, they're interactive in under 3.5 seconds, under 3 with Service Worker enabled. So this is still quite impressive. Another site that recently shipped support for Vue.js is Truecaller. Truecaller is the world's largest phone number directory with over 2 billion searchable phone numbers in there. They recently added support for using Vue.js, Vue 2 with Vue CLI, Webpack 2 with code splitting. They've been using link rel preload, and they've actually seen some decent wins. Their time to interactive scores have significantly dropped just by using link rel preload from 2.1 seconds all the way down to 1.6. Now, in terms of the Vue ecosystem, they're using a global event bus, but they're considering using Vuex. They're experimenting with Nuxt.js, which is another server-side framework that works really well with Vue. They try to do intelligent things around link rel preload. They're using Service Worker caching. And so we get to the final level of our game. Now, I must not have had enough sleep that day because this is the one level in this game that you cannot pass. You cannot hurt Evan Yu, the author of Vue.js, in this at all. I've tried. But Evan and Sarah Dressner, who are both Vue.js experts, say progressive framework when you're building progressive web apps is something that can enable you to get productive and stay productive for an extended period of time. We've been talking today about this idea of trying to move the ecosystem forward, trying to take advantage of lessons that we've had in Chrome across the rest of the ecosystem. So we've seen, Create React App now supports, outputting a PWA by default. Preact now supports outputting a PWA default. And today we're also happy to announce a brand new template for Vue.js that's available via the Vue CLI. Vue init PWA will give you a progressive web app by default. Thank you. Now, in addition to giving you over a 90 on Lighthouse right out of the box, it will give you code splitting with dynamic import. It gives you version hashing for long-term caching. A fantastic Webpack setup, by the way. It's got bundle size analytics, once again, for helping you stay on top of your JavaScript bundle sizes so that you're trying to make sure that you're as interactive as possible when you're doing things. And it will also intelligently link rel preload or prefetch your bundles, depending on whether you've got asynchronous chunks in there or there are things that can wait until later on. We're making this available today. You can go and check out Vue CLI. So install Vue CLI, and then Vue init PWA will give you Vue's progressive web app boilerplate. It looks a little bit like this. It will, of course, make sure to pass all the tests in Lighthouse, so I hope that this is useful. And with respect to the headroom that Vue.js's new PWA template will give you on mobile, it gives you about 2 seconds. Not too far away from Preact, but it gives you about 2 seconds. The framework takes up 3 of that budget. You've got about 2 seconds to ship the user down something useful and get interactive. Now, I don't have a lot of time left, but there was one more framework that I wanted to give a nod to, Angular. I think that the Angular team have done a fantastic job trying to slowly chip away at both bundle size as well as execution time for people trying to use it to build on mobile. We took a new Hacker News application built using Angular a few months ago and worked with Hussein Durja in the community to try adopting new features that the Angular team were shipping over the last while. So we started off with a 245 kilobyte bundle. That was the default with Angular 2.4. This got interactive in about 23 seconds, so much worse than many of the apps that we saw in our research. With Angular support for ahead-of-time compilation, this dropped all the way down to 8 seconds. Upgrading to Angular 4 with their new Vue engine dropped this down to 132 kilobytes from the bundle size, and they got interactive in 6.6 seconds. And by using code splitting, something I know that the Angular team are trying to make a default for all their users as well, we got our interactive scores all the way down to 6.3 seconds on real devices. I think that the Angular team are making excellent strides, and I'm looking forward to the day where a lot of these practices are just the default for all users. What we're trying to accomplish this year is fast being the default for everybody. We want it to be the default for React users and Preact users and Vue users and Angular users. And of course, Polymer users get it for free with Polymer App Toolbox. So we're almost out of time. We've announced a few things today that I hope you'll find useful. hnpwa.com, your reference for how to build progressive web apps with different frameworks efficiently. We announced Create React App with support for PWAs, Preact CLI, and Vue init PWA. And so with that, we're almost at the end of our journey. I hope that from this talk, you take the idea that it is possible to incrementally ship an instant loading progressive web app using a framework if you're willing to put the work in. The way that I like to think about incremental development for PWAs on mobile is to first do it, then do it right, then do it better. And many companies have demonstrated that this is possible. So with that, I would like to ask for a big round of applause to all the members of the community that contributed to making this stuff possible today. This has taken a few months of work. For their restless nights, I would like to thank the React team, in particular Dan Abramov. I would like to thank Jason Miller and Chris working on Preact. I'd like to thank the Polymer team, Steve, Dan, Kevin, and everybody else on Webpack and other tools that have been trying to make it a little bit easier for us to ship progressive web apps. So with that, thank you. I hope that this was useful.
We all know from experience that people love to share things about themselves, such as photos, videos, and GIFs that express their feelings. So what do you do to let them store and share these files through your app? That's where Firebase Storage can help. Our storage API lets you upload your users' files to our cloud so they can be shared with anyone else. And if you have specific rules for sharing files with certain users, you can protect this content for users logged in with Firebase authentication. Security, of course, is our first concern. All transfers are performed over a secure connection. Also, all transfers with our API are robust and will automatically resume in case the connection is broken. This is essential for transferring large files over slow or unreliable mobile connections. And finally, our storage, backed by Google Cloud Storage, scales to petabytes. That's billions of photos to meet your app's needs, so you will never be out of space when you need it. So give your users space to share their lives with Firebase Storage, available right now for iOS, Android, and web applications. And to learn more about Firebase Storage, check out the documentation available right here.
Right, let's have a little chat about a brand new API that's just coming out on the platform called the Media Session API. I heard about it when I started doing this app. It was mentioned to me by a couple of the Chrome engineers. But Francois, who's on my team, there's a brilliant Google Web Developers update where he explains in complete detail about how to set up the Media Sessions API. So check the notes below. We're going to pop in a link for that. But I will just show you briefly what it actually looks like in the context of the app on my phone here. In fact, because you probably can't see it, let's switch across to the direct screen cam. There you go. That's what it looks like on the phone. So as I start playing a video like this, you see that if I swipe down from the top, we actually get a notification which has an icon here, and it has play and rewind and fast forward buttons. And you get to configure those yourself. In fact, let me go into another one of these videos where I think I've actually set up to load some custom album art as well. So there's me and Jake. And you can see here now we've got custom album art, which is the picture of Jake, and the previous and next, the fast forward and rewind buttons are actually set to be skip forward 30 and go back 30. So I should be able to tap that and go forward 30, which you can see there. Oh, it's just skipped it right to the end. Whoops-a-daisy. But I can replay the video. Don't worry. The other thing that it actually does, which I really like, is if I turn off the screen and then on again, you can actually see that the picture, the album art, is actually the picture for my phone in the background. That is very exciting, isn't it? So let me show you a little bit as well, since we're here. Let me show you a little bit of the code. It's very straightforward. We have a quick check whether we support the Media Session API, which is basically looking for, let me show you actually. It is just simply looking for Media Session in Navigator. And if we have Media Session in Navigator, then we consider ourselves having the Media Session API. And what we do is we say navigator.mediasession.metadata, and then we create one of these new media metadata thingamajigs. It's very exciting. ESLint doesn't like it. It doesn't think it's a real thing. It is a real thing. You can totally use it. And you give it things like the title, the album, the artwork. I've only set the 512 and the 256, but very much like your manifest files for progressive web apps, you can set as many of these as you need, and the user agent will choose whichever one it thinks it makes the most sense for the device that it's on, and it will upscale and downscale as necessary. But I currently am just setting a couple of them. I may need more as time goes by. And then afterwards, after we've set up the metadata, we set some action handlers for things like the play, the pause, the seat backwards, and the seat forwards. The thing to bear in mind here is that any that you set will have the buttons appear in the notification. If you don't set one, because there are other ones that you can set as well, and I forget which ones they are, but check out Francois' post. He explains the whole kit caboodle. Any that you don't set won't appear. Any that you do set will appear in the notification, and then somebody can control your stuff from the lock screen or by just dragging down from the top. All very good, isn't it, that? And very straightforward code to be writing. So a brilliant little progressive enhancement thing that you can chuck on, and that I have chucked on my media app. Cool. Toodaloo.
Hey gang, want to see something neat? Check out this awesome hidden feature I found in Firebase Analytics. So I'm over here looking at all my reports in the Firebase Analytics dashboard. Here, for instance, I've got my active users for the last 30 days, and while these graphs sure are pretty, I'm thinking it'd be kind of nice if I could get these numbers into like Google Sheets or maybe Excel so I could analyze them a little better, right? Well, watch this. I'm going to select my graph here in the Firebase console. It's kind of hard to tell, but you can see by like the highlighted text here that my graph has been selected. And then I'll hit Command-C to copy it. And then I'm going to switch to a blank Google spreadsheet and hit Command-V to paste. And look at that. All my values are right there in the spreadsheet for me to analyze. So you can see here on the leftmost column, I've got the date, and then all the actual numbers are in the columns next to it. Now you might notice that I seem to have two columns of what looks like the same data, right? I've got monthly active users here, and then right next to it, I've got this monthly users column. And then the same goes for my weekly actives and same for my daily actives. And so basically that first column is for the value that corresponds to the date here on the left. The second column is basically for that corresponding day in the previous 30-day time period. Basically, it's the values that belong to this dotted line here in the graph that I copied. Make sense? Okay. And then I can do the same thing for a bunch of these other graphs. Here I can copy and paste my daily engagement numbers. Let's get these into a new sheet here. And again, you can see I've got my engagement numbers from this time frame in this first column, and then those same numbers for the previous 30 days in this second column. And better yet, I can jump over to an individual event like this completed 5 levels event and copy all these graphs here at the top. And you can see I'll get event counts, event per user counts, and values for every one of my events that I am recording in Firebase Analytics. And this lets me do some pretty nice calculations right here in Google Sheets. For example, let's say our game designer is curious how often people are failing a level in our game. Well, for starters, I've got my level start graph here to show when people are starting a level in my game. So first, I'm going to copy and put them into a new sheet. Let's put them in. Okay, great. And then I'm going to do the same thing for my level fail graph, and that will show when people have failed a level. So we'll copy from here, and we'll paste them right in next to my other numbers. And once I've copied and pasted these values into Google Sheets, I can then calculate my average failure rate per game stat by dividing this number here by this other one. I'm going to copy this formula down for all of my dates. Let's give it a percentage format so it looks nice. Maybe we'll add an average at the bottom here. Let's do average for all these numbers. And there we look, the game has an average failure rate somewhere in the low 30s, which sounds like it's just challenging enough for our players. So our game designer is happy. Now, a couple of disclaimers here. First, this doesn't work on all the graphs I've tried. Some of them just don't seem to copy and paste as well as others, but it does work on a surprising number of them. You'll just kind of have to try them out and see if they work. And second, this will never be a replacement for some of the awesome and sophisticated data analysis capabilities you get by exporting your raw data to BigQuery, and you should totally go watch this video if you want to find out more. But if all you want to do is maybe compare two graphs to each other or calculate some standard deviations or averages on a particular event, this trick can work surprisingly well. So give it a try yourself, have fun with it, and we will see you soon on another episode of Firecasts.
It's been just over a year since we open-sourced TensorFlow, and we've been thrilled to see the adoption by the community and the pace of development all around the world.
TensorFlow is really the primary tool that we're using for a lot of our machine learning work in all of our products. Towards the end of last year, we actually rolled out a completely new translation system that was based on deep neural nets. In Gmail, we were actually able to roll out a TensorFlow model that, by understanding the context of the message you just received, we can predict likely replies. And this is a feature we call Smart Reply.
Diabetic retinopathy is the fastest growing cause of blindness. It's a complication of diabetes. We gathered a very large data set and had doctors grade the images. And then we, using TensorFlow, trained a neural net that does a pretty good job of predicting whether or not there is diabetic retinopathy in the image.
Can we use something like TensorFlow to make music, to make art, and to allow us to communicate better with each other? With TensorFlow, we're able to think abstractly, almost at a level of like improvisation with machine learning. We're able to try new things, to chunk models together in ways that were impossible before we had that kind of expressivity.
Dugongs are classed as vulnerable to extinction globally, so we do a lot of aerial surveys using drones. Then once you've done a survey of a really large area, you end up with tens, if not hundreds of thousands of photos. The goal was to find a way to automate that whole process, and that's where we've been using TensorFlow.
One of the things that we've been focusing on this year with TensorFlow is performance. We've been especially excited to release support for distributed training.
We want to make it easier for people to use so they don't have to necessarily know all of the underlying internals in order to get the distributed performance the best it can be. XLA is something that can compile down TensorFlow. Maybe you want to compile your graph ahead of time and get it down to something much more compact in terms of memory size, so that way you can easily load it and execute it on something that might not have as much storage space, like a mobile phone or some other portable, smaller device.
When we introduced the Hexagon Vector extensions, what we had in mind was enhancing user experiences with imaging features.
So the TensorFlow team said that you only needed low precision multiplies to be able to execute these neural networks efficiently. So we did some tests, and on the same graph, Inception v3, we were 8 times faster and 4 times lower power than running on the CPUs.
TensorFlow is great to work with, easy to work with, lots of capability. And so our engineering teams and their engineering teams working together, we were able to do something very exciting. This is just the beginning of what will end up being a long evolution of some great things we can do with machine learning in image processing.
In addition to sharing TensorFlow, Google has also shared an ecosystem of tools, which contains everything you need to go all the way from research to production. One such tool is TensorFlow Serving, and this is an open source, high performance serving solution. Another great tool, which is actually quite beautiful, is the embedding visualizer. And you can use the embedding visualizer to interactively explore high dimensional data sets. On the education side, General Assembly has done great work teaching TensorFlow.
For my final project, I was really interested in doing lyrics generation, and TensorFlow was a really great match for that because it allowed me to build out and utilize the models that I needed to be successful.
The TensorFlow community is thriving around the world, and we're excited about as many people as possible being part of it. TensorFlow is an open source project for everyone. We're looking forward to building this into something even better and more useful and more powerful in collaboration with the whole worldwide community.
And here we are in the Code Labs area. This is a special part of Google I/O where if you've always wanted to learn a new API or tool or service, you get to come here and work on the Code Lab. And if you have any issues or you want to get in more depth, you can ask a Googler for their help. Any question you happen to have. I'd like to learn a little bit more about what it feels like to do Code Lab here at I/O. And to do that, Claire, how you doing?
I'm great. It's been a long couple of days, but a fun couple of days.
I hope that means a lot of people learning a lot of things.
Oh, most definitely. We've had lines waiting pretty much the entire day.
That's very cool. So what's the setup like here?
The setup here is a bunch of computers that are all pre-configured with the steps to do and learn pretty much whatever you want. You can tell what's going on by the status of these lights up here. If they're green, it means the computer's ready to go, ready for you to come up and learn. If they're blue, it means Code Lab's in progress. And when they turn red, it means that someone needs a little bit of help or has got a question, and one of our staff will zip over right away and help them out with that.
That's totally cool. Now this is a special Code Lab station that actually has a whole bunch of devices. What's going on there?
Yep. That's right. So right now we're in our special IoT Code Lab section. We've got a couple different devices over here that people can run a bunch of various of our Code Labs on, and they'll actually get to interact and play with them. This one's got some buttons and lights and numbers. It's got a button that's very fun to play with. It's a good time.
All right. Is there anything else you want to say about the day? How's it been going?
Really good. We've had a lot of people with very insightful questions, a lot of people showing a lot of enthusiasm for the subjects, which is always my favorite thing to see.
Awesome. Thank you so much.
Thanks, Timothy.
And that's the Code Labs area. Thanks so much for joining me. Remember, I'm Timothy Jordan, and if you'd like to catch some more of these videos after I/O, head on over to g.co/io/guide.
Hi, everyone. Thank you so much for coming. My name is Mark Sagaitis, and I lead the Location and Context Client team. And with me are Wei Wang, Steve Malkos, and Shovik Sen. And we're really excited to be speaking with you today about what's new with Android sensors and location. Now, we'll start by discussing some of the upcoming changes to background location and how you can prepare your application for the Android O release. We'll then discuss accuracy improvements to location, improvements to activity recognition, as well as sensors. So let's get to it. Well, I think we've all experienced that terrible feeling when your battery is just about to run out. It's a beautiful day outside, so you decide to go for a hike. And after several hours, you come up to a beautiful baby deer. It's super cute, and you manage to get really, really close to it, closer than you've ever been. And you decide you're going to take a picture. Now, this is going to be the best picture you've ever taken. So you slowly, carefully take your phone out of your pocket, push the power button, and your phone is out of batteries. So not only do you miss the shot, but then you realize you're not exactly sure where you are, and you're really counting on your phone to help you navigate back. And all of a sudden, the woods look like a much scarier place. So I think the point here is that battery life is extremely important to users. In fact, 1 in 3 users say that battery life is the #1 problem on their device, the #1 problem. This is also apparent in statistics we track about location. So a large percentage of users have decided to completely disable location on their device. And when we asked them why, they said power was the main reason. Now, this is a problem for every developer in this room who uses location, since when location is disabled, just a lot of stuff breaks. From navigation to context-aware apps, I mean, even the weather just doesn't work whenever location is disabled. But I think more importantly, users turning off location means that they're not happy with the experience they're getting. And we don't want that. I mean, we want users to absolutely love location. So we've taken a really close look at power consumption, and here's what we found. Well, for one thing, location is used a lot. The location APIs currently allow applications to request location at virtually any time. So every bar you see here is a device doing some kind of location-related work. Now, we can analyze the cost of these using something called Android Power Primitives. Now, this is something I'm really excited to be speaking with you today about. This is the first time we've talked about these externally. So you can think of Power Primitives as a way to understand the fundamental building blocks of power on an Android device. And we can use these to really understand sort of how location power is computed. Here are the 4 basic operations that consume power when using location. We first have to wake up the device to perform some work. We then have to get some location signals, like Wi-Fi and GPS. Then we have to run some computation on the CPU, and then finally maybe go to the network to get some more model information. And we can understand the cost of all of these by using the power primitives. So this is the cost of every single one of these operations. There's a lot going on here, so let me highlight the most important ones. Well, first, using the cell network is extremely expensive. This is why the location stack has been heavily optimized to cache data locally whenever possible and try to avoid going to the network by computing things locally. Also, obtaining location signals is expensive. For example, the first fix for GPS can cost quite a bit. This is why we usually tend to prefer doing Wi-Fi scans instead. But unfortunately, Wi-Fi scans are not really cheap either. So what we've been doing is try to reduce the cost of these as much as possible by limiting which channels we look at when doing a Wi-Fi scan, as well as spending the least amount of time possible on each channel. But we are coming up to some physical limits to how much we can optimize here. So in summary, we see that power is extremely important to users. Unfortunately, location is not cheap, and we're coming up to some pretty hard physical constraints as to where we can optimize. And as well, there are some amazing features being built using location. So with all of this in mind, we're introducing a significant change to how location works in the Android O release called background location limits. This is something we're really excited about, as it drastically improves battery life for Android users while also allowing great location use cases to be built. And now Wei will come speak to you about some of the details of background location limits, as well as how you can prepare your application for the Android O.
Okay. Thanks a lot, Mark. My name is Wei Wang. I'm a software engineer in location and context team. I'm going to talk about background location limits in Android O release, the power improvements to location APIs, as well as how you can prepare your application for these changes. So first, let's take a look at the difference between foreground apps and background apps for location purpose. An application is considered as foreground when it is actively interacting with users, which means it's either running a foreground UI or running a foreground service that the user cares about. Otherwise, the application is considered as background from location perspective. So our study showed background apps are the major contributor to location power issues. Now, before Android O release, there were no limits to background location usage, which means any app can request location at any time. Now, this causes several different problems. As a result, many applications request location aggressively when they run in background, or they leak a fast foreground location when they switch from foreground to background. So beginning from O, we're going to impose limits to the background apps. Now, so I would like to emphasize these limits apply to background location only and would not affect your foreground location usage. So let's start with location providers. Location providers are the main entry for requesting location updates. We have two main location providers: the field location provider in Google Play Services and the location manager on the platform. So starting from Android O, for both location providers, apps running in background cannot trigger location commutation more frequently than a couple of times per hour. For batching API in field location provider, a few more location commutations are allowed. But the delivery time is going to be the same as non-batching API. So for field location provider, we're also going to take advantage of Wi-Fi connection to reduce location commutation. No new location commutation will be performed when the device is connected to the same access point, which indicates the user has not moved much from the previous location. So this provides significant battery improvements when the user is at home or at work with Wi-Fi connection. So with similar strategy in mind, we also applied very similar changes to geofencing. The responsiveness of geofence will increase from tens of seconds to a few minutes. But the power is going to be 10 times more power efficient than the previous releases. So we also use similar Wi-Fi connection approach and can now provide better transition detection when the user leaves home or leaves work. So all the changes I mentioned apply to all background apps running on Android O release, regardless of the target SDK version. We believe this is the best approach to provide users with immediate battery improvement when they upgrade to O. Now you may be wondering, how do these changes look like on a real device? So Mark showed you an example of location activities before O. Now let's take a look at how things change after applying all the background location limits. So you can see there are much fewer location activities during the same period. In fact, after around 6 p.m., when the device connected to a static Wi-Fi access point, there was no location computation. But we were still able to provide fresh locations because we know that the device is connected to the same Wi-Fi, so the user has not moved far away. So the battery consumption for background location is much, much better now on O. OK, so I've talked about a few changes to background locations and the battery improvements. The battery looks really good. But as a developer, you might be wondering, this means fewer locations coming to my app. What should I do? So let's talk about a few approaches that you can take to make your application ready for background changes. So first, consider only request foreground location. So does your app really need location when it is not interacting with users? If it only needs user location to search restaurant nearby, then you can always request a location after the user opens the app. No background location limits would apply in this case, and you can get frequent location updates as before. So we are also working on reducing the current location latency to ensure a better foreground location. On the other hand, if your application needs to trigger when the user enters or exits a given area, such as automatically turning off air conditioning when the user leaves home, you can use geofencing API to detect the user has entered, dwelled, or exited an area of interest. As mentioned before, the geofencing API in Android O is 10 times more power efficient than the previous releases. If your application needs to collect users' location and display the location history at a later stage, such as Google Maps timeline, then you can use Beijing API in Field Location Provider. Beijing allows the location system to collect location signals, such as Wi-Fi scans, at low power with a higher rate, then compute and deliver locations to the client only when needed. This way, we can consolidate all the network queries to save battery. So let's take a look at an example of how to enable location batching. As usual, you will need to create a location request. You set the interval to 10 minutes. The key here is to set the max wait time to a few times more than the request interval. So this allows the location provider to collect location signals every 10 minutes, but deliver the location to the clients every 30 minutes. Now, finally, as a last result, if you really need unthrottled foreground locations when you're running in background, you can start a foreground service by showing an ongoing notification. Applications showing ongoing notifications are considered as foreground apps, so background location limits will not apply. To start a foreground service, create a notification and supply a pending intent to be called when the notification is clicked. By calling start foreground, or if your app targets Android O, call start foreground service, the service becomes foreground while you're showing ongoing notifications to the users. Now, do not forget to stop foreground service if foreground location is not needed anymore. OK, so far I've talked about background location limits on the Android O device. How about pre-O devices? The system did not impose any limits on pre-O devices, so we rely on your best practices to make sure the background location power is at a reasonable state. The optimization you do, such as request only foreground locations, use geofencing instead of frequent location polling, using batching if immediate location is not needed, can very well be applied to pre-O devices to make the background location usage, battery usage at a reasonable state. OK, so in summary, I've talked about background location limits, battery improvements for locations on O, and several different ways to make your apps ready for those changes. Now let's switch gear to talk about location accuracy improvements. Thank you. For the past years, we have been keeping on improving location accuracy, especially for indoor environment. Our data showed a 40% and 20% accuracy improvement for the past 2 years. This year, we are on a good track of achieving another 40% better accuracy improvement, and another 40% accuracy improvement in the year 2018. In fact, our accuracy would be good enough for indoor navigation. Now, let me show you a couple of videos to demonstrate our indoor accuracy improvements. So the left side video is running on the current field location provider. The right one is running on a version that comes soon. The blue dotted line shows the route the user was taken. The blue dot, as usual, is user's current location. Now let's play the first video. So you can see the blue dot aligned with the user's real location reasonably well at the start. But as the user went deep indoors, the location jumped and diverted a lot from user's real location. OK, now let's play the second video to see how things improved. So this time, the blue dot aligned with the route perfectly well, even when the user was deep indoors. Now, when the user makes the turn, you can see the algorithm track the move really well. So we are very excited about the accuracy improvements, and we hope this can bring better opportunity to your application. Another area we are truly excited about is the support of the raw GNSS measurements in Android N release on Location Manager. Developers can now get more information, such as pseudo-ranges, Dopplers, and carrier faces, other than just the position. The information can be used to build value-added apps, such as much more precise positioning using carrier face measurements. We also provide tools to log, analyze, and visualize all these GNSS measurements. You can use these tools when prototyping your apps and answer questions like, which satellites are in view? How strong are the individual measurements? How accurate are the range measurements? We are very eager to see more use cases of the raw GNSS measurements in the ecosystem. Okay, so far we talked about accuracy improvements to field location provider, the new APIs for GNSS measurements. We hope developers can take good use of these improvements to build better location apps. With that, I'll hand over to Mark to talk about activity recognition.
Cool. Thanks, Wei. So activity recognition provides your application with contextual cues as to what users are doing in the real world. And now, these are the activities we currently detect. This is something I'm extremely proud of, as just a few years ago, this list was much smaller. So you can break it down into fitness-type activities, like running or biking, device context, like are you in a vehicle, as well as some gestures, like the tilt-to-wake gesture on your watch. And today, I'd like to talk to you about some upcoming improvements to our accuracy, some simplifications we're making to our APIs to make them much easier to use, as well as some new activities we'll be detecting. So let's start with accuracy improvements. Well, the world of machine learning has seen some amazing results from the use of deep neural networks, and activity recognition is no exception. We've developed a deep activity neural net, which significantly improves the accuracy of activity recognition. Now, this makes it much easier for you to build contextual applications, and it also looks really cool. We're also doing some big improvements to our APIs to make them easier for you to use. Now, the current activity recognition API provides you with raw, low-level access to activity signals. Now, this is very powerful and flexible, but it also means that simple things can be hard to do. So let me show you what I mean. Now, let's say you're building a car assistant app that allows users to interact with their device hands-free when in a car. Now, a simple way to do this would be to write an if statement that says, if the activity is in vehicle, start my app, and if it's not in vehicle, close my app. So let's talk about some of the pitfalls that you'll encounter if you do this. OK, so the user starts in a vehicle with a confidence of 80%. Great, so far so good. You launch your application. And he keeps driving with a confidence of 100. Everything's working well so far. And then he stops at a light, and you get a still activity. Now, that simple if statement from earlier wouldn't have taken this into account, and the app would have closed. So you say, OK, let me update my filter to deal with the still while in vehicle use case. So the user continues to drive, and then hits a speed bump, and we misdetect it as biking. Now, we work really hard to avoid misclassifications, but sometimes they're unavoidable in this kind of raw, low-level API we're providing that has very little filtering in it. Now, you can write a filter to try to deal with things like this, because if you look at the history, well, there was a lot of driving in the past. The biking confidence is very low, so 55 is pretty low. And there was no activity that you would expect between driving and biking, like something like walking. But writing this is getting pretty cumbersome and complicated. OK, so the user continues to drive. And now you get a tilt event. Now, a tilt event is a strong indication that the user's activity is about to change. It tends to happen when a user goes from sitting to standing. So you can take that into account into a filter. And then finally, the user starts walking, and you can finally close your application. Now, writing a filter to deal with all of this is pretty tricky and requires a lot of training data to get right. Well, we're making this much easier with the Activity Transition API. Now, it takes a messy, raw activity signal like this and turns it into simple transitions. You get a vehicle start event when the user starts driving, and a vehicle end event when they stop. That's it. We take care of all the filtering behind the scenes. This means that by using this Activity Recognition Transition API, you can write that simple if in vehicle statement, and your app should just work. Oh, thank you. Now I'd like to quickly talk about some of the new activities we're working on detecting. So we're really excited to announce that we've developed a road versus rail vehicle detection algorithm that can tell the difference between a car and a train, for example. So we think this will lead to some very powerful applications that help users during public transit, as well as improve in-car experiences. And we can't wait for you to try it out. And I'm also really proud to announce that we're now able to automatically detect strength training exercises. This means that you can walk into a gym and have your entire workout automatically tracked for you. This makes it really easy to keep track of your progress over time and make adjustments along the way. It's available on the LG Watch Sport, and we'll be rolling it out to more devices soon. So in summary, activity recognition will be bringing you improved accuracy, simplified APIs, and new activities in the coming month. And now, I'd like to invite Steve to talk about how we'll be making this, as well as other contextual use cases, run at ultra-low power.
Awesome. Thanks, Mark. Hi, my name's Steve Malkos. I'm the Technical Program Manager for the Android Location and Context team. Before I start talking about Android Sensor Hub and Context Hub runtime environments, can I see a show of hands? How many people here know what the Android Sensor Hub is? Not that many of you. That's all right, because when you leave here today, you'll all be experts in this field. All right, Mark just showed us some really cool examples on how activity recognition works. We've launched some amazing features in Android, things like physically tracking where you're parked your car, tracking your activities like running, walking, and biking, and providing you with relevant information that's important to you at a specific moment in time, like pulling up a train schedule as you arrive at the train station. But we found that bringing some of these factors, some of the biggest limiting challenges here, has been around power, consuming power. That's your battery. So with the Android Sensor Hub and Context Hub runtime environment, we're able to leverage the capabilities of a low-power processor to make it possible for us to bring these experiences and more. We all know that if you write an application and it sucks up the user's battery, they're going to quickly uninstall it from their device. When talking about power for activities that happen in an always-on fashion, there's always two things at play: latency and accuracy. Improving power means we could run our apps at a greater frequency, improving on the latencies. Improving power also means we could look at more signals, improving on our accuracies. So 2 years ago, we introduced the Android Sensor Hub in Marshmallow. We used this tiny standalone microcontroller that's depicted on a dime and connected all the sensors to it, and it runs in an always-on fashion. We launched this on the Nexus 5X and the Nexus 6P. Last year, we worked on the second generation of the Android Sensor Hub. This time, in addition to connecting all the sensors to it, we also connected all the wireless connectivity components. And we launched this on the Pixel and the Pixel XL. As mentioned earlier, the Android Sensor Hub runs in an always-on processing, and it hardly affects the user's battery. Context Hub runtime environment provides a common platform for us to leverage these low-power processors. So with the Context Hub's common platform, we created mini applications that we call nano apps. And so let's go through a couple nano app examples. All the activity recognition APIs, like running, walking, biking, and vehicle, have been ported from the main application processor into the Android Sensor Hub. We'll take a look at how activity recognition both saves on power and improves on our accuracies when running as a nano app. If you're to run activity recognition on the main application processor, it consumes a ton of power, about 5 milliamps. When we introduced sensor batching in the Android operating system, we were able to cut that number down into half. But it's still running on the main application processor. We took it from 5 milliamps to 2.5 milliamps. Running these same algorithms in the Android Sensor Hub as a nano app costs us a fraction of that power, 300 microamps. And because the power is so low, we can now run these algorithms at a faster frequency, improving on our latencies and our accuracies. Another example of a nano app that I'd like to highlight is geofencing. There are tons of geofencing applications in the market today that use the Google geofencing APIs. We've now offloaded these algorithms from the main application processor into the Android Sensor Hub. And we did this by connecting the Wi-Fi chip, GPS, and the cell modem into the low-power compute domains. This brings us a significant power savings, and it improves on our latencies. And finally, on the Android Sensor Hub, let's talk about gestures. We added tons of gestures. Gestures like lift to check phone, double tap to check phone, flip camera, and more. I'm going to highlight one of the examples, and let's focus on flip camera. If I launch my camera app and double twist it, it will change from outward facing to selfie mode. I have to do this. All right, everybody on the count of 3, say cheese. 1, 2, 3, cheese. All right. This gesture is only possible because it runs in an always-on fashion in the Android Sensor Hub. Any application could register and use this private sensor type today. OK, to close on the Android Sensor Hub with CHRE, devices on the market that support this automatically get a common platform that takes advantage of lower power, lower latencies in an always-on compute fashion. And these nano apps can overcome some of the new paradigms that have been introduced with our latest operating system, like background location limitations. We're really excited about this platform and the new use cases that could be enabled from it. I'm going to switch gears now and go from that to Android sensors, highlighting 4 key items. And then Sulvik's going to come up and talk to us about the Compass. Dynamic sensors. This was introduced in Android N. It allows us to expose sensors that are not necessarily bundled with the device. And it lets us connect them via Bluetooth and USB. For example, you can now attach a high-quality inertial measurement unit to your device, biological sensor, environmental sensor, and your apps could natively see them. This year, we're standardizing on these interfaces for dynamic sensors. So the sensors that you build can now leverage the Android platform and make it easier for you as an application developer to access them. Direct Sensors Channel, initially targeted for VR and camera applications. Simply put, Direct Sensors Channel is minimal latency between the sensor driver and your application by bypassing the sensor service. Accessing sensors directly with Direct Sensors Channel, the programs that you develop will have the smallest amount of sensor latencies. Ever experienced a VR application with a skewed horizon? Similar to uncalibrated magnetometer and uncalibrated gyroscope, we introduced uncalibrated accelerometer. Last year, we wrote our own calibration algorithms for the accelerometer, and we open sourced this to the ecosystem with the hopes and goals that a device manufacturer would build better devices. And we're seeing results like this. After applying the calibration algorithms, the VR landscape is straight. The final sensor feature that I'm going to focus on is wrist sensor, now called low latency off-body detector. Simply, we have a reliable way to detect when the watch is on the wrist or off the wrist. The targeted use cases for this is low friction authentication to your phone, no passcodes for payments, and changing the UI behavior when the watch is off your wrist, like sleeping the watch more aggressively when it's off your wrist. So before I hand the microphone over, I want to quickly note that we use sensors today in almost every application, and our commitments to them at Google is huge. We'll continue to invest in this sensor's future. These features like dynamic sensors, direct sensors channel, calibration algorithms, and low latency off-body detectors are just a few highlighted examples on what we're working on. We'll be adding more sensor features in the future. With that, let's continue on the sensors theme and hear from Sulvik on the Compass.
Thanks, Steve. I'm Shovik, and I'm a software engineer in the Android location and context team. And I'm here to talk about heading and bearing. So what is heading and bearing? So bearing tells you, as a context, the direction that the user is traveling. And heading is the direction that the user's phone is pointing. So heading and bearing are different. Like heading is something that if you are standing at a stoplight and you pan your phone around to find which direction you should walk, that's when your heading changes, and your bearing is not necessarily changing at that point. So how do you utilize bearing and heading depends a lot on the user's context. So if you're an application who might gain by knowing the direction of the user, think very hard about what context you're after, because based on that, you want to select between heading or bearing. Let's see how we are doing that in Android Google Maps. So in Android Google Maps, the blue dot arrow used to always point to the user's heading, essentially which direction your phone is pointing. Now, what we found is that the user's expectation from the blue dot arrow is much more. When they are stationary, like standing still or panning their phone around, they want to see their heading from the blue dot arrow, perhaps because they are trying to figure out which direction to go next. If they're traveling, like in a car or in a bicycle, or even when they're running, they want to see the bearing. That is the direction that they are moving, because they want to perhaps verify that the direction they're going towards is actually correct. And more importantly, they want us to communicate the uncertainty in heading or bearing. Because if we are not certain if the heading or bearing information that we are giving to the user is not correct, the user wants to look around and orient themselves and be diligent about this. So how do we do this? To distinguish between stationary and traveling, we can use the activity recognition API that Mark just talked about. You can know when the user is stationary versus traveling and choose between heading and bearing based on that. Now, to determine the uncertainty, note that bearing is based on location. So you can see what the location speed is and what the location accuracy is. And based on that, you can determine if the bearing is correct or not. But how do you find heading uncertainty? To understand that, let's see how heading is actually being computed. So heading today is estimated based on the phone's compass. And as many of you know, the phone's compass can be very unreliable in presence of metal objects or external electromagnetic fields. Simple cases where, like for example, if you're in a car, or you're charging your phone, or even simple things like you keep your phone next to your laptop, it's possible that the phone's compass will become uncalibrated and hence becomes unreliable. And all of this ties to the heading uncertainty that we are after. So in a nutshell, what we found by looking at a lot of data is that heading uncertainty really is about what is the environmental uncertainty in which your device is at. Now, to understand the environmental uncertainty, we found machine learning can actually help us. There is only a few kinds of environmental uncertainty or anomaly that we are after. And if you have enough data, machine learning can tell when there is anomaly, and hence when the compass is correct and when the compass is not. And that ties into heading uncertainty. We can tell the user, oh, your heading is probably not correct because the compass is unreliable. And moreover, now, because we know that when the compass is unreliable, we can go back to other kind of sensors like gyroscope, and this in return actually improves the heading accuracy significantly. So now that we know the heading uncertainty, let's see how we can communicate that using in Android Google Maps. So before, in Google Maps, we had this pointy cone, which will always point to heading. But now, because we know the heading uncertainty, we have a cone EY, where the width of the cone now tells you what is the uncertainty in heading. If it's too wide, you know that the heading is probably not correct, and hence you can look around and try to orient yourself. If the cone is narrow, you know it is correct, and you can just use it for your own travels. Beyond Android Google Maps, if you are an application who might benefit by knowing the user's direction and also the uncertainty in a more correct fashion, we are happy to announce that this is something we are going to bring in for all applications with the Fuse Location Provider API. With this, I will hand over to Steve to talk about the future of Android location and context. Thank you.
Awesome. Thanks, Solvik. I love talking about the future. So let's talk about the present with regards to testing location quality, because that's the key to making future improvements. Over the past few years, we've gotten very serious with regards to testing at Google. We've built up massive labs and real-time tests from around the world measuring our location quality. For example, we run running tests, walking tests, biking tests, stationary tests, testing both indoors and outdoors. When driving near tall buildings, it's very common for your GPS position to jump, lag, or even drift. At Google, we use very expensive military-grade inertial measurement unit that gives us centimeter-level accuracies that gives us this ground truth. That's the image at the top, the San Francisco test setup. The image at the bottom shows our running and pedestrian test setups. The output from these tests is the graph, where we show a cumulative distribution function on the position errors from each device as measured from the ground truth. OK, project elevation. Before talking about this, I want to quickly note about a service that we launched last year called Emergency Location Services in Android. This service gives us the ability to use the computed location in Android and send it to emergency responders during an emergency situation. So for example, if you dial 911 or 112 on your handset, the computed position from Android will go to carrier's network and public safety answering points for those carriers who sign up for this free service. All right, with that in mind, Project Elevation. Many places around the world, like downtown San Francisco, when you're deep indoors, your 2D Latin lawn are just not enough. GPS altitude works great when you're outdoors, but barely works, if at all, deep indoors. And we especially need it when we're in environments like this. So with Google's machine learning algorithms, anonymized crowdsourced models will soon be launching Project Elevation this year. This service will first be utilized by our emergency location services in Android, where we hope to see first responders benefiting off of it. And then we'll also launch it as part of the standard Android location altitude outputs, so you as a developer could get access to this as well. We'll also bring a new class of 3D accurate indoor location. You heard part of this from Wei. By using Wi-Fi, GPS, cellular, PDR, IMU, altimeter, we're just around the corner from launching this massive improvement. And we'll get there again by using Google's machine learning algorithms, anonymized crowdsourced models, to give us these better accuracies where we can now navigate indoors. Then, once we have this all running on the main application processor, we'll port it down into the Android Sensor Hub, because that's the key. 5 meters at 0 seconds time to first fix at ultra low power. OK, the GPS geek inside of me gets really excited when we talk about dual frequency GNSS receivers. L1 plus L5 signals. What does this mean to you? Better GPS performances. We'll bring this into smartphones in the next couple of years, and we'll do so for the following reasons. Better ranges for multipath mitigation, because we'll be using a higher chipping rate, 10x higher. It will give us unprecedented frequency diversity using the L1 and L5 signals together. Our Android O APIs already have full support for multi-frequency GNSS receivers. This enables many use cases. I'm just going to highlight 2. Better downtown urban canyon performances. No more positions on the wrong side of the street. Post-processed decimeter level accuracies. Any application that needs really precise location will benefit off of this, like fitness applications, traffic info, and more. So at work, we get to work on some really cool, amazing new stuff. Let's put this all together. The future will become more and more contextually aware. We'll continue to add more signals into the Android Sensor Hub. We've already achieved activity recognition and geofencing. Next, we're going to add the Fuse location provider, awareness, places, and more. We'll do this with deep neural networks, machine learning algorithms, and our personalized models with the goals of helping you make deeper experiences to your users in your applications. By adding all these signals, we'll reach a point of location and context singularity, where you'll be able to write applications that simplify user interactions, help augment human memory and knowledge, and your users having a better understanding of themselves. I'm truly excited about this future and all these possibilities. Thank you very much.
Launching a great app requires dedication and vision, but growing one takes revenue. How about a monetization solution tailored specifically to your app? One that has rich and engaging ads, one that works with Firebase to give you the insights you need to grow, and one that uses mediation to connect you with networks all over the world. Well, that solution is AdMob. Trusted by more than 1 million apps, AdMob offers developers everything they need to implement first-class monetization strategies. And when paired with Firebase, it's even better. AdMob is included with the Firebase SDK, and its APIs are built to make adding banners, interstitials, and video ads to your app simple. Plus, AdMob automatically selects the ads that pay you the most, so you can sit back and watch your revenue grow. And as your business grows, you can benefit from AdMob's advanced features. Say version 2 of your app has a slick new design, and now you need an ad format that fits naturally with your content. With AdMob's native ads, you can create CSS templates designed specifically for your user experience. We'll style the ads to match and display the result in a native ad view that fits your app like they were made for each other. And it doesn't stop there. AdMob helps you earn in-app purchase revenue too. AdMob can determine which of your users is most likely to make a purchase and target those people. They'll see an ad you design, and they can make purchases right there. Now, with your app's slick design and in-app products, it's become a worldwide sensation. But how can you make sure you're maximizing the revenue generated by each user? With AdMob, you can connect to ad networks around the world, bringing even more advertisers who'll compete for your impressions. And because you're using Firebase, you get access to free and unlimited analytics. Imagine a big-time blogger in Tokyo posts about your app, and overnight, your Japanese audience quadruples. With Firebase Analytics, you can easily spot the trend, and then switch to your AdMob settings to tweak mediation configurations or start a campaign targeting your new fans. That's AdMob with Firebase. It's as easy as you want and as powerful as you need.
The Firebase Notifications console lets you re-engage your users quickly and easily. With it, you can manage and send notifications to your users easily with no additional coding required. Messages can be addressed to single devices, Firebase Cloud Messaging topics, or devices that you select using powerful analytics tools. So, for example, you could send a message to all of your users who have made an in-app purchase, giving them a special offer, allowing you to re-engage with them. The Firebase Notifications console integrates with analytics so you can measure the effectiveness of your messages and explore insights based on your users' activities, so you can grow your application by easily engaging your users through the Firebase Notifications console.
We all know from experience that people love to share things about themselves, such as photos, videos, and GIFs that express their feelings. So what do you do to let them store and share these files through your app? That's where Firebase Storage can help. Our storage API lets you upload your users' files to our cloud so they can be shared with anyone else. And if you have specific rules for sharing files with certain users, you can protect this content for users logged in with Firebase authentication. Security, of course, is our first concern. All transfers are performed over a secure connection. Also, all transfers with our API are robust and will automatically resume in case the connection is broken. This is essential for transferring large files over slow or unreliable mobile connections. And finally, our storage, backed by Google Cloud Storage, scales to petabytes. That's billions of photos to meet your app's needs, so you will never be out of space when you need it. So give your users space to share their lives with Firebase Storage, available right now for iOS, Android, and web applications. And to learn more about Firebase Storage, check out the documentation available right here.
Hello, everyone, and welcome to the 2017 TensorFlow Developer Summit. And I'm delighted to see all of you here today.
Today, we are excited to announce TensorFlow 1.0. TensorFlow's philosophy has always been to give you the power to do whatever you want, but also make it easy, and this makes it even easier.
We really were hoping to build a machine learning platform for everyone in the world that was fast, flexible, and production ready.
The point of TensorFlow is to figure out how can we give this back to the community and be able to use TensorFlow to further whether it's the research or the production needs.
It's how we express our ideas, and it's the piece of software our engineers and scientists spend most of their time interacting with.
So TensorBoard is a really exciting tool. It's something that will let you take the confusing world of TensorFlow and start to dive into it.
It's just a really amazing time to be an AI researcher.
One of the projects that we've been working on is using deep learning for retinal imaging.
Can we use deep learning and reinforcement learning to generate compelling media?
But this is just the beginning. The TensorFlow community is truly global.
We want to see all the amazing things that you guys can do with TensorFlow. Thank you very much.
Good morning, Berlin.
It is an absolute pleasure to be here with you. Here we go. We're live. We have a lot of experience building some of the world's most popular applications, and we've learned a thing or two about what it takes to build an app. And we found that it's a pretty difficult process.
A lot of your time goes into running infrastructure instead of building the features that make your app your app. There has to be a better way. That better way is using Firebase.
We're now up to over 750,000 developers using the product.
If you use Firebase, your app's code talks directly to our powerful managed backend services. We take care of security and of scalability so that you can focus on building the features that your users love.
Today we're launching Firebase UI 1.0. It's an open source library. It has customized theming and it works for web and Android and iOS. So you can go ahead and drop that in and you'll have all of the UIs that you'll need.
Is my app set up correctly? Which events are being captured by the SDK? Are you receiving my events and parameters? We've built something, the ideal tool to answer all of these questions and these pain points.
App quality leads to better user retention. Better your app is, and the more stable it is, the more likely for users to come back and for your business to be successful and sustainable. And that's where we come in.
So we're really looking forward to get the feedback from the community, as always, to help us continue to refine our product and to work together to help you build a better app.
And we want you to be able to spend all of your energy on bringing innovation and creativity, something new to the world. That's really what we're trying to achieve here, is making all the infrastructure pieces simple for you. And I'm really excited for you to engage with Firebase and see how it can make you more successful.
All right, let's get back to the code.
We're now in the experiments tent, and there are so many cool things to play with. Before we get to that, which is going to be in just a moment, I just want to ask Amit what experiments are all about.
Thanks. So experiments are platforms that we bring out, websites. Each one is a kind of a playground that invites everybody to come in and send in interesting, playful things that they're doing with our technologies. We have Chrome experiments, Android experiments, web VR experiments, and AI experiments. They're all there, and new platforms will come out. And we're very excited about the things that people are doing with them.
And a lot of them are open source, right?
Yes, a lot of them are open source, which is amazing because experimentation is a wonderful way for people to play and discover new things for themselves. But when they share with the community, then everybody gets to see what's possible with AI, what's possible with web VR, and it's really amazing. And it's also amazing for us at Google to see the surprising things that sometimes happen when people just have fun and play with these technologies.
And a lot of them are built by people who aren't Googlers.
Oh yeah, absolutely. There's a submit button on there, and you can just go and send us the stuff that you're doing in the garage, the kind of passion project that you have, and you'll be surprised how helpful some of these projects could be for everybody else, especially we can get inspired and imagine new things with these technologies.
All right, let's check some of them out. First off is Quick Draw, and I'm actually going to play. Do you want to like narrate for everybody at home what we're doing?
Yeah, absolutely. So Quick Draw. Oh, thanks. So you might have actually played this game at home, but this is the multiplayer version of the game. What's happening here? It's a machine learning game. So you're going to draw something, and you're going to draw something, and the machine is going to try to guess what it is that you're drawing. And if the machine can guess right, you get a point. All right, so here we go. We got Timothy, Adam, and Nick. 3, 2, 1, go. So the machine is going to tell them something to draw. In this case, for example, Timothy is asked to draw water. And you can see over there that he's trying to draw water. And if the machine can guess, if the computer vision algorithm can guess that it's actually the handwriting API. If it can guess that he got water right, then he gets a point. So I think Nick is killing it over there. He's drawing a train, yeah. But Adam seems to be in first place with 14. After we got Nick Jonas with 12, and Tim up. There we go. We're done. Time's up. All right. Third place, Timothy, but it's okay.
All right. That was the water that got me. How do you draw water? I just drew the surface.
That's the funny thing. Some things are perceived differently, right? Like people think water drops versus river water shapes, and it's different every time. Yeah.
Awesome. Thanks, guys. All right, let's go check out something else. There's something that makes music over there, right?
Yes. Okay, so this is a really exciting one. The artist Giorgio Moroder, who used to be he is the king of Europop, created this amazing soundtrack. And what we've done is we're using the computer vision API to go and have the phone identify different items, and then the phone is actually narrating itself as a soundtrack to the music, telling us about what it's seeing, what it thinks it's seeing, and how it's identifying these objects. And that actually becomes part of the song. So it's kind of...
That's really cool.
I think it's better to just listen to it, right?
All right,
yeah.
Let's go check it out. You guys ready?
Perfect.
All right, which one should we do first?
We should
do the guitar. Recognition with me. Take a picture and it'll tell you what I see. Here we go. I'm on it. All right. Is that guitar or not? No. Got musical instrument in this spot. Okay, what else? Yeah, I'm on it. Looks like automotive exterior to me. I'm seeing vehicle.
This is really great. Okay.
Turn it on. All right. I'm on it. I think ceiling is what we've got.
It's a banana, silly.
Maybe not.
All right, I'll leave this with you guys. Thank you. That was really cool. All right, let's try a couple more things. That was super fun. So this is satellite imagery.
Yes, this is satellite imagery. It was created by an artist, Zach Lieberman, and the DAT team. So the idea here was really simple. What if you could search the world using a simple gesture? Right, and notice here how it takes you to different places all over the world every time you draw a gesture. So let's just give it a shot. Let's see where we go. Spain. Yeah. So it's an experiment. It's just a really wonderful experience, right? It's not like you'll be able to find your way to a specific place by drawing a gesture. That's not the point. The point is really, this is optimized for a really joyful and fun experience. Do you want to try the other mode as well? Yeah. So what it's going to do here is build this imaginary city built around these tiles. As you start dragging in a certain direction, it'll start building a road by combining all these tiles. There's about 50,000 of them that the team has processed using various algorithms to go and create this experience. And this is a Chrome experiment. You can check it out at chromeexperiment.withgoogle.com. Oh, no, sorry, chromeexperiments.com.
That's really cool. It's really joyful and rather pleasant.
It is, yeah, it's very meditative. I mean, we've been standing here and seeing people play with it, and we find ourselves just like starting to it's mesmerizing.
Kind of zone out on the satellite image.
Oh, absolutely.
I mean, the world's a big place.
It's a big place. It gets a little smaller when you get to travel it this way. Yeah.
All right, I think we have time for one more thing. What should we check out?
Yeah, let's go check out actually a submission by a student, former student. He's graduated now from Denmark, and he's created a wonderful piece using machine learning. Very unexpected, interesting piece.
So this is Objectifier with spatial programming, and it's a really cool machine learning device that takes visual input, processes it through TensorFlow, and ultimately triggers if this then that statements. So you could imagine putting your favorite reading glasses on would trigger a reading lamp, pulling the sheets up at night, getting into bed will turn all your lights off. It can happen on device. It was built by a developer, Bjorn, out of Denmark, and if we had the proper European adapter, we could do it all right within this physical hardware. There's a Raspberry Pi Zero in there, and then it can ultimately connect to anything you can plug in for the trigger. There you are.
All right, well, I was playing with this earlier. It was very cool. I was able to hit the button and do a gesture, and then using that gesture, we could turn it off or on. That was awesome. So you wanted to say one last thing about QuickDraw.
One last thing, we're very, very excited today to announce that we're releasing, open sourcing 50 million images. These are vector drawings where the actual ordered strokes of images that people have drawn in QuickDraw. It's available now for developers to go and train their own models on, which is very exciting. Researchers can go and look at it and find some interesting patterns, and artists can go and do interesting and weird things and submit them back to us as experiments. So we're very, very happy to share all of this data with the world. Yeah.
That's awesome. Thank you so much. And thank you for showing us around the Experiments tent.
Oh, absolutely. Thank you, Timothy.
All right, Amit. So that was Experiments. Now, if you want to see this video again, or you want to see any of the other videos or recording at the sandbox areas here at Google I/O 2017, head on over to g.co/io/guide. I'm Timothy Jordan, and I'll see you at the next one.
Hi, welcome to the animation talk on Friday afternoon. We are opposite a Kotlin talk, so I think that means that everybody in this room didn't want to hear about Kotlin, which is perfect because we don't have any Kotlin on our slides. So welcome to the not Kotlin talk. I am Chet Haas. I'm from the Android UI Toolkit team.
I'm Doris Liu. I'm also on Android UI Toolkit team.
And we're going to tell you a little bit, actually a lot about animation. We're going to talk about small changes that were made to the existing animator stuff, small but very important and deceptively tricky to implement features. But more importantly, Doris is going to tell you all about a new physics-based animation system starting right about now.
Clicker. All right. So today I'm going to talk about physics-based animation. You might be asking, why would we need a physics-based animation library? A few years ago, before I joined the Android framework team, I was an app developer, just like some of you. I wanted to create a swipe animation for the Google camera app. And I had the camera menu moving in a beautiful waveform along with the gesture. I also track the velocity of the gesture up until the moment of finger release. Then I thought to myself, all right, now the only thing that's missing in this is getting the camera menu to continue the momentum of the gesture once the finger is released. So I looked into the Android animation framework for an API that can take velocity as one of the starting conditions and close the gap for me. I looked and looked, and there was no such API. If you've had similar experience building animations in your app, you're in luck, because today we're going to talk about the new physics-based animation library that we have just released. You might be asking, how is this new physics-based animation library any different than the existing animation API? Well, if you're familiar with the existing animation API, you know in order to create an animation, you will need to provide a start value, an end value, a duration, and an interpolator. Velocity, that's just an afterthought. Once such an animation is created, velocity has to be derived from other properties of the animation. Given that, it's extremely difficult to create an animation that can continue the momentum of the gesture once that's leading up to the animation. But with physics-based animation, it can handle the different gestures with different velocities much easier, and different gestures from small swipe to a really fast fling. Also, because the movements of the animation in the new system are governed by real-world physics, they look more natural and lifelike. And the new system can also respond to updated user input and dynamically change the target value of the animation during the animation. Now let's take a look at how different animation systems handle this target value change during the animation. Here we're using an object animator. I think some of you might be familiar with this. And the target value is indicated by the position of the green ring on the bottom. As you can see, the ring had moved before the animation is finished. And usually the way we handle this is we would cancel the ongoing animation and then reconfigure the animation using the new end value and then starting it again. But the problem with that is, as you can see, it leads to a really sudden and abrupt change in the movement. And if we look at the velocity chart for this animation, the blue and red curves in here represent the velocity x and y. At the moment of target value change, the velocities are dropped immediately back down to 0. And that's because we have canceled the ongoing animation. And then the velocities will start changing again once the new animation starts. But this discontinuity in velocity can create a really jarring experience for the user. In contrast, here's physics-based animation. When the target value is changed in physics-based animation, we interpret that as a change in the physics force. And then the new force will continue to act upon the existing velocity of the object, which is why we won't see a velocity discontinuity. And in this example, we can see the transition to the new target position is really smooth. And similarly, let's look at the velocity chart. And we're no longer seeing any discontinuity in the velocity, and that is the key to a smooth animation. At this point, you might be asking, so what exactly is this physics-based animation? The way we define it is, it's an animation that's driven by force. And based on the force, we can calculate the acceleration or deceleration, which we can then use to calculate and update the velocities and values for the animation, until finally, when the force reaches equilibrium, that's our signal to stop the animation. First, let's take a look at fling animation. Fling animation starts with the initial velocity, and usually that's the velocity of your gesture. And then it will continue that momentum, and then gradually comes to a stop. The force behind fling animation is a friction force, which is proportional to the velocity. What that means is velocity will undergo an exponential decay in the duration of the animation. And that will produce a very graceful end to the animation. And by the way, this fling animation is exactly the API that I was looking for years ago when I was building that animation for the camera app. Now let's see an example for the fling animation. Here, as you can see, I'm flinging this list from left to right. And the orange dot is indicating the position of my finger. And the list just took off at the same velocity of my gesture, and then gradually come to a rest. Now let's see how this is achieved. In order to get notified when a fling gesture occurs, we need to create a gesture listener. And once the fling gesture is detected, we'll receive this on-fling callback with a down event, an up event, and the velocity in both x and y axis. And we'll be using, and they'll be in the unit pixels per second, which is also the unit that we'll be using for the velocities in the new animation system. And now we're ready to create a fling animation. To the constructor of the fling animation, we need to provide the object we want to animate. In this case, it's the list of bearded androids. And the property that we want to animate, in this case, that is the square x, since we want to fling this list horizontally. And then we're going to set the start velocity. Here you can see I have inversed the velocity of the gesture. And that's because here we're animating the squirrel property. The squirrel property is sort of special in that a positive change in the squirrel value would actually move the list in the opposite direction as a positive velocity would. And then we're also going to set min value and max value to define the range for this animation. Fling animation would end immediately once it reaches either its min value or max value. And I would encourage you to set a good value range for your animation so that as soon as the animation goes off screen, it should stop right away. Otherwise, the animation might go on for too long without making any change on screen, while it would request for redraws and consume a lot of battery. And finally, we're setting friction to control the rate of deceleration. Now we're ready to start. So this is all it takes to create a fling animation. Now let's take a closer look at the fling friction. Here I'm going to create an animation for the view's squirrel y property with a starting velocity of 5,000 pixels per second and a friction of 1.1. And then I'm going to create another animation with the exact same setup, except we're going to double the friction. And if we run these two animations side by side, we can see how the friction affects the look of the animation. As you can see here, with a smaller value of friction, the animation would go on for much longer, whereas when the friction is higher, naturally it decelerates the movement a lot faster, causing the animation to stop a lot sooner. And you can configure the friction to whatever positive value that looks good for your animation. In addition to fling animation, we've also introduced spring animation in our new animation system. Now first, let's create a spring animation. Here, to the constructor of the spring animation, we're going to supply the object we want to animate. In this case, it's a view. But it doesn't have to be a view. It can be any object. And then the property we want to animate, in this case, is a translation y of the view. And then finally, the resting position of the spring. Now we're ready to start. So this animation would animate the view from whatever translation that it had at the start of the animation to back to 0. And here's what it looks like. As you can see, as I'm pulling this little android down, it's moving its translation y while stretching the spring as it goes. And then once I let go, that's when the spring animation would start. And then the translation y would start from where I released it back to 0. And you can see it bounces back up and oscillates a little bit before it rests at translation y of 0. And if you feel adventurous, you can also change the bounciness of the spring by simply setting the damping ratio. Here we're going to set the damping ratio to not bouncy at all. And that's what we see in the animation. If you look at this animation and you feel like this doesn't really match your taste for spring animations, we have an easy fix. You can simply change the damping ratio to high bouncy, and then you will have a very bouncy animation with a lot of oscillation before it finally settles. In addition to damping ratio, you can also change the stiffness for the spring, which will control how quickly the object would return to its resting position. And we'll take a look at that in a moment. Now, before we start the animation, we can also set some starting conditions for the animation. For example, if we set the start value to 200, this animation will go from a translation y of 200 back to 0. And also, we can set the start velocity to match the existing movement of the object, creating a continuous motion. We can also set the min value and max value, like we did for fling animation, and define the range for the animation. Now we're ready to start. So let's take a look at the stiffness from low to high. Here we have, if you look on the very left, when the stiffness is very low, the spring compresses rather slowly after it's stretched out of its resting position. And when the stiffness gets higher towards the right, it bounces back up much faster. And these are the 4 spring stiffness constants that we have already defined in our system, because they each provide a somewhat unique look. You can use one of these already defined constants, or you can use any positive float value for the spring stiffness in your animation. Now that we've seen how we can animate translation using spring animation, let's see what we can do when we combine the rotation and translation together in the spring animations. Here we have an example of that. As you can see, as this list flies in, each individual head sort of shakes around as if they were hanging on to a clothesline that we're pulling in. To achieve this, we need to apply a rotational spring force on each individual head, along with the translation animation to slide this whole list in. First, we need to rotate each individual head. We need to go through all the items on the list, and for each item, we'll need to create a spring animation on its rotation property. And you may have noticed here I'm using a different spring animation constructor as we did before. And this constructor doesn't require a third parameter, which is the resting position of the spring. When using this constructor, the spring animation won't create a built-in spring force. And it would instead expect a custom spring force to be passed in. And that's what we're going to do. We're going to create a custom spring force of a resting position of 0 and a damping ratio and stiffness that looks good for this particular animation, arrived at through careful experimentation. And you might ask, why do we want to use a custom spring force instead of the built-in spring force? And the answer is, by creating a custom spring force, we can then share this spring force across all the spring animations for the children. Note, this is only viable when all the spring animations here expects the same spring constants and the same resting position. And finally, we can set the start value of the rotation animation to -25, so that each head would rotate from a -25-degree angle and then oscillate around 0 degree and eventually come to a stop. Now that we've rotated each individual head, we still need to slide this whole list in. We can do that by creating a spring animation for the list on its translation X property. And similar to the rotation animation, we're going to configure the spring constants. Here, we're going to use the same spring constants as we did before. And finally, we're going to set the start value so that the translation Y would start from 400 and then slide back into place. So we've seen spring animations on rotation and on views translation. What if you want to animate something that's not a view property? Well, good news is physics animation supports that. Here's an example of that. As you can see, when I tap on the little mustache icon, all the items just pop in and blow up beyond its normal size and then shrink back down, making a very dramatic entrance. And we could achieve this by creating not one, but 2 spring animations for each individual child. One on its scale X property, the other one on its scale Y property. So each individual head would be able to scale along both the X and Y axis uniformly. But that's a lot of work. Now let me show you a different way to do this. Imagine, what if view group had this property, let's call it child scale. And whenever child scale changes, the view group would propagate down that change to all its children in both the scale X property and scale Y property. And in that case, we can just animate this one child scale for the view group, and then we're done. Even though view group doesn't really have this property, we can create one for it. Here, we're going to create a custom property using float property compat. And we're going to have to override the set value and get value. Whenever the child scale changes, we will receive this set value callback. And in that, like we mentioned, we're going to pass down the change to all the children and then change their scale X and scale Y property uniformly. And in the get value, we'll, since we're assuming all the children to have the same scale, we can just return the scale of any child. In this case, we'll just return the first child. Now that we've created this custom property, we can put it in an animation. So we're going to create an animation on the child scale property for the list of beers. And again, we're going to set the stiffness. If you remember, stiffness changes how quickly the object returns to its resting position. Here, because we want the scale change to be more graceful, we want to use a low stiffness. And finally, we're going to set the minimum visible change. And this is a method that we haven't seen before. What it does is it provides the animation system a hint as to when it would be a good time to stop, so that the animation doesn't go on for too long without making any visible change on screen. And the reason why we haven't seen this method before in all these previous examples is because up until this example, we had animated only the built-in view properties. And when we animate built-in view properties, the animation system can derive such a value based on which property is being animated. Here, since if you create a custom property, you will need to provide the smallest change in your custom property that can make a visible difference on screen. In our case, we're animating child scale, which is essentially a scale property. So we're going to use the already defined constant mean visible change scale. And then we can set the start value to 0.5 so that the scale animation starts from a half scale and then blow up. And then eventually, it will settle at scale of 1, its normal size. So we've talked about fling animation. We've also seen some cool effects from the spring animations. Let's see what we can create by combining these two. Here, we're going to use the same example as we did, or same list as we did for the fling animation. As you can see, I'm flinging this list back and forth. But as the fling animation gets to the end of the list, there's still some velocity left. There's still some remaining energy. And that's when the list starts to stretch out and snap back like a rubber band. This is a very playful way to dissipate the remaining energy when arriving at the end of the list. And I think you will agree with me, this is a much better experience than harshly stopping the motion and losing all the momentum. In order to achieve this, we first need a fling animation. And we're going to just use the same fling animation as we did before. Except this time, I'm going to call out the set min value and set max value. These define the range of the animation, like we mentioned before. But this range ensures that the fling animation would end immediately upon reaching either end of the list. And that's when we can start the spring animation to then take over whatever momentum that it has left. So in order to start a spring animation right after the fling animation, here we're going to use an on-animation update listener. Once the fling animation finishes, we'll receive this on-animation end callback with a fling animation and whether or not it's canceled, and then the scrolling value and the scrolling velocity. If the velocity is high enough, then we're going to create the spring animation for the stretching effect. And we're going to create the spring animation for this whole list on its scale X property so it can stretch horizontally. And as always, we're changing the spring constants to make the animation look good for this particular case. And finally, we're going to set the start velocity. Here, you might notice I'm not using the velocity that I received from this callback, because that's the scrolling velocity, which is pixel-based. And for our scale animation, we want something that's in terms of scale. We can do that conversion by simply dividing the velocity by the size of the menu. Now, before we start, we still need to configure one last thing, which is the pivot point. And that's for the scaling. As you can see, I'm really flinging this list back and forth. And depending on which way I'm flinging it, I want the stretching to go the same way as the scrolling direction. So when the velocity is negative, the list is scrolling to the right. And I want the stretching to go towards the right as well. That requires us to pin the list on its left side. And we can do so by set the pivot x to 0. Similarly, when the list is scrolling to the left, we want to pin the list on its right side. And we can do so by set the pivot point to the right side of the list, which is the width of this list. Well, we've seen each individual animation, each individual spring animations in the past slides. And I think we can create something that's more advanced and more complex if we build on top of that, such as chain springs. Here we have 3 views that are chained together via spring force. And you can see I'm dragging the top view around, and the white circle indicates the drag point. And the other 2 views would follow as the top view is moving around as if the 3 of them were attached to each other by a bungee cord. Now let's take a look at how we can achieve this. Let's name these 3 views lead, A, and B for easier reference. So our goal is to have A follow the lead as lead is being dragged around, and B follow A. And we're going to achieve this by using spring animations. Let's first take a look at how we can have A follow the lead. So first, we're going to create animations for A on its translation X and translation Y properties. And in the on-touch listener, where we're going to process the touch events and move the lead view around, we're going to first, for each move event, we're going to compare this event against the last event in terms of position. And then we calculate the delta, and this delta would be the amount of movement of the finger. And then we're going to apply the delta to the lead view's position so that the lead view would be moving the same amount as the finger. Once the lead view's position is updated, we want to update the position of or the animation for A so it appears like A is following the lead. And here we're going to use a method called animate to final position. And we haven't seen this method before. It acts one of 2 ways. If the animation is not yet started, this method would set the final position for the animation and start the animation. If the animation is already started, is already running, then this method would just update the final position for the animation. And what this means is every time we receive a move event, we're going to move the lead view. And then if A is at resting position, we're going to start animation to move A towards the lead view. If the A is already animating, then we're going to update A's final position so that if you remember in one of the earlier slides, the way physics-based animation handled target value change, A would eventually, after some course correction, it would eventually head towards the lead view. And this is how we achieve having A follow the lead. And finally, we're going to update the last position for the motion event for the delta calculation. Now let's take a look at how we can have B follow A. Similarly, we're going to create animations for B. And in order to get notified whenever A's position is changed, we need this on-animation update listener, and we're going to add the listener to A's animation. And in the on-animation update callback, we're going to receive A's animation, and then A's position, and A's velocity. We're going to do the same trick here. We're going to call animate to final position. So if B is not moving at the moment, then we would set the final position for it and start the animation to move it towards A. Or if B is already moving, we're going to update its final position, so eventually head towards A. So the physics-based animation is available now in SupportLib 26 beta 1. And you can use it by adding this dependency to your Gradle file. And it's backward compatible to API 16. And I'm very excited to see what you guys can come up with using this library.
Awesome. So that was the cool new stuff, but what if you're still using the cool old stuff? So that's what I'm here for. So animator set, there was long requested functionality in terms of being able to seek within an animation as well as reverse. We have this in the value animator API, but not in animator set because it was difficult to do. So now we have these capabilities, and I'll show a simple demo and some code that's not written in Kotlin, and you can see how to do that. So there's a famous quote that I think everybody probably knows, seek and you shall find. It turns out that this was taken out of context. The full quote goes something like this. Seek and you shall find that there is no seek API on animator set. Right? Nobody knew that, but I'm here to tell you that. Also, it turns out that there's no way to reverse it. But we did some things about that, and I'm going to show you how you can use that functionality. So here we have a really simple, rather lame demo. What I want to do, given this amazingly complex UI, is move those 3 buttons around on the screen when the user clicks on the various controls there. So in particular, when you play the animation, I want the button on top to move to the right, the button in the middle should move down to the right, and the button on the bottom should move straight down. So the button, when it moves to the right, you create an object animator, fairly straightforward. We're going to animate translation X, and we're going to move it all the way over until it's positioned all the way over on the right. The button in the middle, we're going to move it to the lower right. Similarly, we create an object animator. We can use property values holder so that we can animate X and Y at the same time inside the same single object animator. So we're doing translation X and translation Y in parallel. And finally, the button on the bottom is going to move all the way to the bottom of the screen. Similarly to the one at the top, it's going to animate translation Y all the way down to the bottom. So we create these things, and then we create the animator set that contains these child animations. We're going to run them in sequence, so it's going to go top, middle, bottom. So we'll play those sequentially, and then we start the animation, which looks something like this. I bet you couldn't guess what was going to happen there. So you press the play button, animation plays, fairly straightforward. That's what you could do already. But what happens if we actually want to seek within the animation? Well, now we call this new method called setCurrentPlayTime. So we've hooked this up to the seek bar at the top. So when we get a call back into the onProgressChanged method, we can see where the seek bar is in that track that it's in and interpret that as a percentage of movement, and then apply that to the animator set animation. So set current playtime using that percentage multiplied times the total duration that the animation has. So we have this get total duration method on animator set. We get that, multiply it times the percentage, and away we go. So we drag it around on the screen, buttons move, all the child animations are moving independently depending on where we've seeked in the animator set animation itself. All right, and then finally, I bet you couldn't guess how this is going to work. What if we want to reverse the animation? So the user clicks on the reverse button, and everything moves in reverse. Very straightforward. It turns out that the entire quote is now amended, and it's now until now. So please use reverse and seek. And get the capabilities that you want. A couple of notes on that. One is that it will specifically seek within child animations that are a value animator, because if it's not a value animator or an animator set, we're not sure how to reverse or seek that thing. Right? So if your child animation is just an animator, it's this opaque thing that you've implemented, we're not sure what to do about it. That will get dropped on the floor, or you can implement that functionality. But it's really specifically for the common case of value animators and object animators, subclass of that. Another thing to note is there is new on animation start and on animation end callbacks in the interface, default methods that we implemented that will then provide you the direction. So in addition to knowing when you're starting and ending, it's useful if you know what direction you're running in, given the new capabilities that Animator Set has, so you can access those as well. And that is the talk. And we do have, sure. Thank you.
The IndexedDB 2.0 standard is now fully supported in Chrome and features new schema management, bulk action methods, and more standardized handling of failures. Progressive web apps become more immersive with display full screen. Allow top navigation by user activation gives sandbox iframes new powers, and there's plenty more. I'm Pete LePage. Let's dive in and see what's new for developers in Chrome 58. The structure of your site's database has large performance impacts and can be difficult to change. IndexedDB 2.0 changes that. Updates, object stores, and indexes can now be renamed in place after refactoring. Binary keys allow for more natural keys without worrying about performance penalties. Data retrieval is easier with getKey, OpenKeyCursor, and continue primary key methods. And bulk recovery of entire datasets no longer needs a cursor with getAll and getAllKey. When progressive web apps are launched from the Android home screen, they launch in a standalone app-like mode that hides the Omnibox. This helps create an engaging user experience and frees up screen space for content. However, for even more immersive experiences like games, video players, and other rich content, mobile UI elements such as the system bar can still be a distraction and take up valuable pixels that you may want. Now, you can make your progressive web app feel more immersive by setting Display Full Screen in your web app manifest. When your app is launched from the home screen, all non-app mobile UI elements will be hidden. Chrome 58 now supports the new iframe sandbox keyword, Allow Top Navigation by User Activation. When triggered by a user interaction, this keyword gives sandboxed iframes the ability to navigate the top-level page while still blocking auto redirects. And of course, there's plenty more. Say goodbye to the clear fix hack. Instead of manually resetting multiple layout properties like float and clear, you can now add a new block formatting context using display flow root. Pointer events.getCoalesced events allows you to access all input events since the last time a pointer event was delivered. Perfect for when you need a precise history of points for things like drawing apps. And workers and shared workers can be created using data URLs, making development with workers more secure by giving them an opaque origin. These are just a few of the changes in Chrome 58 for developers. Check the description for more details, including links to the docs and specs.
Hey everyone, Sam here. In this web series, we'll solve common web problems with standards. These techniques are part of the web platform and work with any framework or library. Okay, let's go. If you're animating some elements, whether you're using CSS, the Web Animations API, or libraries which just use Request Animation Frame, make sure you help your browser stay speedy by letting it use your 3D graphics card. Sam, what are you talking about? When you look at a website, it's made up of layers stacked on top of each other, and your graphics card won't need to redraw for changes to only some certain CSS properties, specifically opacity and transform. These two properties let you move stuff around and change how visible it is. You can animate, width, color, or other CSS properties, but do it sparingly and not in response to user action, where you want to be snappy. To keep things fast, if you have elements that move around a lot, you'll also want to set the will change transform or opacity CSS property. This is a hint to the browser. This element should be a layer all the time. Otherwise, when you upgrade or downgrade to a layer, you incur a cost. The browser has to redraw that specific part of the page. But if you give everything in your page a layer, this might bog down your browser as it struggles to compose them all together. This is a complicated topic, and you should check out more documentation to learn more about it. And most importantly, your site doesn't need to be perfect. It won't crush your user's experience to make a few mistakes here and there, but it's good to keep on top of it. Check Chrome's rendering section inside Developer Tools once in a while just to see what's happening and how your site's going. This was Layers the Standard Way. See you on the next tip.
The only thing that evolves faster than technology is our expectations. We want everything. Better, easier, now. Suddenly, downloading an app feels like it takes forever. And in many parts of the world, data is still at a premium, with 1 megabyte costing up to 5% of a monthly wage. Let's face it though, until now, the alternative to native apps hasn't been great. But that was then. Progressive web apps can now deliver mobile web experiences with a native look and feel, offering features like real-time push notifications, adding a site to your home screen so you can easily jump back to it with a single tap, even when you're offline. Plus the ability to make quick payments on the go. And all from your browser. This is the next generation of the mobile web. So what are we waiting for? Let's go and build something great.
Android Wear 2.0 is the most significant update to Android Wear since its launch in 2014. I'm Hoi Lam, and I'm here to take you through 3 highlights of Android Wear 2.0. First, material design has arrived on Android Wear. The new Android Wear interface uses a darker color palette, which makes the watch blend in more in social environments. It also helps save battery by OLED displays. We also suggest that developer adopts vertical layouts and reserve horizontal swipe for activity dismissal. In our research, this makes user interface easier to understand. To help developer implement these new design patterns, we have introduced new user interface components such as the wearable drawer layout and wearable recycler view. Check out the material design for Android Wear site for more details. The second highlight for Android Wear 2.0 is watch face complications. Before Android Wear 2.0, if a watch face wanted to display data from another app, they need a one-to-one agreement in both business and technical terms. To alleviate this complexity, with Android Wear 2.0, we have introduced the Complications API. Complications are a traditional watchmaking term for areas of the watch face that displays information other than the time, such as the date or phases of the moon. We have extended this concept to smartwatches, so any app can publish data for watch faces to consume. And watch faces can display these data in a style that fits into their unique designs. For app developers, this helps increase user engagement and mindshare. For watch face makers, this adds utility to the watch face. Users can now choose whichever watch face they want, as well as getting the data that they need. Check out the watch face and complications sections of the developer documentation for more details. Last but not least, standalone functionality. Previously, Android Wear 1.0 apps require a phone app to communicate with the cloud. With Android Wear 2.0, Wear apps can access the internet directly without the need for a corresponding Android phone app installed. This means the Android Wear app can access the internet even if the user has an iPhone. To help with app distribution, we have also put the Google Play Store on the watch. Users can now download apps directly on their wrist. Apart from these 3 areas of improvement, material design, complications, and standalone apps, there are numerous other enhancements with Android Wear 2.0. Check out the Android Wear developer site for more details. I'm Hoi Lam. Happy coding!
Hi everyone, and welcome back to Ask Firebase. I'm James Tamplin, a co-founder and product manager on Firebase. A fun fact about me is I first started programming at the age of 12 using a TI-83 basic in math class. Needless to say, my math teacher wasn't pleased. Nice. Our first question comes from Mr. Pan4. How did you meet Firebase co-founder Andrew Lee? So Andrew and I actually went to high school together. We've known each other now for about 17 years. After we both finished university, Andrew gave me a ring and we had dinner at a small Midwestern diner. And 9 years later, we're still working on making lives easier for developers with Firebase. This next question comes from Harold Weisinger. And Harold asks, is there a way to run my cloud functions once every hour? Great question, Harold. Unfortunately, currently there isn't. However, it's our #1 most requested feature for cloud functions, which we launched last month. Stay tuned for more news on our Twitter, Facebook, and YouTube channels. Thanks for the question, Harold. Next question. TJ asks, can you check the progress on a database request to know when it's finished? Well, TJ, we have a couple of ways you can kind of get at this. First of all, when you write into the Firebase real-time database, you can attach an onComplete callback with your set request. This will let you know when the write is completed to disk. Alternatively, you can check out our Firebase real-time database profiler that we released just a couple of weeks ago. This will give you granularity at a path level into both the latency and the bandwidth usage. This way you can get a little bit more insight into what's going on with the Firebase real-time database. Thanks for the question, TJ, and check the links in the description for more information. Next question.
Lighter.
Our next question comes from Se-Chun Kim. What's the limit of Firebase projects that can be created? Well, Se-Chun, it depends. We don't actually publish or document the limit of projects that can be created, since that number actually depends on inputs from our spam and abuse teams. However, a couple of things to note. First, billing accounts or paid accounts don't count towards this limit. So if you're having trouble, you can upgrade to either our Flame, which is our $25 a month plan, or our Blaze pay-as-you-go plan. Also, if you're still running into trouble, please reach out to our support team and they can help you raise that limit. Check out that link in the description below. Next question. Charles asks, where do you see Firebase in 5 years? Well, Charles, in 5 years' time, we're still going to be creating great tools that make developers' lives easier. Software is playing a bigger and bigger role in society at large, and we want to help the people creating that software. We'll do this by allowing them to focus on solving their customers' problems, by letting them not focus on low-level infrastructure, by not making them stitch together a myriad of growth tools. While I can't comment on specifics, I can give you a few general areas of where we'll be focusing. The first of which is more deeply integrating with Google Cloud Platform. This lets developers start with Firebase and then move seamlessly into Google's public cloud offering. Second of all is a focus on machine learning and integrations there. It's no secret that this is a big focus for Google. With integrations, we can intelligently provide recommendations to developers about next steps they can take to grow their app, or how they can better improve their app quality. It's going to be a great next 5 years for Firebase, and we're excited to serve you, our developers, as best we can. Thanks for the question, Charles. Our last question comes from Gabe, who asks, how has the culture of the Firebase team changed since joining Google? Well, Gabe, we were 23 people when we joined Google, and now we're more than 10 times the size. So things have certainly changed a little bit. However, I would like to think that we've changed Google more than we've changed ourselves. Specifically, we've changed Google's processes towards building developer products, trying to bring a focus on developers around the globe rather than just Google engineers. We've done this through things like one-on-one developer feedback sessions, through a lot of meetups, and through introspecting and dogfooding. By preserving this culture, we'll try and make developer offerings across Google better for you, our developers. So thanks for the question. That's all we have time for today, but thanks for all of your questions. Do keep them coming on Twitter, YouTube, Stack Overflow, and more with the hashtag AskFirebase. I'm James Tamplin, and we'll see you next time.
Hi everyone, Timothy Jordan here for one last interview, this one with Françoise, principal scientist here at Google.
Hi Timothy.
How are you?
Very good, and you?
I'm doing so good. The festival has been amazing, and we've had the opportunity to talk to a lot of people about what they do, and that's why I'm excited for this moment here, because you do some really cool stuff.
All right, yeah, it is cool, I agree.
So why don't we give everybody just an introduction to the work that you do around machine learning and input?
Yeah, so I work on speech recognition and I work on keyboard input. So speech recognition, you all know what it's about. Sundar has been talking about our progress in voice and how we've lowered our word error rate quite a bit, Google Home and all that. I've been working on speech for the last 12 years at Google, and then more recently, maybe last 2-3 years, I've been working on keyboard input. And you know, when people think of their keyboard, they think it's something very simple where they just take the mobile keyboard on their phone and they just tap, you know, the letters of what they want to spell. But in reality, if you want a good keyboard that really understands you and corrects your mistakes and predict the next word that you're going to type, it's pretty complicated. And there's a lot of machine learning that goes into keyboard as well.
Yeah, that's one of the things when you and I were talking about this earlier, is that that's a common misconception that like machine learning wouldn't apply to the keyboard because you're just hitting buttons, but that's actually not true at all.
No, it's not true at all. You know, keyboard is very interesting because it's such a complex product in itself, because you can do a lot of things with a keyboard. You can tap on the keys, you can swipe what you want to write, and then you can even click on the microphone and then you can speak to your keyboard too, right? So the two modalities come together there. But doing a good job at correcting your typos, yet letting you type new words that the keyboard maybe doesn't know about, and then learn those words and those phrases for you, and then being able to predict the next word or the next phrases that you're going to type, so that you don't have to type them. You can just say, oh yeah, that's what I meant, click. That takes a lot of machine learning. Yeah.
Awesome. You know, one of the other aspects of your work that I find really interesting is I end up talking to a lot of machine learning researchers that are just blazing new ground. It's really interesting, but it's like very theory and theoretical. But what you do is you have problems, and you've just found that machine learning is a good way to solve them.
Right. So the way that I like to think about these problems is I have a technology to build, right? And it has many facets, and there are many things that we need to optimize. It can be the machine learning, it could be the UI, it could be the infrastructure that's behind it that nobody sees. And so what we're really trying to do is to understand the pain points for the user. Where are the places where our users are wasting time, are getting frustrated? What are the places that they enjoy instead? And then trying to understand those problems, then we look at what are the right solutions for those problems. And sometimes the solution is just, you know, sweeping a parameter, and sometimes it takes like a really complex piece of machine learning. So we're just picking the technology that matches the problem that we have to solve, and we improve the technology one step at a time.
It's really interesting to kind of have that perspective of it's very pragmatic about machine learning.
Right, exactly, exactly. And I think it's a good approach, because once you know exactly what, the hardest part is really figuring out what is the problem that you're trying to solve. And I think a lot of developers are struggling exactly with that same problem. It's what is it that I'm trying to solve, how am I formalizing that, and then what is the best tool to solve that problem.
Awesome. Yeah. So there's another aspect of your work I want to bring up. This is the last one, I promise, which I find really interesting, and you call it deep internationalization. Can you tell me what that is?
Yes. So, you know, as you may guess, I'm not a native US American speaker. I grew up in Belgium. Belgium is a country with French and German and Flemish. I learned Italian when I came here to the United States, so I care deeply about languages. And we have found, developing those keyboards, that a lot of countries in the world and a lot of languages are not well represented in mobile keyboards. What I mean by that is that there are a lot of people in the world, sometimes tens of millions of people, who speak a language and would like to write to their friends in that language, but that language is not supported on a keyboard. So what do? Either they go back to another language, so maybe I cannot type in French, I would go back to English because it's okay, my friends understand English too. But that's not what I want to do. I want to speak French with my family. And if we happen to speak a much, you know, more distant language that is not well represented, we wouldn't have the luxury of being able to talk to each other in our own language. So that brings us into this space where we think it's not just about bringing a few tens of languages into our keyboards and into Google technology in general. It's about hundreds of languages. It's about going beyond 1,000 languages. There are in the world 1,342 languages, according to linguists, that have more than 100,000 speakers. So you imagine, and if you go into even the deeper end, it would be in the 6,000, 7,000 languages. And so I really have a passion for bringing as many of those languages online as possible and progressively enabling technologies like speech recognition, keyboard input to more and more languages.
And the way you design an app is just a little bit different if you're trying to design for all of them, right?
Yeah, so the app itself, we try to keep things as general as possible because there's no way you can scale to hundreds of languages if your infrastructure is not general and your modeling methodologies are not as general and scalable as possible. And that's where machine learning actually is very helpful to us, because before we had machine learning to solve our problems, we would really hard code things, and you would see pieces of C++ code that would say, if language equal German, do this, right? And that's not what you want. There's no way to scale that. With machine learning, you essentially have the algorithms that are data independent and language independent, and then the data is the piece that contains the knowledge about the language. So now there's this nice interface between algorithmic work and data work. And so once you have the right algorithms, it's just a question of pumping data from different languages into them to create a new capability in those languages, and if you improve your algorithms, all the languages improve at the same time. So it's a really nice synergy as long as you can establish that boundary, and with machine learning, that's very easy to do.
Yeah, and it sounds very sort of, once you get the right perspective, things start to fall into place.
Exactly, you really want to build from scratch with this thinking of how am I going to internationalize my product, my technology, but not just to 5 languages, just to hundreds of languages.
Okay.
Yeah.
So I think that's about all the time that we have, but thank you
right.
so much for joining with me and talking about all this.
Yeah.
Is there anything else, like say, if you could see some developers on the other end of this camera that would love to be doing the kind of work that you're doing now, what's some of the stuff that you'd tell them to get started on?
I think the best work that you do is really when you're passionate about the thing that you're doing. So I would think for each developer, if they are, and I assume they are, passionate about what it is that they're trying to develop, dig deep into it. Just don't be satisfied with something that's average quality. Keep digging and digging to try to understand your product the best you can and what your users want the best you can, and then keep developing from there and everything will go well.
Awesome. Francoise, thank you so much.
You're welcome. Thank you.
Hello, my name is Aga, and I'm one of the TLs on the Android Wear support library.
And I'm Ollie Lan. I'm the lead engineer for watch faces on Android Wear. It's great to be here. We're excited to tell you about some new things to help you build apps and watch faces on Android Wear. I'm going to introduce some tools to help you build watch faces with support for complications. But first, Aga's going to tell you about some big changes coming to the support libraries for Android Wear.
Thank you. So when smartwatches first launched, a lot of developers struggled to build apps for this new form factor. There were issues with small screens, round screens for the first time, and also bridging information from the phone to the watch. We built a wearable support library to help with these issues, and today I'm pleased to announce that we are starting to open source our code. The wearable support library will be moving to the Android support library and will become the so-called Wear module. This is similar to other modules in the Android support library, ones that hopefully you already know, like the core UI or the recycler view or design. So we will just become another module for you, again, open sourcing the code. This is launching with Android Support Library 26.0 Beta 1. So it launched actually 2 days ago, so you can start using it pretty much immediately. It's very easy to add to your code. You just add your regular dependency with a very similar structure to other modules. Just make sure to mention where there and Beta 1. So hopefully this change makes you happy. There's a few reasons to be happy. First and foremost, as I said before, the code is now open sourced. You can stop trying to reverse engineer it now. It's all going to be out there. The APIs will now be part of the support library, and they will be consistent with the rest of Android and the rest of the support library. We will have more frequent releases along the Android support library. That will be roughly every 2 months. And this means we will be able to take in more of your feedback and react to it a lot quicker than we were before. But we won't be moving all of the code at once. That would be a bit of a shock to the ecosystem to move everything. So we'll start with the UI components, and I'm going to focus on that for the rest of my talk. So the first package we will be open sourcing is the View package, or now it's going to be called the Widget package. And there we want to focus on enabling round-friendly UIs and space-efficient interaction patterns. So we're targeting the 2 main issues that developers had with UIs, which is building stuff for round screens for the first time in Android, and also building for really, really tiny screens, very little screen estate. It's not trivial to build good UIs in such conditions, so that's why those are the things we're focusing on first. Here's a good example of how we've enhanced a typical Android list. You used to have on Android a very straight list. All the elements would just go one by one, start at the top. What we've done with Wear here is we've played to the round factor of the watch. We've adapted the list to follow a curve, and that means also it fits a lot more information on the screen than it was able to with just a straight list. Here are some other examples of our best round-friendly UIs. We've got the launcher. We've got the date time picker, launched recently in the new desk clock app. And then we've got LiveSum, which is a great example of a third-party app that encompasses a round-friendly UI. So all of these make use of the curvature of the screen. All of them manage to fit more information in the UIs and are just generally more pleasant to use. So these are the kind of UIs that we want you to build in the future, and we want to help you build those UIs with the support library. So when building the Wear widget module, so the UI components, we were thinking of the UI generally in terms of components. Much like Android Framework, much like the Android support library. So with this module, we want to develop a suite of building blocks that would make it easier for developers to put together a UI which is both intuitive and feels native on Android Wear, as well as build it in a flexible manner enough that it will kind of express the personality and the character of your app. So we're exploring both tiny building blocks, like views, so image views or text views. We're also exploring larger ones, like the wearable recycler view or swipe dismiss frame layout. And we call these specifically components. And these components, this larger pieces of data, and you come together to form UI. So this is where you come in as developers, and you'll reuse our components and views to build your own apps. Okay? Some of these views and layouts already exist in Android, and some of them need to be implemented specifically for Wear. Those are the ones that we would want to go to put in the Wear module in the widget UI library. So here's a visualization, again, of how we think about UI. It's reusable building blocks rather than custom, tailored, or special case interfaces. Like, hopefully, that's not big news to you, but I wanted to make it very plain that this is what we're going for with this new library. So again, with this in mind, we hope we will enable you to build good interfaces, functional interfaces, very rich ones, that feel native to Android Wear, but also express the character of your app. So this is quite a long project. The complete construction of the Wear module will take some time, so I wanted now to spend the rest of my time to talk a little bit about how we will make it happen and what's the timeline for it, kind of step by step. So we have divided all the existing Wear UI elements, broadly speaking, into 3 categories. We will migrate the components that are already built for Wear and that are Wear-specific into the new Wear module. Some components we will merge. Those are the components that are useful not only for wearable devices, but also for handheld devices. So they can be reused on phones. And there's no need for them to live only in the wearable space. So we will kind of graduate or merge them into the framework or into other handheld or generic support modules. And then the last group is the components that we will deprecate. Those are the ones that are mostly associated with old design patterns that have not proven successful with our users. And I'll talk a little bit more about that in a second. So first, I want to talk about the components that will migrate. I want to kind of shine a spotlight on them. Those are the most important bits. They are the ones that are launching with the support library 26 beta 1. And that's the wearable recycler view, which gives you that nice curved list that we used also to build the launcher. Then we have the box inset layout, which enables you to fit all of your UIs on the screen into the center middle square of the screen. So you can reuse basically your UIs between a square and a round watch. And then we've got the swipe dismiss frame layout, which is quite an interesting case because it encapsulates a design pattern that we want you to use. So this pattern is replacing the back button on the handheld device. On Wear, we don't use the button for a back gesture. We want you to swipe away your views. That was a specific request from the developers during our developer preview program. So we're making this component available to you in the wearable support module. The next group, sorry. So in terms of code, should be really simple, short slide. On the example of the wearable recycler view, this is how you import it now into your code. And this is how you would use it in an onCreate method in the activity, for example. So now with the migration to the new module, there are very few changes that we would need from you in terms of code, hopefully very simple and easy to implement. So first, we changed the package name to support Wear widget to distinguish this new UI Wear module in the support library. And then the second thing is that we would introduce minimal tweaks to the API so that it is consistent with the existing Android APIs and support library APIs. These are better APIs and hopefully will make your code healthier in general. So super easy to update your apps. Really not much of an issue. Clicker. OK. So then some classes, the ones that we're merging, are not only applicable to Wear. This we will, as I mentioned, merge into the main framework or different support library modules. So here we've got mostly kind of what I call round things with an icon inside sometimes. There's a lot of them. All of them look the same. There's no point in having separate UI components for it, separate kind of pieces of layouts that you would need to use. And also, there already is a circle image view in the in the support library for handheld. So we're going to take all of those additional APIs that we've created and merge them into that one component, so that there's only one kind of really strong, really flexible component for you to use. And then the third group, here I want to talk about it on this example of a conversation in Hangouts, is a group of layouts that we're deprecating. So those are the layouts that are associated with user patterns that didn't prove successful, didn't prove popular with our users. So here we are taking the two-dimensional spatial model, where you could move either vertically or horizontally in an app or in the system UI, and we're transforming it into a linear layout, like here, just vertically, which is which is following the material design principles. So all of the classes associated with that two-dimensional spatial model will be deprecated. So that's the grid view pager, that's different action buttons, action layouts, things like that. So this will hopefully slim down your dependencies as well. That pretty much encompasses everything that we're going to be doing in 2017. And here's a rough timeline of what I've just been speaking about. So today we're announcing and launching the Where module with the first 3 core components. Just again to remind you, that's launching with the Android support library 26.0 beta 1. When that program graduates out from beta alongside the O launch, we will deprecate the old APIs in the current place, and then we will really encourage people to move over to the new APIs. Then we will subsequently have regular bug fixing and update releases of the Where module with the Android support library. And then sometime, say, mid-2018, mid-next year, we would be starting to remove old APIs so that we slim down, again, dependencies to the ones that we want people to use. So that's all from me. With that, I'm going to hand over to Ollie to talk about complications.
Thanks, Saga. Some important changes there. So I'm going to talk about some new things we're adding for watch face developers. And as this is a big win for anyone building a watch face, yes, it's another reason to jump in the air in front of a sunset. More personalized, helpful watch faces are a key part of Wear 2.0. That's why last year, here at I/O, we introduced the Complications API for Android Wear. On Wear, just like in traditional watchmaking, a complication is a display of data on the watch face. So these are all examples of complications. Apps using the Complications API can be data providers, or they can be watch faces. And Android Wear manages the flow of data between the two. So watch faces using the API can be configured to show any of the data providers that are installed. This lets users put the information they care about just a glance away. And if you build a data provider, you can get your app's data onto a whole range of watch faces. All of these apps already include data providers for complications. There's fitness apps, like Strava. There's finance apps, like Robinhood. And there's weather apps, like AccuWeather, and lots of others. So if you add complication support to a watch face that you're building, users will be able to choose from any of these apps if they're installed, as well as from built-in providers like the World Clock, Next Event, and Battery Life. It's like you're adding functionality from all of these apps without having to know a thing about them. Many watch faces have already added complication support, including classic-styled ones like Ultimate Watch 2, more abstract styles like Venom, and super customizable ones like Pugy Black. And there are ones that are a bit different. On Move from the Us2 Moods collection, the ring around the outside is a complication. So here it's showing your battery life, but it could also show your fitness progress. Mesh Turbine HD shows the complications on spokes, coming out from the center of the screen with a scrolling text effect. And FitCat, it has a cat. But it also has complications using the API in their own style. So there's a huge variety of styles of watch face on Android Wear. And that's why the API gives watch faces complete control over how they draw the data, to ensure complications fit perfectly and to allow new, interesting ways of representing the information. But this freedom can make it hard to add complication support to a watch face. When you build a watch face, you don't have access to layouts or views. You draw directly onto the canvas. And you have to create the settings UI yourself. Today, we're introducing a few things to make this easier. There's Text Renderer, which helps draw all kinds of text onto a canvas. Complication Drawable is a complete rendering solution for complications. A new settings sample shows how to let users easily configure complications and style. And a test suite provider lets you easily check if complications will display correctly. So first up is Text Renderer. And you might have noticed this has been in wearable support for a few months. Text Renderer makes drawing text onto a canvas easier. And that's important because many of the most useful complication types include text, such as the short text type, the long text type, and the ranged value type. The strings in the short text and ranged value types will be short. They should only be 7 characters maximum. Whereas in long text, the strings can be any length. And there are challenges rendering the text in both cases. So here's a short text example. This string here is 7 characters long, and it fits nicely at this font size. But this string is also 7 characters long. So to handle both of these and make them fit, you have to measure the text before you draw and adjust the font size accordingly. Here's a long text example. A short string looks good centered vertically. But the text can be any length, so it can easily flow outside the box. You can use something like a static layout to help with this, but you need to be careful not to relay out the text on every frame. With Text Renderer, you tell it the bounds that you want the text to fit in. If 7 characters don't fit, it will shrink the font until it does. And longer text can be flowed over multiple lines and ellipsized at the end. So let's look at some code. So when you initialize your watch face, create a text renderer using this simple constructor. And you pass in the text paint that you want to use. The text paint defines the font, the text size, the color, things like that. Now, because Text Renderer caches things like the layout, you should create one for each field. So we have one for the text here, and we also have one for the title. Don't share text renderers between fields. Now, when you want to draw, you need to set the text on the renderer. So you do that calling setText, and to get the text, you call getText. Now, this takes the current time, and you need to do this every time you draw, and that's whether you're using Text Renderer or not. And that's because some complications are time dependent. So imagine a world clock complication. The text changes depending on the time. Once you've set the text, draw into the bounds that you specify. Now, it's OK to pass in the text and the bounds every time like this, because Text Renderer only lays the text out again if something has changed. That does mean that sometimes you need to tell Text Renderer that a change has occurred, such as if you change the paint's text size. And that's because the paint is a different object from the Text Renderer. So let's imagine that we have code that makes the text bigger when something happens. In that case, you should call request update layout on the text renderer so that it can adjust. Now, one other thing that Text Renderer can do is adjust the rendering for the always-on screen, so for ambient mode. Many watch faces are black and white in this mode, so you might not want things like color emoji appearing. So you need to tell the text renderer that the device has entered ambient mode. So in on ambient mode changed in your watch face, you just pass the in ambient mode Boolean into the text renderer like so. So that's text renderer. We strongly suggest you use it whenever you're rendering text directly onto a canvas. But what if you want not just text, but the entire complication drawn for you in a standard way? That's where the new complication drawable comes in. Complication drawable can render all of the 6 main complication types, and it handles all of the layout and styling for you. As an example, let's look at what you'd need to do to render a short text complication like this. Now, without complication drawable, when data arrives, you need to decode any of images which are included. And you also need to cache those images, because you certainly don't want to decode them more than once. Now, every time you draw, first you need to check that the data is active. And that's because some complication data is only relevant within a certain time frame. For example, if it's for your next meeting, you don't want to show it after the meeting is finished. And then to draw, well, we draw the background, we draw the image, and we draw the text, probably using text renderer. With complication drawable, it's much simpler. When data arrives, you pass it to the drawable by calling setComplicationData. And then on every frame, you just call draw. It is a drawable. Now, like text renderer and like other drawables, complication drawable draws within bounds. And the layout adapts to the shape of the bounds. So here you can see within square bounds, you get a circular complication, whereas the wider bounds give a pill shape. And you can also see that the position of the icon is different in the 2 cases. If you don't set any style parameters, you'll get a default look. But there's many things you can set, such as the background color, the corner radius, if you'd rather have something more like a square than a circle. You can change the border or have no border at all. You can change the colors, and you can change the typeface. You can create a complication drawable programmatically with a simple constructor. And then you can set styling options for active mode and for ambient mode. But if you have lots of styling to set, you might find it easier to use XML instead. You will need to be using API level 24 to do this. But as long as you're doing that, now you can just inflate the drawable in the standard way. Now, we do need the context to render, so you'll need to pass that into us as well, into the drawable. And if you do that, then your XML might look something like this. So attributes at the top level apply to both ambient and active modes, unless they're overridden in ambient mode by the attributes in the ambient section. So there are a few things you need to pass to the drawable. As I mentioned earlier, you of course have to give it the complication data. So in onComplicationDataUpdate for your watch face, which is where you receive the data, you just pass that data to the drawable. You also need to tell the complication drawable when the device goes in and out of ambient mode. And that's because the drawable handles the change of styles for you. So all you need to do is call setInAmbientMode every time it changes. And you also need to tell the drawable if there are any special properties of the screen. So if it uses low-bit ambient mode, or if it has burn-in protection, tell the drawable that, and it can adapt the rendering for those properties. And then to draw, now, if it's the first time or if something's changed, then you'll need to set the bounds. So set the bounds, and you just call setBounds on the complication drawable. Now, the bounds that you pass in here should be defined in proportion to the watch face bounds. So you might say, position it 1/4 of the screen width across. Don't use fixed dimensions, and that's because watches vary hugely in their size, so you don't want to be defining things in an absolute way. Then you can just call draw on the complication drawable, This method also takes the time, and that's so it can get the correct up-to-date value. So that's it, complication drawable. So that should really make it a lot easier to add complication support to your watch faces. Now, complication drawable is the biggest addition to wearable support, but the next two things are available as samples so that you can adapt them to meet the needs of your watch face. The first is the settings. Any watch face with complications should include a way to configure them, and usually that's in your watch face settings. But if you bury complications deep in your settings UI, it can be frustrating for users who want to change things around. For the LG Watch Style and Sport, we worked with our partners O'17 to design an UI that lets users have a visual interface for setting up complications and also have quick access to other settings. So here's how it's set up. At the top, we have an image of the watch face with the complication slots clearly shown. This lets users get a good idea of where the data is going to appear. Provider icons show what's currently selected in each slot. Below, if you scroll down, you can see all of the other settings. Now, background image here is a special case. Technically, it is a complication using the large image type. But in studies, we've found users understand this better as a separate item. So this is what it looks like on the portions watch face. And now let's see it in action. So you'll see the user can just tap on one of those slots at the top. It opens the complication provider chooser, and they can quickly choose what they want in each slot. It's much easier than having a list with left slot, right slot, top slot, etc. If you'd like to try this on a real watch face, download the O'17 Looks or Moods collections on any watch running Wear 2.0. All of those watch faces use this UI. Now, you'll find this UI implemented in the updated watch face sample. So check out Analog Complication Watch Face Service in the sample. This has been updated for the new stuff that we're introducing today, so it also uses complication drawable now. The config UI is in Analog Complication Config Activity, and the items that are shown in the UI are defined here in Analog Complication Config Data. Let's take a quick look at that class. So in here, you'll find this method, getDataToPopulateAdapter, and it returns a list of config items. So those define what the entries in that settings list are. So the top entry will probably be the preview and complications config item. That's the view of the watch face with the slots. And then we might have a background option. We might have some more options, and then return. The actual sample has a few more details than this. So that's settings. Now let's say you've added complication support to your watch face. How can you check that everything's working? For most complication types, there are several combinations of fields that you must handle. So for example, if your watch face supports short text complications, that might be in the form of an icon with text, or it might be a text and another piece of text, or just a single piece of text. The test suite provider makes it easy to make sure that every combination looks good on your watch face. So when you install the test suite, it'll appear in the list of data providers. And when you pick it, you'll be able to choose which complication type you want to test. So let's say we choose short text. Here's how it might appear on the watch face. And then all you have to do is tap the complication, and it will cycle through the different combinations. So all of these are short text complications. And if your watch face supports short text, it has to render all of these correctly. This is a long text example. And for long text, there's even more combinations. So it's really useful to give this a go and check that everything works properly. You can have icons with text and title, just text and title, or images as well. We're releasing the test suite provider open source on GitHub so that you can see how it works and so that you can add your own test cases if you want. If you're building a data provider and not a watch face, I suggest you also take a look at this. because it's a good example of a provider for each of the different complication types. So that's it. So these 4 tools should make it a lot simpler and easier to add complication support to a watch face. Please do give them a go. There are code labs to try out here at I/O, or you can check out the samples on the dev site or through Android Studio, or you can start using the new version of wearable support and try it out on your own watch face right away. And please do let us know what you think.
So this is just one last slide that sums up our presence, Android Wear presence at Google I/O 2017. If you haven't seen the talk yesterday at 9:30 a.m., it is recorded. It was a general overview of how the platform is doing and what's new in the platform this year. And today's talk is also recorded, so you can come back to it after I/O is done. Thank you very much. I think we've got a
and
few
with that, we're
minutes
happy
for
to
questions.
take any questions.
Yeah. Good.
When we want to learn something, it's not very comfortable for girls. Generally, they don't go out and learn with with other colleagues. They don't prefer learning with someone. The reason I go to Udacity is because a friend of mine told me about how wonderful the course is, and even if you know nothing about Android, the courses are designed so that you don't have to have a very much detailed experience in Java or Android. So when I started the course, I was like very scared that like maybe it will be too technical for me to understand because I don't know very much about Android or Java in very deep, like how to have some logic into a program and how to code in general. But the instructors, like my favorite way, Catherine, she makes it so interesting and so normal. You don't feel like that you are learning something, and it's a good way to learn online. Whatever I feel like learning today, I could just go and then search for it, and there will be a course available for that.
I was an HR. I was working as a recruiter, and I was completely unaware as to what I am supposed to do. I used to feel that I just don't want to be a recruiter. I want to be on that other side, talking technology and talking about gadgets and how technology is changing our day-to-day lives. One of our relatives, he challenged me that you are a girl and engineering requires a lot of designs and drawings. I wanted to prove him wrong, and that was the time when I heard about Udacity. I started taking some online courses in Java and Android, very basic things. It is little difficult, but it's just that I don't want to feel that, that sense of regret. I just don't want that. So Udacity has actually been a savior in my life. The quality of the projects is very good. It's like, after completing those, you feel like you have conquered something. Actually, I finished my nano degree yesterday, and so today it's just going to be the celebration.
Did you know that the average user has 36 apps on their device and doesn't use 3/4 of them most of the time? And of those, about 1/3 of them have only ever been used once. Well, what if that's your app? You've done the research, you've written the code, you've performed the testing, you've perfected the design, you've gotten the installs, and then nothing. So, how do you prevent this? App indexing helps you re-engage with your users through tight integration with Google Search. As well as appearing in search results, it surfaces your app through autocomplete and now on tap. All you have to do is get your app in the index. And when users search for the content that's already in your app, they'll be able to see your app directly in the search results and be able to launch it right from there. It's as easy as that. But how does it work? If your app and site have similar content, you associate them with each other. Then, your app can receive incoming links from search. On Android, these are achieved using standard Android app links, and on iOS, using standard iOS universal links. When a user searches for your content, they can then find your app. If you have the app installed, it will allow you to link directly to it. When the app launches, it sees the address of the index content and decides which screen to load to show it. It's really as easy as that. You can also use the App Indexing SDK to submit content to the search engine based on how people use your app content. When people use your app, your search position can be improved. With app indexing, you get into the index, putting your app into Google search, and allowing you to re-engage your users.
This is Ask Firebase, a show where we answer all sorts of Firebase questions on whatever medium you ask questions on. We take those questions, we give you answers. It's a show. Let's get into it. Ask Firebase. Take one, Mark. Hey folks, my name is Abe Haskins. I'm a Firebase engineer here in San Francisco, and I'm here to talk to you about Firebase for Unity. If you haven't already seen it, I did a getting started video for Firebase in Unity. It'll be linked below. But in the meantime, I want to talk to you about some of the great questions we've gotten since we released the Firebase SDK into general availability a few weeks ago. Also, unrelated, but if you want to call me Abe, that's great. You want to call me Abe, you want to call me literally anything, I'm okay with it. As long as it starts with an A and has some letters after it, we're all good. Let's dive in. That's not nice. Let's get started with the first question from my laptop battery is dead. All right, first question. On our last YouTube video about Unity, 7Mandara1 asked, can I use this to build out WebGL games that I've developed in Unity? And the answer is no, you really can't. Since the Firebase SDK for Unity is built on the Android SDK and the iOS SDK, we don't have the ability to build out for WebGL or PlayStation 3 or some of these other platforms that Unity supports. You'll find that some of the features do work, and even in the editor, they're stubbed out, so you'll be able to use them and test your code and compile it and everything like that. But you won't get the same functionality you would if you built out the game for the device. Thanks for the question. Next question. On the Firebase mailing list, DeepPixel asked, why does my app report libapp.so cannot be found? This is actually a great question, and it's related to another issue we've gotten on GitHub from Sakura777. He said, why is Firebase app not able to be found? These issues are both related to the timing of when Unity imports the dependencies it requires to run the Firebase SDK. In some environments, you're just gonna luck out and you're not gonna have to deal with this, but it just depends on your specific game and your specific operating system. So what you can do is, one, make sure you're on the latest version of the Unity plugin. We've pushed some changes that should help this for a lot of people. And two, you can go into the assets folder and go to Play Service Resolver, Android Resolver, Settings, and there's an Enable Auto Resolution checkbox. This is just going to do some extra things to help you get those dependencies imported and help control that timing so everything's going to work well for you. All right, and if you do that, your issue should be solved. Thanks a ton, Sakura and DeepPixel. Next question. The next question is one we've been getting a ton. A lot of people want to upload different assets for their game into Firebase Cloud Storage. They want to upload images and text, all of these great things, movies, etc., all those things you need for your game. You know the stuff. They want to upload those into cloud storage and then retrieve them in their game and just, use them in the easiest possible way. The Firebase Unity SDK is really good when you're dealing with these storage assets because you have a lot of control. You can download them as streams or you can download them as a byte array. But you don't have to really do all of that if you're not interested in dealing with those more complex flows. The absolute easiest way to get an asset out of cloud storage, rendered or consumed in your game in some way, is to use the W package and the get download URL async method that we offer. With that method, you'll just get a normal URL. It's a public URL that you can consume and pull down just like any other URL. And the W package in Unity makes it really, really simple to take that URL, download it, and turn it into a material, turn it into an audio clip, even a movie. So any of those assets you upload in cloud storage or your users upload, if they're uploading profile icons or anything like that, you just pull them down with W and you'll be good to go. If you want to find out more about the W package or how it works with the get download URL async method, you can check out our documentation or the Unity documentation. Both are great resources for this. Thanks a ton for that question, everyone who asked it. I appreciate appreciate it. Next question. You guys have no idea how much I spend on conditioner to get this volume. And the final question, the big one we all want to hear about, Cloud Functions. I'm sure you heard at Google Next we announced this awesome thing, Cloud Functions. How does that work with Unity? What can we do with these two things put together? And the answer is you can do like anything. If you check out the repo we have a function sample repo, and this isn't specific to Unity, it's just our general function sample repo. It has 26 different examples of things that functions can do. And every single one of those you could do with the Firebase SDK in Unity with Cloud Functions. And that's because Cloud Functions ties into your real-time database. It ties into analytics and storage and all these other Firebase services that are supported in Unity, and it lets you execute code and change things way back on our cloud so you don't even have to think about it. So if you want a game that interacts with an external API, or you want a game that has some custom authentication that you've brewed up in your awesome game development shack, you can do this with Cloud Functions and you don't have to worry about scaling or anything like that. So you can absolutely use Cloud Functions with Unity, and it's highly, highly recommended. So go check out that repository. It's got a ton of different samples and every single one will work great with Unity. Thanks for the question. All right, everyone. Thanks for watching. That's going to wrap up this Ask Firebase featuring Unity. If you have any more questions, obviously you can leave them in the YouTube comments below, post them on Stack Overflow, tweet them on Twitter with that hashtag AskFirebase, or literally reach out to us in any way. Tweet at me, tweet at Firebase, shout it at the top of your lungs near a Google office. We will hear it. We will answer your questions. We'll see you next time.
Hi, I'm Timothy Jordan, and I've been your friendly developer advocate here at Shoreline Amphitheater for Google I/O 2017. For the past 3 days, we've been checking out all the really cool in-person experiences that you might have otherwise missed if you were just watching the session videos. I hope you enjoyed them as much as I did. And if you'd like to see anything again, check out g.co/io/guide. And hey, maybe next year you can join us here in person. I'm Timothy Jordan, and I'll see you at Google I/O 2018.